sampling theory, optimization technique, multivariate statistics, data science, machine intelligence, uh, network security, multicollinearity, and ridge regression, computational statistics, biostatistics, SAIS 2009, 2012 professor. He have also achievement of the honor and awards, and he शिक्षक शिक्षक गौरव पुरस्कार पुणे म्युनिसिपल कॉर्पोरेशन एजुकेशन बोर्ड in 2011. Yeah, he has guided doctoral degree. I can tell the number here rather than reading all these. 15 people sir has guided as a, I think, yes, doctoral thesis for the 15 students. With this introduction, I welcome Professor Gore sir and to have his invited talk here in this session. Welcome sir. Please come for your session. Thank you very much sir. Thank you sir. Thank you sir.
Thank you. So I will request that please allow me to share my screen because I have modified.
Yeah. Please welcome sir. Please.
Yes. So good morning to all. I'm not going to talk on my own research. I want to raise an issue typically related to data science, because recently data science has become a very good job opportunity for statistics students. What I find is many of our students are not prepared to work as data scientists. So from that point of view, I'm trying to present some ideas for introspection among the statistics community. So let us begin with our own idea about statistics. So historically, statistics was known as a special branch of applied mathematics. Gradually, it became recognized as an independent discipline. But even today, in the 21st century, technology institutes all over the world do not have separate departments of statistics. The department where I learned in Pune was a joint department when I was a student there. The two departments separated in 1978, and gradually most of the Indian universities separated statistics and mathematics. Then came a time when the UGC floated the idea of forming schools of mathematical sciences. This trend also continued for a long time. Now the problem is, even if we have schools of mathematical statistics sciences, we don't see any impact of these subjects on each other, because the job market for every discipline is exclusive and there is no competition between them. The demand for statistics increased due to the development of data analytical procedures and availability of sophisticated statistical software packages. During last 10 years, during the decade, the big data revolution made a huge impact on the job market. Due to the tremendous volume of data growing so rapidly, the computer scientists alone could not cope up with the challenge. There was a new job requirement known as data analytics. And obviously, statisticians were at the forefront for this job. Now, the problem in getting statisticians as data analysts is that statisticians available for the job were not adequate to fulfill the gaps. And as the notion says that nature does not tolerate a vacuum, the corporate houses with huge amounts of data, they had to employ people to analyze the available data before the data became obsolete. Because data also has an expiry date and it has to be used before its expiry date. At the same time, software engineering institutes were more in number and their graduates could not find or could not fit in the job requirements of data analysts. Of invention, so these people, they tried to began to prepare themselves to work as data analysts. So for this, they tried to learn some statistics, they put their computer knowledge, and they started calling themselves data scientists. So what can they do? So data scientists are supposed to be able to handle data of all the types. methods for building models for data, then carry out statistical inference, run predictive analytical methods, produce predictions on the variables of interest. Now, most of these data scientists are computer science or computer engineering graduates. Well, and this is one of the deficiencies the market finds among statisticians. We are not coders, we are developers. However, the lack of understanding of a variety of algorithms, they are not usually able to develop new algorithms. So algorithms have to be developed by scientists, especially statisticians. Now, this is why what we find the trend among the data scientists, they promote tools and technologies that involve more coding. There is also a branch known as machine learning. So what is machine learning? What is the role of it? So when huge amounts of data are available, it is humanly impossible to handle all the data sets. For automation of the methods of data analysis. And the concepts of statistical learning are already available in the form of training, testing, validation paradigm. An additional component is added in the form of automation. This is what forms machine learning. Now the collection of automated, whether supervised or unsupervised, analytical algorithms, machine learning. So it uses the basic concepts of statistical learning. It uses computer science for implementation of these algorithms, and it uses the skill of coding for coding the selected algorithms if necessary. That if there is no ready-made tool, then the programmers, coders have to program. Now, what is the classical statistical learning theory? The classical approach of statistics was information can be extracted from data with one single mathematical operation. For example, the factorization of the likelihood function provides sufficient statistic. Maximizing the likelihood function provides the MLE. The Neyman-Pearson lemma provides the most powerful statistical test. Now, statistical learning theory proposes that there can be more learning if we carry out the same statistical procedure repeatedly. It's possible to learn more by repeating a statistical procedure. This gave rise to many iterative algorithms. Similarly, in classical statistics, we don't have the separation between supervised and unsupervised learning. So the new concept of statistical learning, it introduced these two paradigms, supervised learning and unsupervised learning. Supervised learning uses a target variable to monitor the learning process. And this target variable is used for fitting the prediction model. Supervised learning divides data into two subsets that are called training data and test data. By the contrast with this, unsupervised learning has no target variable, and for the objective is now to partition the data in subsets so that statistical models fit well to each of these subsets. So statistics curriculum still does not introduce the concepts of statistical learning, the two types of statistical learning, and unsupervised. Similarly, resampling. Now, resampling has been around for more than 50 years. A part of major common statistics curriculum. So very few specialized courses may have this idea. The concept of overfitting, underfitting, it must be introduced to students of statistics at the right time so that they can understand these concepts and use them effectively. So what I suggest, for example, we have some pairs like type 1 error and type 2 error in testing of hypothesis. So we should also introduce some terminology to students because these are used in the market, like false positive, false negative, sensitivity and specificity, supervised learning and unsupervised learning, overfitting and underfitting of models, and so on. So they become more ready for the market. The language used in the market, very often known as jargon, sometimes confuses our students. Now, why is this question relevant? The question about the role of statistics in data science by data scientists. But it is not mostly addressed by statisticians. The origin of this question is in the confusion about the discipline called statistics, because many data scientists don't understand comprises statistics. So most of them talk about statistics without learning statistics, whether formally or informally. So many of them even claim, recently I have read even many articles, can become a data scientist without learning statistics. Now, why does this happen? This happens due to lack of their understanding of statistics. At the same time, statistics also must appear
Hello.
Is not audible.
Maybe some technical issue.
Sir has been interrupted, sir.
Maybe
due to
some
some network issues.
network is right.
Network issue. Okay. Okay, then it seems he is disconnected. No?
He may be trying to
Left
reconnect.
it.
Maybe he may be trying to reconnect, sir. Let it 1 minute. Have a wait. No problem.
Okay.
Yes, sir. Sir, please call and inform to her, sir.
Sir. Do you have number, sir?
Yeah, that is what I'm searching.
Yeah. Please.
Isam.
Isam, sir, Isam is not. I mean, I think he's.
Yes, sir. I'll check. Yes, sir.
Third core is biodata. You just verify whether there is a number, contact number, or you got the mail from him. No. So in signature also might be number is there. You please go through it.
Yes, I'm checking, sir.
You check it and send it to me through WhatsApp.
Sir, I've sent, sir.
Center?
Yes, sir.
Okay, right. Thank you. I'll make a call to. He's not lifting voice. Probably he's connecting with
Yeah.
that this phone only.
Yeah, that is the possibility.
Probably he may not recognize that he was disconnected.
Right.
ஒருபோதும் உங்கள் ஓடிபியை ஷேர் செய்யவோ அல்லது உங்கள் அக்கவுண்டில்
Sir, mic on, sir. Sir, please on your mic.
Naveen Chandra, you can
Yes, yes.
make
Yes.
a observation that you can make an observation. I think he's not on the board also even. Am I right?
Acha. Yeah, 1 minute, 1 second. I'm trying also to see.
You just see that he is not on the board also. He was disconnected, it seems.
Right, sir. Right, sir. Right, sir.
Yeah. So what we do is,
Shall we go for next speaker?
yeah, next speaker you make it, sir.
Yeah.
Next speaker is,
So-
yeah, please make it.
Professor K. Muralidharan, sir. Sir, Professor, sir. Sir, are you ready? Hello.
Yes, I am ready. No issue. No issue.
Okay. Thank you, sir. Thank you, sir. Thank you, sir. Thank you, sir. So, due to some technical issue, this was discontinued. So maybe we'll sort out and then we'll see the. Meanwhile, I would like to going to request to Professor K. Muralidharan, sir, to start his session. Before that, I will introduce about him. Just a moment.
Thank you.
So the second speaker of this session today, Professor K. Muralidharan, and his title of the talk is "Some Testing Problem Associated with Power Law Process." So I would like to brief about the professor profile. Professor K. Muralidharan is currently working as professor and was ex-head of Department of Statistics, Faculty of Science, the Maharaja Sayaji Rao University, MSU, Vadodara. And he was also the director of Population Research Center, MSU, Baroda. Also, with his teaching at MSU, he was also an adjunct faculty of IIT Gandhinagar from 2012 to 2015. He has obtained his MSc first rank degree in statistics from Calicut University in 1987, MPhil 1989, and PhD 1996 in statistics from Sardar Patel University, and has completed postdoctoral fellowship in 2003 from Institute of Statistical Science at Academia Sinica, Taiwan. He is an internationally qualified Six Sigma Master Black Belt and quality trained from Indian Statistical Institute, Bangalore. He has about 30 years of teaching and research experience and has guided about 7 research students for doctoral degree. He has more than 130 research publications in international and national journals. His research interests are in the field of static inference, applied stochastic point processes, reliability and life testing, industrial statistics, quality and Six Sigma. He is the coordinator editor of Journal of Probability and Statistical Science published from Taiwan, associate editor of Journal of Indian Society for Probability and Statistics published from India, associate editor of International Journal of Mathematics, Statistics and Operation Research published from Singapore, and associate editor of Investigations in Mathematical Science published from India. He has won number of awards and fellowship, including Distinguished Statistician of India Award 2018 from Indian Society for Probability and Statistics, India, and Commonwealth Academic Fellowship 2011, sponsored by British Council, UK. He was awarded the Best Science Teacher Award in Mathematical Science by Gujarat Science Academy, Ahmedabad in 2017. He was also awarded for Young Emerging Future Leader of Quality and Reliability by Society for Reliability Engineering, Quality and Operation Management, Sweden in 2015. He is a principal member of the Bureau of Indian Standards, New Delhi, since 2008. He has been the Secretary of Indian Society for Probability and Statistics for the terms 2013-14, 2015-16, and Vice President from 2019-20. Yeah.
Next, please.
Yeah, I think. Yeah. Beside publishing the best-seller book entitled Six Sigma for Organizational Excellence, a Statistical Approach, with Springer, he has co-authored a book entitled An Introduction to Parametric Inference with Professor B.K. Kale, and the book is published by Narosa publisher, New Delhi. His first book on statistical method for quality, reliability, and maintainability, published by PHI Learning Private Limited, is a blend of three disciplines, namely management science and engineering, and can be used as a text cum reference book for engineers and practitioners in manufacturing and maintenance area. Professor K. Muralidharan has offered number of consultancy services for companies like Shah Software, Bangalore, Value Labs, Hyderabad, Deepak Foundation, and Deepak New Nitrates, Vadodara, Reliance Industries, Vadodara, TCS, Vadodara, Industrial Jewelers, Bhavnagar, uh, uh, Arcil India, Bhavnagar, and so on. He has mentored about 8 Six Sigma Black Belt projects for industry. He is also associated with many NGOs for quality training and volunteering activities. Professor K. Muralidharan has completed 5 major research projects funded by UGC, TST, MOHFW, and NHRC New Delhi. Apart from this, he has guided many students' projects on statistical methods and Six Sigma. He was invited speaker in over 140 national international conferences and has organized a dozen conferences and seminars. He has chaired number of conference, seminar, workshop sessions, and was a resource person to many UGC refresher courses programs at various universities across India. He had visited number of universities in India, Taiwan, UK, Russia, and UAE. So with this brief introduction about Professor K. Muralidharan, now I would like to welcome Professor K. Muralidharan, sir, for his talk this session. Please, sir, please welcome, sir.
Thank you very much. I'm so happy to be a part of this prestigious conference in honor of Professor C.R. Rao. Also thankful to Professor Tirupati Rao for his kind invitation.
Thank you for accepting our invitation, sir.
Thank you, it's my pleasure, sir. And Naveen Chandra for his nice introduction about me. Okay, so let me share the presentation first of all. I hope I can share right now.
Yes, sir. Yes.
Okay. Okay. So I am on the slides show mode. Can you see, all of you? Can you see?
No. Now coming.
Okay, it will come.
Yeah,
it will
yeah.
come. Okay. So
It has come now.
this is actually,
Yes.
okay, fine, sir. Now my topic title is some testing problems associated with the power law process. Now this is actually an application of stochastic process, actually applied stochastic process models. This is one of the area of my research, and some of the a part of this presentation has already presented in many forms, actually speaking, and there is a chapter also available in one of the book called System Reliability Management Solutions and Technologies. So that chapter includes a very detailed account of power law process. Now another interesting, this was published by CRC Press 2 years ago. Now this is also available online for reference and purchase. Now this is actually an application of repairable system models. We know naturally we have two types of systems, repairable and non-repairable systems. Most of the time we discuss our the problems with respect to non-repairable systems. Non-repairable system means once the system, the item fails, you cannot bring back to the service. That's the meaning of non-repairable. Repairable systems are generally systems which are catering many components and many parts and many things, either arranged in the form of parallel way or series or hybrid form, etc., etc. So this is one of the application of repairable systems. So this is the contents of my presentation, and most of the time I am in fact interested in the testing part. Inference part,
Yeah.
when we talk about, generally we come up with the estimation and many other related things also. But I will just center my attention only on the trend testing and the testing of parameters, etc. So when you say that it's a repairable system, definitely we should introduce the non-homogeneous Poisson process, because we the usual way of defining homogeneous Poisson process. The usual. When you talk about stochastic process in the class, we usually talk about homogeneous Poisson process. So the difference here is that if the lambda of t, we call in the repairable system, we call it as intensity function, and in non-repairable system, we usually call it as hazard function or hazard rate function. So it is one and the same. So the difference here is it is always depends on time to event, the time of its occurrence. The failure depends on the time of its occurrence, and that's how it becomes a non-homogeneous Poisson process. So the intensity function, as I told you, in the non-repairable system, it is called hazard function. So here we call it as intensity function. So it's actually depends on time. So you can see that it's going to be limit delta tends to 0, probability that a shock happening in between t to delta t. Delta t is a small time period. So t to delta t divided by delta t. So it's the rate actually speaking. Okay, so that is going to be beta by theta, t by theta, whole power beta minus 1. If this is the case, we call it as power law or Weibull intensity function model also. This is another model, because when you talk about the non-repairable system, so we always talk about the Weibull density function with the hazard function looks like almost the same. But understand, one has to understand that this whole process is depend. The time to event happening depends on time. And power law. There are many intensity functions available in the literature. Now it's very huge now. Intensity function is based on the power law process or the Weibull intensity function. So this is therefore, because of its flexibility in finding estimates and testing, etc., a lot of best characteristics are possible for power law process. So that's the reason why this is best considered to be one of the best non-NHPP model. So you have the realization, say T1, T2, etc. Tn are the time to failures of the system. Then the likelihood can be written with the lambda ti in known. So it's very simple. You have to simply plug in that the likelihood function in that form. So lambda t you just replace by beta by theta, t by theta raised to beta minus 1. So you can have various forms of lambda t in non-linear form. Can be logarithmic, exponential, can be any other form which takes care of all issues like maintenance also, repairability also, and there are many other availability also. So we have studied all those things. So I'm not discussing. I'm very focused on only the power law process intensity functions. So here, if you can see that beta equal to 1, the process becomes homogeneous Poisson process. So that's the interesting factor of this particular model. 1, it models deteriorating system. Beta less than 1, it provides a model for reliability improvement, and that's what we always want it. Okay, so beta parameter is very, very significant here, and yes, these are some of the exercise one can try to derive the conditional densities, marginal densities, etc. And all these densities are very important for developing testing and the inferential aspects of the parameters. Okay, so if you see the maximum likelihood estimators, we can get in close to form expressions like theta cap is Tn beta raised to n, beta by n, and beta cap is actually n divided by. So it's better to find beta first, then get back to theta cap, because theta cap involves beta cap. And for failure truncated data, because you know all the failures happening at up to n, so the Tn. So if you are truncating at a time point, so you get a time truncated data, and accordingly the estimates will change. So that instead of Tn, that becomes T actually speaking. So that is how the change is happening here in failure truncated data. Now there are many interesting properties for the estimates here. So the vector beta log Tn by Tn minus 1 beta log Tn by Tn minus 2 etc. is distributed as order statistics of a sample of size n minus 1 from exponential distribution with parameter 1. Similarly, property 2 is also another interesting property which can also be used for constructing test statistics for beta. So 2n beta by beta cap becomes a quantity 2 beta, so its distribution is again chi-square. Similarly, 2 times Tn by theta whole power beta has also chi-square distribution. And this is the estimated variance covariance matrix of the parameters. So we have usual I is equal to I theta theta, theta beta, beta theta, beta beta as the variance covariance matrix. So if you can get it in a closed form, but it involves gamma, digamma, trigamma functions, etc. If you go for higher approximations, Gaudoin in 2006 has given based on, it's actually the same expression, the second expression, which is simplified based on the first order approximation of gamma, digamma functions. Now, so we have tried with the second order approximation also. So it's going to be a very big, long expression actually. I am not going here. Now, confidence interval we have variance also available with us. So large sample confidence interval can be easily suggested. So the 100%, 1 minus alpha percent confidence interval for beta is shown there, and similarly for theta is also shown there. So W becomes the theta cap by theta. It's kind of a pivotal quantity kind of things. Now, since it is a process, because we know every failure depends on the previous line. So suppose we have n realizations already, can we suggest what is going to be the n plus 1th failure or n plus 2th or n plus mth failure? So this can be found using this particular probability density function. So this involves some mathematical calculations, so I am not showing that. So this is the expression for generating future observations from the process. So f of Tn plus m given Tn. So given Tn, the nth realization, what is going to be the n plus 1, n plus 2, etc., n plus m? This can be found using this one. And this was also studied in detail along with my student and my colleague. So that is also appeared in one of the important journals. And with this also, based on this density function also, you can suggest many interesting characteristics and properties based on the parameters. So 2 times Tn plus m by theta whole power beta follows pi square. Then the second result 6. Again, beta distribution with the n and m. That's very, very interesting result, actually speaking. And we have all the derivations for all these, characteristics and results. So we are not showing here. You can see that result 7 involves a lot of other quantities. No, it also involves gamma, digamma functions, etc., etc. And involvement is when even the presence of all these quantities makes the results very interesting. And these are some of the simulated results based on the for various combinations of n and m. So the future samples are generated. So when m equal to 0 means the estimate based on the complete sample up to nth only. So when m equal to 1 means the next sample. So given n realization, what is going to be the 11th realization? That's what the way it should be read. So n10 and m equal to 1 means that you are going to generate the n plus 1 based on the n plus 1 realization. Given n realization has already happened, what is going to be the estimate of beta and theta, and with their corresponding lower and upper confidence intervals. So here is the exclusively for that. The previous one includes the complete as well as the future one also. This is exclusive for future samples, etc. Here is some of the real life examples. It's very interesting to see. Okay, so you can see this is a very important example discussed many often in stochastic process modeling aspects. So you can see that beta cap is estimated to be 1.655. So it is more than 1. So definitely it is going to follow a non-homogeneous Poisson process, and we have found that PLP is the best model for this one. And this is another example discussed in Black and Richter 1996. Okay, so beta cap is going to be 0.4831. So it's a good system. It's a good system. Improvement is seen there because beta cap is less than 1. So that's a good one. So whatever may be the value of theta, so we are interested more in beta cap in both the examples. Here is another example discussed in 2006 by Ruggieri. So they are based on different types of corrosions happening in different components. So galvanic type of corrosion, natural type of corrosion, stray currents type of corrosion, etc., etc. So we have done all kinds of model fitting based on homogeneous Poisson process as well as non-homogeneous Poisson process, and estimates of theta and beta are okay. So you can see that 2 cases. First, in the galvanic and natural, the beta is going to be more than 1, and the last one is going to be good. So 0.4981x. Okay, so presence of beta is very, very important. Another important example discussed in the repairable system model is Kumar and Club data on hydraulic system of LHD machines. You can see that many times it is even in not all the models, although beta is slightly more than this. Say for example LHD 20 for example, beta LHD 11 for example. So beta is very close to 1. You can say 1.31 and 1.22. It's not too big, too larger than 1. So PLP is not accepted in the when we done the goodness of it test. Actually, the test for trend. So what do you mean by trend? Trend means the way the failure patterns occurs over a period of time. So the intensity function we have already defined as a function of t. So we test the h0, lambda t or lambda x as a constant. So when you say constant means it's exponential. So that means usual Poisson process, homogeneous Poisson process. So actually the testing h0 becomes lambda t a constant against lambda t is monotonic increasing or decreasing, and this is where the beta comes into. So this is a general testing where you may call it as this not exclusively parametric test. So this is semi-parametric type of testing actually speaking, because we are not very specific about parameter beta or theta in this case. There are many tests available already in the literature to test for trend. So we'll discuss that also. So why we need testing for trend? Because we have to see whether the system is improving or deteriorating over a period of time. What is stationarity? Quite often we discuss this stationarity aspects in time series data, because time series data is also a stochastic processor based application based data where time dependence is there. So stationarity is a very important concept in time series as well as in stochastic process. So to test whether there is stationary over a period of time, also we can do using trend test. And similarly, successive interval times are independent or not. This is another interesting thing. Because if there is independence, we can model this using the usual non-repairable way. So all IID observations you will get. So here the importance here is, and we don't want that to happen. We don't want that every time the data follows IIDs more. We want that it should be dependent on some time. Okay, so that is the importance of test, and we can even test whether it is linear, exponential, logarithmic, etc., etc. There are many procedures available in the literature. You can see the graphical procedure. We will discuss that. I will show you how quickly how it can be done. Goodness of fit test is as usual, Kramer one Mises test. Then total time test plots. These are a very famous tests, very usually used by people working with repairable system models. So they are already available there. So the other three for a unconditional test procedures, conditional test procedures, large sample procedures, they are our contribution actually. Okay, so I will just focus more on that. Okay. So graphical procedure is very simple. What you need to do is, you know what is NT stands for number of failures happening from 0 to T. So just take the ratio T by NT and plot this along y-axis against T on the x-axis on a log paper. T is going to be a straight line. We can understand that there is no trend. So this is the best way of. So here you can use total time test. Also you can compute if you take all the, so that's what is usual way of doing. So please refer to some text book or reference book for that. So it's a large amount of discussion is available for total time test procedures, etc., etc. Here is a real life data which even I was present during the data collection in Visakhapatnam steel plant. So we have about 1702 data. So this is all about the maintenance related, all types of maintenance, operational, mechanical, technical, failure, service, everything related data sets of their tripler machine actually. It's a tripler machine, tripler wagon, tripler machine actually. So a very big kind of vehicle. So the failure often have to take place actually. So it can be due to operational, mechanical, technological, services, maintenance, etc. We found from the data that it models exactly a very good model for power law process. So we have first plotted to see whether there is any correlation between the I-1 test time between failures and the ith time between failures, and we could see that there is a high correlation. You can see as from the graph, and we also fitted. So after initially there was some zigzag kind, there was a change. So in fact, we even investigated the case of shift point estimation in the power law process also. So I'm not referring to that paper here. So we have that paper also published in the literature. Please refer to that. Okay, so in the first 1,000 hours, you can see that there's going to be a kind of change. After that, it is going to be a linear. But interestingly, that you can see that beta estimate is coming out to be beta is 1.06, so it's perfectly linear now. So it's going to be homogeneous Poisson process. Although there is a high correlation between the I-1th time between failures and the ith failures. So we have investigated many other things also based on that. Now this is another test which is also famous, Kramer-1 test statistics. So this is how you can compute. And the above example we have computed CM square is 0.4867. And here in that case, PLP is accepted. So goodness of it, the PLP is accepted. This is Laplace test, again, is available in the literature. And this kind of test statistics is very good for non-homogeneous Poisson process with exponential intensities. And here is modified Laplace statistics. Again, a slight modification of the previous one. This was introduced in, by Louis Robinson in 1974. Handbook, I'm sure most of you are familiar with. It's a very, very famous test statistics, M, 2 times summation log T and by. And military handbook, yes, most of the times work, but in some of the, if the failure pattern is uncertain completely, then military handbook text will never work better. But generally it is found to be that for an power law process intensity like lambda T. This is also another form of viable intensity, theta beta times T raised beta minus 1. It works sometimes better. This was another test statistics introduced by us, Jani, Shanu, by my other 2 mentors, slightly an old one. Okay, now we have found altogether a different way. Okay, so we have used, we also could get the expected value and variance value under H0 as n minus 1, and the variance of Q is 4n square n minus 1 by n plus 2. This is also working well best for many broad range of intensities actually. Now let us now be specific about the parameters. Okay, the previous test for all intensity, test for trend, we are testing the lambda T as a function of T. So that itself is tested against whether it is constant against non-constant, not constant. So now I'm going to discuss about some of the tests which are specifically our contributions recently studied by us. So to test H0 beta equal to beta naught against H1 beta greater than beta naught in the presence of nuisance parameters. So nuisance parameter become theta here, because in conditionally we have seen that some of the densities, marginal and conditional densities we have derived. So and those conditional densities removes the effect of parameter theta. So the nuisance parameter effect in that person is completely gone. So with that, based on that, we have introduced the test statistics for the testing beta equal to beta naught against beta greater than beta naught as -2 times summation log ui less than equal to C alpha. That C alpha is such that probability of that usual under H0 it should be equal to alpha, the usual condition. And here, interestingly, ui is actually Ti by Tn raised to beta, so that can be taken as a pivotal quantity, and that's the reason why it is free from the parameters. So it's following chi-square degree distribution only. And this is what uniformly most powerful, because the H1 is beta not equal to beta naught. So this test will reject H0 if Vx is not in element of C1 and C2, where C1 and C2 is shown on the screen. Okay, so this also we have published slightly long back. Another large sample test based on for the parameter beta equal to beta naught against beta naught equal to beta naught. This is where we are introducing the importance of Fisher information and various covariance metrics and all those estimates based on the information functions. So we have found these kind of tests are, even we are going to have a Rao's test also. Although this conference is in honor of Professor Rahul sir, I found this is the best place to present this particular kind of paper, where we have studied a Rahul's test, and we have found many modification also for Rahul's test, scores based test, and we have found that.
Sorry for interruption. So time for summarize, sir.
Okay.
Time.
Okay.
Yeah.
No issue. Don't worry. I need only few.
No problem. Please.
Okay. So here is another form of the above test statistics where I beta is substituted. Again, I beta evaluated to estimate beta. You will have another test statistics called B. Here is another test statistics again where we have used the first order, second order. This is actually based on score test, unconditional score test of the same Professor Rao's score test. So this is how the test statistics looks like. Interestingly, most of all the time we are getting the test the critical value is based on chi-square distribution. So here is C is another form of the modification of the previous test. And here is another interesting concept which was again introduced by us. So you have the information function theta beta as shown. Now, of course, we are treating theta as the nuisance parameter. Then how do you get the information of beta? So this is how we can calculate the information of beta in the presence of theta. That is I beta beta minus I beta theta, I theta theta inverse I theta beta. This is what is used in the score function test, large sample test also we have used. So we have the modification D, equation D, then another modification, then for approximate, with some approximation, we have another forms, etc., etc. So all these tests have been calculated for power computation. You can see beta is taken considered from 0.4 to 3. So we have all the equations, all those main equations, and the sample size 10, 20, 30, etc. So you can see, and BE in the table, BE stands for Bain and Angel Heart test. That test is considered to be one of the best. So far at that time of our research, that is considered to be one of the best. And you can see that here, equation C is going to be give the best power, that power better than the existing test. Okay, so I hope I will stop here, because I have so many other things, since the time is up, I will have to stop, because I always concerned with the time, so very, very important. So I don't want to be too much ahead of it. Okay, so here are some of the references and yes, references. Okay, thank you very much.
Thank you, sir. Thank you for your nice talk. And I can summarize here. Sir has started his journey from the reparable and non-reparable system and non-homogeneous Poisson process, and sir has covered the power law intensity, the concept of power law of intensity function, and also very nicely sir has told there are several intensity functions where our power law function is one of the simplest functions which can be used very nicely. And sir has also discussed about the several properties of power law function, and also the problems sir had discussed about the future sampling and estimation problem from power law function, and also sir has discussed about the how to observe the future failures about the n plus 1, n plus 2, like that. And sir has given also good number of illustrative examples to understand the problem very well. And sir has also discussed about the trend of the test for the trend procedure for check of the trends. Also, it's very interesting for the younger generation who is doing research. It will be helpful for them. Sir has finally discussed about the testing of hypothesis, the problem with the illustrative examples. Sir, it is very a nice lecture, sir. It is definitely helpful to the younger generation who is listening. Surely, I also very much motivated with this your lecture also, sir, since I am working in reliability theory area. So thank you very much, sir, for a very nice lecture.
Thank you very much.
And on behalf of the organizing committee, I thank you very much, sir, for your talk.
The chairman is requested to entertain one or two questions, sir.
Yeah.
Okay.
Now floor is open for some questions. Now, please, some questions from the audience side, participant side.
Right.
Okay.
Then there is no interaction. Then
Yeah. Thank you, sir. Thank you very much, sir, for your valuable time and sharing your thoughts.
My pleasure. Thank you very much. Thank you.
Now,
I just wanted to congratulate Professor Muralidharan for this excellent
Thank you,
address.
sir.
Lakshman Rao from Chennai.
Thank you very much, sir. Yeah. I know, sir. I know, Professor Lakshman Rao, sir.
I know. You're on your camera, sir.
I have a small comment.
Okay, please.
Professor Muralidharan, your talk has been excellent. Even though testing of hypothesis problems are good old and conventional things, nowadays it's a hot topic which must be very much useful in data science field. Thank you for your presentation.
Thank you very much. Okay, thank you.
Thank you, sir. Thank you very much for comments. And now, today is the third talk. I would like to invite Professor Rahul Gupta, sir. Professor Rahul Gupta, sir, is here. Hello, sir.
Yeah, he's there.
Yeah. Very good morning, sir. Very good morning. You are welcome for this talk. Now, I'd like to introduce about you something.
Rahul ji, are you there? Rahul ji, you are appearing on the dashboard, but Any issues are there?
Hello, Professor Rahul Gupta, sir. Hello. Hello. Hello, sir.
He is appearing on the button, just he is again disappeared. He's coming and going. Let us wait.
Yeah, no problem. Technical issue.
In that case, we can, if he's ready, okay. Otherwise, we have to go for next speaker. That is the problem. Who is the next speaker, sir?
Okay, just a moment. I will see and then tell. Professor Shila Mishra, madam.
You just call them. If they are available, then you go for it, sir. Yeah, madam.
Professor, just a moment, sir. Professor Rahul Gupta, sir. Hello, Professor Shila Mishra, madam.
Yes, sir. I'm there. Very good morning.
Very good morning, madam. Very good morning. You are very warm welcome to the international conference, madam.
Madam, on your camera. Madam, on your camera, please.
Okay.
Pop up.
So before requesting to Professor Shila Mishra, madam, once again I would like to just call Professor Rahul Gupta, sir is available here. Professor Rahul Gupta, sir. I think sir is not here. So now I would like to request Professor Shila Mishra, madam.
Welcome, Shila Mishra, madam. Welcome. Right.
Madam, you are welcome.
Yes.
May I request you, madam? May I request you for your talk now?
Yes,
Hello?
sir. Yes, sir.
Okay.
Thank you so much.
Okay,
Thank
madam.
you.
Okay, madam. It's our pleasure, madam. Just a moment.
Yes. So, very good morning to all the esteemed colleagues and the distinguished statisticians.
Shila Mishra, madam.
Yes.
Naveen Chandra has to introduce to.
Okay. Thank you, sir. Thank you.
Yeah, what next? Hello. Sir, I am back. Actually, the internet connection lost.
Hello.
Rahul Gupta arrived now. Just.
Yes, sir. There is a power disruption.
Are you ready?
Are you ready, sir? Are you ready,
yes,
sir?
Sir, I am ready.
Okay, sir. Okay, sir.
Madam,
Madam, sorry.
Okay, no problem. I can wait.
Excuse me, madam, because of this technical issue. Sorry
No,
for it.
I can understand. No problem. Thank you.
Sir, Rahul Gupta ji, on your camera, sir.
Okay, sir.
Right, so that we will be able to understand.
Just a minute.
Yeah.
So today's third speaker is Professor Rahul Gupta, sir. And the title of the talk is today on some inferential procedures for the reliability function with Nakagami distribution. So before requesting him, I would like to welcome sir, and I would like to introduce about sir. Professor Rahul Gupta, sir, Professor of Statistics since 1st August 2011, Department of Statistics, University of Jammu.
Naveen Chandra.
Yes, sir.
So your presentation is not coming. Sir,
Okay. Just a moment, sir. Just a moment.
Rahul sir already presented.
Okay, I have stopped now.
Just a moment, sir. Just a moment. Wait, sir.
Rahul sir, just stop sharing and once again share
No,
the.
I am sharing, sir. I am sharing.
Okay.
Is it visible, sir? Is it visible, everybody? Hello?
Just a moment. Yeah.
Yes, come on.
Same.
It is, yeah, acha. Okay, sir. Welcome, sir. Professor Rahul Gupta, sir. And Professor of Statistics since 1st August 2011, Department of Statistics, University of Jammu. Sir was also ex-dean, Faculty of Mathematical Sciences, University of Jammu. Sir was also former head, PG, Department of Statistics, University of Jammu. Sir was former Chief Librarian, Dhanvantri Central Library of Jammu. Also, sir, post Director UGC, HRDC, University of Jammu. Sir, having teaching research experience of 26 years plus, and till date at PG level or higher education. about 40 research publications in recognized journal Scopus Index, UGC Care, produced 15 PhD scholars under him and 9 MPhil students till date. Attended about 30 international national conferences in India and 6 foreign countries for participant, invited talk, paper presenter, etc. Sir है UGC member. Sir is also UGC member of DRS SAB Advisory Committee for University of Kolhapur, Maharashtra, and University of Kolkata, West Bengal. With this short introduction, I would like to request Professor Rahul Gupta sir. So please deliver your talk. Please, sir. You are welcome.
Thank you, Dr. Naveen Chandra, for your nice introduction and my entry into the conference. And first of all, I would like to just a minute share.
All the distinguished guests, you are all are welcome here. Those who join late, welcome all. Please, sir. Please, sir. Please continue, sir.
Okay. First of all, I am thankful to Professor Tirupati Rao Padi for giving me a great opportunity for this interaction, and I am really obliged, sir. I really feel obliged. Now let me share my screen. As mentioned, the topic. Is it visible now?
Yes, yes.
So the topic of my today's talk is on some inferential procedures for the reliability function of Nakagami distribution. So it's a very important distribution with a lot of applications. So I just diagnosed this distribution and have produced some results for dissemination in this conference. So the overview would be like this. The first I'll give a brief introduction, then some estimation.
Sir, can you little bigger slide? Is it possible your side, sir?
Okay, just a minute. Now is it better?
Yeah, good. Very fine, sir. Very fine.
So these are the topics step by step where I'll move with this presentation. First is the point estimation cases, then confidence intervals, then some problems of testing, and then the simulative study and some examples, all related to Nakagami distribution. Okay, the introduction and preliminaries. So this paper is on the reliability aspect. So most of you are already aware, but some of you may not be aware. Reliability function is the probability that system performs its intended function without any failure at time t. So if we suppose the lifetime of an item or any system denoted by the random variable x, then the reliability is RT. That is probability of x greater than t. Another important aspect which I have touched is the stress and strength model. That is denoted by P, and its measure is probability of x greater than y, where x will represent strength, random strength, and y will represent random strength. So many researchers have done quite a lot bit work on these topics. For some review, one may go to Pug, Basu, and all these mentioned people. But my approach is slightly different, and I'll explain the details now. Yes. In this paper, a very important distribution, Nakagami distribution, is taken into consideration, which is most useful in communication engineering. It was Nakagami who proposed this distribution, which models the fading of radio signals by naming as Nakagami M distribution. So this is PDF, where alpha and lambda are two parameters. Alpha is the shape parameter, and lambda is the scale parameter. And I have also given its CDF, cumulative distribution function, and its reliability function. can be seen from equation 1, 2, and 3, just to make you aware of this distribution. This is its form. It's CDF, it's a royalty. The failure rate of Nakagami distribution is also mentioned in equation 4. This is the failure rate, instantaneous rate. And I would also like to tell you that it has relationship with other distributions, or other are some part of this distribution, like we can derive those distributions from this. If we take the shape parameter to be 0.5, then the Nakagami distribution reduces to half normal distribution. And if we take the scale parameter to be 1, it becomes Rayleigh distribution. And if a random variable is distributed as gamma with shape k and scale lambda, then the square root of that y will follow Nakagami distribution. And moreover, there are many other. Fourth one is that if z follows chi-square with parameters 2 alpha, and 2 alpha is an integer value, it should be integer valued, then square root of lambda upon 2 over z is again a Nakagami distribution. Various literature can be seen to find its application in hydrology, multimedia, data traffic over networks, medical imaging studies, in modeling of seismogram and envelope of high frequency. Okay. The first is a case of point estimation. In this case, we assume that the shape parameter is known, and that the likelihood function, using the likelihood function, we have obtained the first result which we have obtained is the UMVUE of lambda k, lambda raised to power q. So lambda is a shape scale parameter, and we have obtained the UMVUE for lambda q. Q can be negative, q can be positive. This is the value.
So Lakshman Rao sir, please, you are also presenting. Please stop presenting because it disturbs the presenting by our speaker.
Okay.
I request Professor Lakshman Rao sir, please stop presenting.
Yeah, no, I'm not doing anything. I'm just listening.
Okay. Anyways, should I continue, sir?
No. There is some screen. Now you share, sir. You reload your presentation.
Okay. My content is not coming. Is it coming? No.
No, not coming, sir. It was coming, but now coming. Yeah.
Now it's coming?
Now coming, sir.
Okay, I'll just maximize it.
Yes, sir. Yes, fine, sir. Very fine.
Okay, so for that Nakagami distribution, this is the UMVUE of the reliability function, which depends on the incomplete gamma function, beta function. And from this, we can also find the result using the corollary, as you can see in the corollary, for the reliability estimate distribution for which when alpha is 1. And as I told you, when alpha is 1, the Nakagami distribution converts to half normal. Then I have also obtained the UMVU of sampled probability density function at any specific point x, which is this equation 9. This is also its estimate. So this is quite useful these days. Then about the stress strength reliability, again, we assumed probability of x greater than y is the stress P, is denoted by P, which is the stress strength, and we assume two variables x and y with PDFs, both for following Nakagami distribution with different parameters, alpha 1, lambda 1 for x, and alpha 2, y, lambda 2 for y. And equation 10th and 11th give the PDF, and then we, after drawing a sample from both the distributions and denoting S as sufficient statistics for summation xi square and T as sufficient statistics for summation y for both the distributions respectively, the UMV for P comes out to be this, the theorem 3, and also obtained the UMV of P when alpha 1 or alpha 2 is 1. Both are 1. is given. That is this. So it's a sub. These results come from the main results. Then we have obtained the MLEs of lambda Q, RT, reliability, and stress strength under the assumption that alpha is known in the following theorems. So MLE of lambda is obtained, and then using the one-to-one property of MLE, MLEs of lambda Q and RT are also obtained. And the MLE of sampled PDF is also obtained with the help of theorem as a corollary. And the MLE of P, the strength model, is also obtained. Besides this, moment estimators are also obtained, for which first we obtained the moment density function, and from that, using the moment method of estimation, we have obtained the moment estimators for lambda, and also alpha m hat of lambda is obtained by the solution. Actually, lambda m MLE is easily moment estimate is easily obtained, and for the moment estimate of alpha, we get a the result, the likelihood. This what we call likelihood equation is a closed form. Is not a closed form, so we have to find the roots of the equation, and which was done by using our software. And later in the simulation, we will see the results. The other case is that when the shape parameter is unknown. The earlier was when it is known, it is now unknown. For that also, we have obtained the MLEs of alpha and MLE of lambda. These are the likelihood equations. Was needed there, and MLE is given by solving the following equations. It depends on a polynomial function of order 0. This is the usual mathematics. Looking more. Then the MLE of reliability measures were also obtained. The first was RT. RT was obtained, and the MLE of this is the case when shape parameter is unknown, and MLE of the PDF was also obtained. And MLE of P, the strength model, was also obtained. Besides, asymptotic confidence intervals were obtained using the variance covariance matrix of the MLE of parameters. The asymptotic covariance matrix of the joint parameters is the inverse of the following. Fisher information matrix was required and was used. So although it is very cumbersome to the exact distribution of the MLE, the alternative is to use the observed Fisher information matrix, which is this. And we observed that, and using that, we obtained the confidence interval, which was obtained as 28, 29. Coverage probability was also mentioned, and asymptotic confidence interval based on log MLE has better coverage probability as reported by Meeker had given a significant result, but this asymptotic confidence interval based on log has better coverage probability as reported by this. An approximate CI for log alpha and log lambda are also obtained, and these were the confidence intervals for alpha and lambda. Now the last part is regarding testing of statistical hypothesis. There are 3 types of hypotheses were considered. First 2 are regarding lambda, and the third one is regarding the stress strength P. So for testing the first hypothesis, we took the help of likelihood ratio test by finding the maximum of the likelihood function under H0 under the entire space, and using the conventional methods, the likelihood ratio test was obtained, where critical region depended on the chi-square distribution, and we obtained the values between which the critical region lies, or the significance, or the region to find the significance of the hypothesis. The second hypothesis also, this is the way how we obtain the critical region, again depending on the chi-square distribution. And it can also be seen that for 2 independent random variables, when alpha 1 is alpha 2 is same or equal to 1, in that case the strength model is lambda 1 upon lambda 1. This relation also helped us in testing this hypothesis. P is equal to P naught, again the third hypothesis. So using this, we also obtained under H0, as we have the estimates of lambda 1 as lambda 2. Using that, we have the likelihood of lambda 1 as this, and using again likelihood ratio test, maximizing because likelihood test depend on the MLEs. So we obtained this, and using the F statistic, the critical region was observed. Now the simulation part for acquiring the performance for of lambda q and for moment estimator and MLE, we generated 1,000 random samples from different sizes and 20 to 60 and alpha different values, and we computed average lambda q hat and lambda q plus there. We obtained corresponding average biases and mean square error and approximate 100 confidence intervals, and which are I have given in the future table 1, table 2, table 3, which will give you the results. These are the UMVs and MLEs of lambda q for different values of alpha. Average, it is giving the average mean square error. It is giving the confidence interval, bias. So these are the results. Regarding the UMV and MLE of RT, again simulation was performed, and these are the results. Where you can see that the performance of MLE of reliability is better than the UMV of reliability. This is the good result, new result. And performance for estimators is decreasing with the increasing time as the mean square values are increasing. Estimators tend to perform better in the large sample sizes, which is universal. So in the then regarding the moment estimator also, we drew the conclusions and obtained them. And moment estimators MLE of lambda are equal, and both the estimators as functional sufficient statistics. So both MLE are equally efficient. This can you see this table? Compare it with moment MLE, both are equally efficient. Then UMV, UE, and MLE of P for this, we again took how well the P performs. 1,000 random samples were generated, and these are the results. And it reveals that MLE of P gives better estimate than UMV of P for all combinations of lambda, the parameters scale and say both. So these are the results. And we also plotted the estimates of PDF, and we found that the estimates of PDF also fits well to the actual model. The same in both scale and were unknown. Again, we performed this generated samples using R, and results were obtained, and we could finally observe that all the estimates can be seen validating the theoretical results obtained. And for hypothesis testing also, we generated random sample and critical region, and that was seen, and it was enough evidence could be found through simulation also to reject the null hypothesis at 5% level of significance. So for real data set also, we performed the same procedure, and the results were found to be incompatible with the Nakagami distribution. Same for Y for strength as well as stress model, and we took the data of what we call Dastir and Muhammad, who use the data to analyze and compare in the case of weighted Nakagami distribution. So that was good for here also. These are the plots of MLE estimates for X and Y, where X represents stress and Y. And you can see in both the case, survival is very high at initial time, but as time increases, survival probability goes on. It's in fact a fact also. So finally, I conclude that this paper consists of estimation and testing procedure of reliability functions of Nakagami distribution. A new technique to obtain a UMV, MLE, RT, and P has been used. Our method of obtaining MLEs and UMVs of RT and P is simpler to the existing methods. Moreover, in our approach, we do not require the expression of these parametric functions. UMVs and MLEs of powers of alpha, lambda, RT, and P are obtained. Moment estimators of parameters are also obtained. Comparisons have been done under different setup of parameters using simulation. MLEs and MEs are all seen to be equally efficient for the estimation, as both can be seen as functions of sufficient statistics. Testing of different hypotheses performed. Real data analysis using two sets has been given. In future, Bayesian estimation can be done the parameter distribution, and also we can compare the performance of the classical and Bayesian estimate technique, find the best suited one for the estimation. One of the interesting topic for future studies is to develop the sequential and simultaneous testing processes for the distribution.
Sir, sorry for interruption, sir. Just please summarize. It will be.
But that's all. That's all.
Yeah.
That's
Thanks.
that's why I'm giving my conclusion. That's
Thanks,
all.
sir.
My time is over.
Thanks, sir. Thank you very much, sir, for your nice presentation in time. That's very good. Very good.
Thank
Sir,
you, sir.
now the floor is open for the discussions and any questions from the participant side, please. Yeah. Hello.
Sir.
Yes.
Sir.
Yeah.
Yes, Rahul.
Srinivasa Rao, sir. Professor Srinivasa Rao, sir. Yeah, please.
Yes, sir.
Good morning, sir. Good morning.
Good morning, sir.
Good morning.
You did very nice presentation, sir. Rahul Gupta, sir.
Thank you.
Yes, sir. And can we compare the different methods of estimation like least square percentiles and other type of estimations in the stress strength? Is it possible for this?
Okay, for stress strength.
Yeah.
You're talking that methods of estimation comparison regarding strength.
Yes, sir.
Actually, this is a good idea. We have not tried yet, but definitely there is a way out, and some of our future project will definitely try to compare the stress strength model using different methods of estimation. That is what you want. It's a good idea. We can think over it. At present, we couldn't do it.
Yeah,
but definitely there may be a way out.
Yeah. Okay. Thank you, sir. Thank you.
Okay.
Okay. Balakrishnan sir, Balasubramaniam sir, please.
Yes, sir.
Yes, Balasubramaniam sir, please ask the question.
Sir, this is Vishwanathan. Can you hear me?
Yes, sir. Yes, definitely.
Sir, this is regarding the concept of your UMVU derivation initially for the distribution parameters. Whether the UMVU you have derived, is it through something like Rao Blackwellization, or is it concept associated with say uncorrelatedness with unbiased estimators of 0? So we have different concepts. So which way you have derived your UMVU?
I think we have done it using the complete and sufficient statistics, the Lehman-Chaffee results.
Yeah, Blackwellization.
Yeah.
Okay. Okay, Professor. Thank you. One more thing is about when testing, you are saying that the most powerful test exists when alpha is known and when you are testing for only lambda. What happens if
in one case?
In one case, one of the three cases, so to say. Say when both alpha and lambda are unknown and you are going to test it as a vector, do you have any UMP test for that?
Yes, definitely. We have a UMP test. We have derived that test.
In all the three cases, you are fixing alpha.
Okay. That is a quite a little bit complicated thing. That also needs to be tried when it's a vector. Both are unknown. You mean when both are unknown?
Yeah, exactly.
That needs to be given a try. That again, same problem. We have to look after it, and presently it is not possible.
Okay, sir. And finally, your claim is UMV is or MLE is better than UMV.
MLEs are better, but
as a parameter, we have a very classical counterexample to disestablish the UMV UE. In fact, certain UMEs they fall out of the parameter space. That is also there. But when we have a real-time thing associated with reliability and we have a UMUE and it is working worse than your MLE, can you suggest what is the reason behind it?
I can't say anything now because I have to look after, go to details again. At present, I am sorry, I can't give you answer to you.
Thank you.
I have to go through it and.
I will get in touch with you later, Professor.
Sure. I'll just go through it and let you know.
Thank you very much, Professor.
Okay. Thank you, Viswanathan sir. Sir, I have a small point here about this new distribution, Nakagami distribution. Can you some light on his hazard characteristics. Can you light something, sir?
Yes, sir. There are some papers which have done some work on this also. It has been in my what we call review papers. Some authors have done the work, but at present I don't remember. But hazard rate, definitely some work has been done by some of the authors.
Okay, sir. Okay, sir.
Definitely.
Sir, another point, sir, you have proposed the problem of stress resistance reliability, where you have assumed that X and Y are independent, but in that you have considered the function for X lambda 1 alpha 1, for Y lambda 2 alpha 2. So what we say, whether these are independent and identical case or independent or non-identical case, what we say?
No, they are definitely independent.
No, independent it is sure, but about identical or non-identical?
Non-identical.
Non-identical.
Yeah.
Achha. Okay, sir. So thank you, sir, for your clarifications. And it was a very interesting talk. And sir has covered about the new distribution, Nakagami distribution. And sir had elaborated detail from definition of reliability, stress resistance idea, and detailed review also sir has given. And sir also have given the selection about the particular distribution related with the Nakagami distribution. And also sir has focused about the UMBU and different inferential procedures, MLE, all those things with the real life examples. Surely this talk will be motivated to our younger generation who are listening here. It will surely will benefited to them. Thank you, sir. Thank you very much for your nice talk. Thank you very much, sir.
Thank you. Thank you, sir.
Now,
thank you, Rahul sir, also.
Yeah. Please, can you stop your sharing, sir? That will be fine.
Yes.
Yeah. Please, sir. Thank you, sir.
Thank you, sir. Thank you very much.
Okay. Stop.
Thank you, sir.
Now
I'm out. Thank you.
Thought provoking.
Yeah. Lot of open problems was there, right?
And research.
Yes. So now the next speaker of this session is Professor Shila Mishra, and the title of her talk is New Normal COVID-19 and its Consequences from Gender Perspective. It's a very interesting topic of this talk. Yes, madam, are you ready? Shall I introduce myself? Hello?
Yes, sir. Very much. I'm very much there.
Yeah. Thank you, sir. Thank you, madam. Yes, sir. Today's talk is going to deliver by Professor Shila Mishra, sir, Professor, Department of Statistics, University of Lucknow. And I would like to read profile. Her academic experience is 30 years, and chairing the session organizer, invited talks, presentation, etc. as follows: USA 2003 and 2012 for invited talks, and in Canada 2003 invited lecture, in Nepal 2004 for invited talk in Waves conference, Portugal 2009, in Sri Lanka 2014 for invited session, chair talk session organizer, Thailand 2017 for workshop for SDG 2030 advocacy, and madam has completed research for 2 research projects, and research awarded 8, and area of specialization is sampling technique, applied statistics, gender statistics, biostatistics, sequential inference. And just a moment, I would like to some bigger size. Awards and membership, fellowship, etc. of academic society, professional bodies, school merit scholarship, fellowship through from 1981-1983 government of UP India, junior research fellowship, UGC CSIS JRF, through all India National Eligibility Test NET for research in 1989 UGC, and she also have received the Gaurav Samman 2013 award, 2013 Brahm Shakti Punj NGO UP.
Sorry to interrupt, Professor Naveen Chandra. I think you can skip all these things.
Okay. And also, I will nominated for Human Value Award 2013 and appreciation for Shashakt Mahila Puraskar 2014 Anupama Foundation, appreciation for Shashakt Mahila Puraskar, and HT Women Appreciation 2015. Just a moment, madam. And Jan Manas Rashtra Seva Samman 2016, and Jan Manas NGO Lucknow Rashtriya Ekta Mission Samman 2016, Rashtriya Ekta Mission, Pandit BG Avasthi Utkrisht Sechak Ivam Samajik Seva Samman 2016 NGO and government of UP Sanskriti.
I think we can skip all these details and
my Hindi also nowadays thoda disturb ho gaya hai.
Yes, I think the South impact is there.
Outstanding people are 21st century 2003 honored by IBC Cambridge, England 2003, and Educator of the Year 2006 awarded by IBC Cambridge, England. Sorry, madam, for my reading. And for more detail, people may visit the website of the Lucknow University about the madam. Now it's a very honor, madam, to welcome you for the international conference for your invited talk. I request on behalf of the committee, madam, please have to deliver your talk. Please, madam.
Welcome, madam.
Namaskar. Thank you so much. I'm really delighted to be a part of this prestigious international conference, which is dedicated to the honor of Professor C.R. Rao. My salute to the living legend of statistics, and my best wishes for his happy and healthy life for many, many years to guide all of us. And I'm also greatly thankful to Professor Tirupati Rao Padhi sir, because he has been a very good friend, and he has always been very kind to invite and to support us in all our academic endeavors. And he has been really a great organizer of so many conferences and workshops, and he is giving us all the opportunities to meet at this academic forum to all our esteemed colleagues, friends, and distinguished guests from all over the world. So thank you so much, Professor Rao, and thank you so much. And thankful to Dr. Naveen Chandra ji for giving me the opportunity to present my thoughts in front of this esteemed gathering. And I can see many friends in the participants list, and my the great salute to all of them, because despite of this COVID-19 and despite of so many webinars going on simultaneously, they have taken out time to attend this session. So thank you so much. Now I would like to go to my topic, which is related with the present pandemic crisis. And I would like to present my PPT to all of you. And if it is visible, just let me know, okay? So I'm just, is it visible?
No.
It is not visible?
It has come.
Okay. I'm just trying to maximize the size. Are you able to see it, sir?
Yes.
Now it's okay.
Much. So how much time am I supposed to wind up?
25 minutes.
Okay, thank you. So see, the COVID-19 has put us in a new normal situation. there are many things which we never imagined before the start of this COVID-19 era, and so many things which were taken for granted. Now they seem very, very difficult. If we want to find out how it has impacted the two parts of the society, especially the men and women, if we want to classify them like this, and what are the consequences, and whether both of them are affected in a same way or they are affected in a different way, that we need to understand. So this is a great concern which has been expressed by senior global advisor targeting the gender equality. So it is saying that though coronavirus is not like discriminating between men and women, but the impact definitely, COVID-19 is hitting women very, very hard. It's not same. So it is like if they are men, they are having a different kind of feeling and the repercussion. And if they are women, they are having a different kind of impact on them. And how, let us see. See, the 70% of healthcare workers are women, and they are the frontline workers, but at the same time, they are having the greater risk of being exposed to the virus, and they are also the primary caregiver at their home front and in the society. So being more exposed to the virus, having a difficult duty to perform, and at the same time a lot of work at the home front also. So this is the situation of women with respect to the healthcare workers. And at the home, they have to deal with everybody is at home. So children are studying from home, the elderly are in the need of special care. The family people, they are also full time at home. So many things are there to manage now. And economically also, it has been a very, very difficult time for them, because the unorganized sector, that is having so many women into it. So it has hit them hard economically as well. And it is given by the International Labour Organization that 41% of women are employed in the sectors which are at high risk of job losses. And it is in comparison to 35% of men. So here also, economically, they are having a greater risk. And when you are coming to the societal and the behavioral kind of attitude towards women, so we see there is a lack of empathy also. Like some people say that, well, they don't have to send children to the school, everybody is sitting at home, so why they are so much pressed or stressed out? So the lack of empathy is there. Then if it is to surrender the job because of the increased work burden or increased caregiving burden at home, so it is the women who is advised to leave the job, because in any way, at many places it has been seen there is a huge gap in the remuneration which women are getting for the same thing. So if they are getting less paid, then they are more advocated to leave the job at home if the need be. And undernourishment is also there because of the loss of job, the economy, the socio-demographic factors. So and they are eating at last. So most of the time they are undernourished. They are not getting what they should have. If we come to the front of domestic violence, it has seen a huge rise all over the world, and there has been more than 50% rise in domestic violence as per National Commission for Women. And across the world, even the France, Argentina, Singapore, it is more than 30%, 25%, 35% like that. So at the home front, they need to stay at home to be saved from the coronavirus. But again, they are not safe at home. So this is the greatest irony in the life of a woman. And at workplace also, the incidences of the sexual assault, the harassment, the abuse that has increased. And they are having less access to healthcare facilities. So if there are pregnant women, then also it is difficult to have all the facilities which they need. And it is the report which just came out today in the newspaper that 54% girls in UP are uncertain of return to school after COVID. So this is a huge percentage that the women won't be able to continue their education. And at the time of online classes, there is also a huge difference between the pattern between the girls and the boys, and 64% girls are spending their time on the household chores and the care work, whereas the 78% of the boys, they are spending time on the leisure activities. So and the girls have also opined that the 75% of them have said that the pre-COVID era was much better. So this is the situation that the education is also going to be a great challenge for the girls and the women. And the gender poverty gap is also increasing. So as per the United Nations Women Report, before COVID, 195 million men and 221 million women, they were having the poverty gaps. But now, after the COVID-19, there are going to be 232 million women who will be living in poverty. So that this is a huge number. So we know that sustainable development goals, there is a goal for reducing the poverty, reducing the hunger, having the gender equality, and so many important goals for the society are laid down there. But all of them are going to be affected if women are not going to get access to what they need as an opportunity, as a the care, the health access, the education access. And it is the recent report shows that the pandemic will push 96 million people into extreme poverty by 2021, and 47 million of whom are women and girls. So this will bring the total number of women and girls who are living on US dollar 1.9 or less to 435 million. And this is the more concern because these are going to be between age of 25 to 34. So this is the height of their productive and family formation period in any women's life. And in 2021, it is expected that there will be 118 women aged 25 to 34 in extreme poverty for every 100 men aged 25 to 34 in extreme poverty globally. And this ratio could rise to 121 poor women for every 100 poor men by 2030. And the most impacted industries have more women. So that is also like the 40% of all employed women, 510 million women globally. And they work in hard hit sectors compared to 36.6% of employed men. When everyone is stayed home, they sent the domestic workers packing the domestic and the maid servants and the supporting staff is not there. So it is like they are having at one front, the women are losing job, and at the other front, the women at home are having more unpaid work to do. And it is seen that the women did 3 times more unpaid care work than men worldwide. And this have led to months of additional work for women. And for working mothers, this has meant balancing full-time employment with childcare and schooling responsibilities. So for mother like me, we are not having any separate hours for working for our career and for working at home. It is like intermingling all the time, and the responsibility of caring for sick and elderly family members often falls on women as well, and giving the teaching and all other help to the children's school activity, that is also a burden full time on the women. So this is also leading to the inequality, and the estimates show that an additional 11 million girls may leave school by the end of the COVID crisis. And this is a global crisis. So if the women are going out of school, out of job, and out of the healthy lifestyle, then it is going to impact all the goals of SDG 2030. It is not only one. And economic insecurity is not just jobs and income loss today. It has a snowball effect on the lives of women and girls for years to come. Impact on education and employment have long-lasting consequences that, if unaddressed, will reverse hard-won gains in gender equality. A widening education gender gap has serious implications for women, including a significant reduction in what they earn and how. An increase in teen pregnancy. It also pushes women into early marriages and teen pregnancy, social evils. So lack of education and economic insecurity also increases the risk of gender-based violence. Without sufficient economic resources, women are unable to escape abusive partners and face a greater threat of sexual exploitation and trafficking. And above all, 49 countries, even they don't have any law to protect women from domestic violence. So these consequences won't disappear when the pandemic subsides, because it is not only a health crisis. Women are likely to experience long-term setbacks in workforce participation and income. Impacts on pensions and savings will have implications for women's economic security for down the road. The fallout will be most severe for the most vulnerable women among us. For example, the migrant workers, the refugees, the marginalized racial and ethnic groups, single-parent household, youth, and the world's poorest. So these people will be more impacted. And SDG 5, which is directly related to the gender equality, this is there to empower all women and girls, and that is at the highest risk. We are going to have greater gender gap, greater gender inequality due to COVID-19 crisis. So in 2030 agenda, if we are not going to revisit the strategies to to bridge the gap of gender inequality, then the 17 goals which we want to achieve will be really very hard to achieve. And as we know, the women's need are different. So we have to have a gender perspective to detect what exactly women need and how their needs may be prioritized in the policies and in the strategies to give them benefit. And the preventive measures of COVID-19, they also have put women at higher risk. For example, staying at home and social distancing, all these have increased the domestic violence against women, and they have increased the unpaid care work and the loss of livelihood, and all these issues, they have made women and girls more vulnerable to sexual violence, abduction, and trafficking. And also, when such kind of pandemics are there, the social and welfare schemes also, they take the back stage. They are not given priority. So that is also another problem on them. So community support structure and protection mechanism, they are also likely to be destroyed or disrupted. So these are the important issues: how to reduce the gender-based violence, how to handle the unemployment and economic and livelihood problems, how to handle the unequal burden of care leading to increased vulnerability of COVID-19 transmission, the low access to life-saving health information, especially by women and girls who are mostly left behind, and the policy prevention and response mechanism. This has to be gender responsive, including lack of gender disaggregated data and gender responsive plans. We won't be able to get the objectives fulfilled. So the thing is that we need to learn from the history. So it has been seen that during the 2008 economic crisis, the diversion of government funds towards relief efforts culminated in major cuts to social services and benefits with heavy impact on women. And during the recent Ebola outbreak also, quarantine significantly reduced women's economic activity, driving a spike in poverty and food insecurity. So while men's economic activity rebounded, the women's does not. So the recovery effort must reach women. Despite the clear gendered implications of the crisis response and recovery efforts, tend to ignore the needs of women and girls until it is too late. We need to do better. This is urged by the United Nations Women's Chief Statistician Papa Singh. But most countries are either not collecting or not making available data broken down by sex, age, and other characteristics such as class, race, location, disability, and migrant status. So as a statistician, what we can do, we can collect the local, at the local level, at least the sex disaggregated data, because we know that the problems are having many local issues which may not come up into the national or global figures. And for this, it has been suggested that there are 5 important steps that the government and business people can take to mitigate the negative economic impact of COVID-19 on women. So if the data is there, we can have 2 kinds of strategy. The observed data can help us in formulating many predictive models and handle the things which are same for men and women. But there is an unobserved data which is related with the mental, social, behavioral, cultural, attitudinal things that we need to collect at local level, and which will help in addressing to the problem faced by the women. So gender analysis is very, very important to mitigate the risk from the gender perspective, and the gender responsive approach is needed. So we need to understand this at every different classifying variable level. For example, how the women's health is affected, how the education of women is affected, how the livelihood of women is affected. All these factors need to have the gender approach. So we need to give the direct income support to women, and we have to introduce economic support packages, including cash transfers and all those things which are mentioned here. So because of the time lag, I will be just giving you the headlines of what we can do. And we can support for women owned and led businesses. The third could be the support for women workers, and implement gender responsive and social protection system to support income security for women, and support for informal workers who are working in the unorganized sector, and reconciliation of paid and unpaid work. So at home also we need to sensitize people to care and to share the burden of the women at home. And these are the data which have been released by the United Nations of Women. And if we are able to do all these things, as a statistician, if we bring out the studies from the gender perspective with the disaggregated data, I think the impact of the COVID-19 can be reduced in the negative sense, and it can increase the positive impact, and we can have a better new normal after this crisis. So thank you very much for your patient hearing.
Thank you, madam. Thank you for your nice talk and very informative and very useful for the coming time for the research perspective point of view. And now floor is open for any questions or discussions. All the audience, you are invited for your side. Yes, please, sir.
Let me congratulate the speaker, Professor Shila Mishra, for presenting a very useful information. Not only informative, concern-prone, empathetic, and innovative. So, need of the hour is that we are having ignorance on different prime concerns. Prime concerns. Your research areas, you have mentioned that. I am proud to now read that items that your research areas consisting of biostatistics, applied statistics, and gender statistics. It's a nice concern that you are working for.
Thank you.
And really, I agree completely and absolutely with you that there are unorganized sectors and what we call it as informal working groups that are neglected and ignored, and some person has to take initiative to keep that problem on pace. So, madam, your efforts, I have been gone through your activities through Facebook and other social media, and whenever I have seen your information, I used to see a fighter or with a fire in you to address the women concerns. It's not that a feminist. It's not the concept of feminist. It is the concept of awareing the people where the neglected group is supposed to be focused. And they are the prime or pivotal people. The people who are claiming that unorganized. The girl education is now affected. As per your presentation, COVID is drastically affecting in different aspects. Girls have a special responsibility and at homemaking as well, and they have to read. The dropout percentage, 54%, is really very, very, I am unable to, a little bit emotional I am about this one. Okay. So really, the prime, as you said, these people are the frontline workers. When the crisis has come, when the crisis either at home or at national level, these people are the more vulnerable group, then they are exposed to this risk. In spite, they are not able to give in the proper recognition or proper care or concern. This is true, madam. And really, the forums like this, not only like this, all the forums what you are working for, you are making much work to the social concern. Really, I appreciate your way of communicating our statistics to address the real problems of the nation. So I hope you will reach to the positions where these problems can be addressed. Might be, I'm expecting that you have to occupy the positions where you will be the policymaker and administrator. Then nation will have some sort of benefit out of it. Now, this presentation has really touched my heart, madam. Really, I'm speaking. Thank you very much, madam, for sparing.
Thank you so much. Thank you so much,
Thank you, madam.
sir,
Thank you,
for your kind words. And
Yeah.
I'm extremely thankful that you gave me the opportunity to share my thoughts at this distinguished forum. So
Yeah.
thank you very much.
Thank you.
Thank you, madam. Thank you, madam, for a lot of nice things you have delivered. Lot of problems occurred during this pandemic, and that many of the issues people not care, and you have bring in the notice. Surely, our younger researchers definitely take this opportunity and do something in further. Thank you, madam. Thank you very much for this nice talk.
Thank you.
Very nice talk. Now,
Thank you very much.
thank you, madam. Now, the next speaker of today's session, I would like to call Professor G. Arivangan. Professor G. Arivangan sir is there.
Arivarignan.
Arivangan sir is there.
He joined sometime back. Professor Arivarignan sir. Sir, Professor Arivarignan sir. I think he's not there. Next speaker is make it, sir.
Professor P.R. Mittal sir. Professor P.R. Mittal sir. Professor P.R.
Now
Mittal
only
sir.
joined, sir. Now only joined, sir. Please wait, sir.
Acha, acha, acha.
Hello. Who is that? Arivarignan sir joined.
Yeah.
Welcome, sir. Arivarignan sir. Welcome.
Welcome, sir.
Right.
So, yeah.
Okay.
Yeah. Just a moment. Yeah.
Thank you, sir. Thanks you for letting me in.
Yeah, it's a great pleasure to today. Next talk is Professor G. Arivaranganam, and his talk of this title of the talk is an inventory system with random lead time and general service time. So I'd like to share his profile. Yeah, is it visible, sir?
Wait a minute, sir. I just hugging in.
Yeah.
Professor.
Yeah, sir. Yeah.
Yes, sir.
Yeah, I would like to read his profile. Professor G. Arivangan, sir, former UGC Emeritus Professor, Department of Statistics, MSU Tirunelveli, and CSIR Emeritus Scientist, School of Mathematics, Chairperson, School of Mathematics, MKU, Head Department of Applied Mathematics and Statistics, MKU, Coordinator, Curriculum Development Cell, MKU, and sir also received award FAS Fellow of Academy of Science, Chennai, professional experience 1974 to 1990, Assistant Professor of Statistics, Government Art College and Presidency College, Chennai, 1990-1997, Reader, Madurai Kamraj University, Madurai, 1997 to 2007, Professor Madurai Kamraj University, Madurai, 2007 to 2012, Senior Professor, Madurai Kamraj University, Madurai, and sir having research PhD, produced 16 and papers in international journals, 96 numbers of papers with impact factors, more than 2 are 10, between 1 and 4 are 9, and less than 1 are 16. H index 12 is 12, Scopus 20, Google, guest editor, Annals of Operation Research, special issue, volume 233, and his research interest is research stochastic modeling and of inventory system, applied statistics, membership in professional bodies, life member, International Indian Association for Statistics, Indian Bayesian Society, Indian Association for Productivity, Quality and Reliability, IAPQR, Indian Society for Medical Statistics, member of Operation Research, Society of India. With this introduction, I would like to request Professor Arivangan sir to deliver his talk.
Thank you, sir.
Thank you, sir. Thank you. You are welcome, sir.
Okay, sir. I thank Professor Tirupati Rao also for asking me to join here. That is a great event. I am very honored. For the last 1 hour, I was trying to get connected. I could not get connected. But I remember that my time is 12 to 12:30. But fortunately, I was just logged in. Now we are inviting to talk. It's really a coincidence. Anyway, I'm very happy. I was able to join you in the correct time. Now I will try to present my screen. So are you able to see me, sir? See my screen?
Yes, sir. Yes, sir.
The title screen is being shown. I have made my screen so large that I can see only my screen and I can't see anybody. So if anybody wants to interrupt, please don't raise your hand.
So make it in a Zoom mode, sir. Put it in a Zoom mode.
Okay. The point is, my title is an inventory system with random lead time, with general service time. It may look like an inventory or queue. I want to assure that this is both. Some people are working queuing theories, some people are working inventory theory. Basically, I am from inventory theory, and this one is a combination, amalgamation, I should call this a queue and inventory. So I consider service facility in the usually that is considered in queuing theory. If there is a service facility, customers come and join the service facility. They are served one by one. That is the queuing theory. In another case, inventory theory, there is a stock of items that will be released and issued to a demanding customer. Now I think of this situation: a service facility, a customer comes and joins and requests an item, and that will be serviced. So that is the type of queuing system. But what I say is the items are selected from the stock. Moreover, in another context, if you consider inventory modeling, they have the stock, but only when there's a queue, they start issuing. So this both way you can think of. That is, you think of a queuing model, there you have a stock of items, or inventory model, there is a queue. Right. Now, what is the problem when you consider both? A queue is formed when the item required by the customer either under service or there may not be in stock. In that case, you can't serve your customers, a queue will be formed. Whereas in regular queuing theory, the item is always available. As and when they come and they get serviced, they move away. But there is a fixed stock when I specify the queue, though one by one is formed, unless otherwise there is an item, they can be served. Moreover, people are there in queuing theory when customers are there, their service is performed. But only if the stock is available, it will be served. That means if stock is depleted or no stock, you can't perform any service. Okay. This is a vast literature. Mainly it is started by Berman and Kaplan. You can see the early journal papers are mainly due to Berman and Kim. If you want to see. So then, okay. There are some more people, they have done work. Krishnamurti and Schwartz, Krishnamurti and Anbulahan, M.R. Weller. This is my joint paper. Okay. So Kumar, my student, now he's working in American History. So when there is a Etel, I mean, there are more than 2 authors, I am also there. So most of them were students, except Chakravarti, Bhattmadi, Rajkumar, Jennifer, Avida Kudi, Sophia. Now I is a student of Krishnamurti. Okay. So these are the literature, but I didn't give any reference here because now Google gets everything to you. Now I'll give you a schematic diagram of the problem. That is, we think of this area. There is I have time axis here. A time axis here. Here the customer level, customers, the queue size. When there is a customer carrying this at this time, the queue length becomes 1. But at that time, an item is received from the stock, they start servicing that item so that at the time of completion of the service time, he gets it, then he leaves. Therefore, the queue length will be 0. But at the same time, the stock length goes down. When there is a departure of the customer, a stock length goes down. Another then his service is random. It goes up to this time. During that time, there are 2 more customers coming in. So queue length goes to 3. When the service is completed, the customer leaves. So the queue length becomes 2. At the same time, the inventory goes down. So sorry that I can't draw a picture with both axes in one diagram. That is very difficult to draw. So I'm just giving this. Particularly, we are going to have one prefixed level small s. When item drops here, we place an order. That order will be received only after some random time. In this time, suppose the inventory comes down to 0, then the item is replenished only at this time. During this period, I should say this period, first starting model for covering queue and inventory. So I already I got a lot of other complications. I'll tell you. So this is my model. So what are the process I'm going to have? T1, T2, T3, T4, T5, they are the arrivals of the customers. So the distance between T1 and T2, T2 and T3 are the inter-arrival times. When a customer comes in, if there is a stock, a service starts, so this is the time. This is the service time, and so on. So C1 designates the customer leaving the system, and L represents the lead time. So I want to specify capital Tn is the time of arrival of nth customer. The inter-arrival time is Tn plus or minus Tn is distributed as exponential. So something like a Markov in Q, M. The Markov in Q is we have 3 letters, M. But what about the service? If it is M, then you will have M on Q. But what I do is, the Sn is the duration of the service time for nth customer. Now I assume Sn has general distribution, because if it is M, you can easily solve. So I am going to do general service time. So G. Mg 1. Usually the general service time Q theory has got a problem because we can't solve completely. But here we are going to address in a different way. Right? We are not going to use the usual Markov process approach. I'll tell you the technique. Now, O is the time at which the order is placed. The lead time is L. At the end of the lead time, order is received. The items are received. So lead time is distributed exponential. So this is Markovian, this generalized. Apart from the lead time is exponential. So this is the problem, and please note that not everything is exponential. If I do not consider general distribution, and if I consider Markovian, then actually I will be having a very simple structure. I can use a Markov process method to solve the problem. But I will be using Markov red matrix approach. Because of this a general distribution, I can't use the Markov process approach. So that's why I'm going to repeat it here. The service time alone is arbitrary, others are exponential. So this assumption makes the problem not to be modeled as Markov process. We use embedded same Markov approach. Okay, then I have done it. The last bit I noted that this is already talked, so I remove this. So I will take to spend some few time to explain the stochastic process, the sample path approach. So this is the time axis. Time axis is the process. It could be, sir. It could be a inventory or queue length or waiting time, whatever be it, and the sample path goes like this. times of arrivals of customers are assumed to have exponentially distributed interval times. Now, I am going to just point out an important point. Let us say you consider a problem like this, and the sample path changes its time, changes its movement. It's horizontal, now it goes up. It is horizontal, it comes down. It is horizontal, comes down. Whenever there is a change, I call this the times of changes in the process. TK, the TK is here. Can you see the cross symbol? These cross symbols are times of changes. Now these dots are the value of the process at time TK. Any there is any problem? Okay. So if you do not have any, the gaps are simply ignored or treated as equally spaced, then I got a Markov chain. But suppose if there are no these XKs are not there, only the times at which the things there are some arrivals, then I got a renewal process. So the same problem, according to our interpretation or according to our requirement, I can consider a renewal process or a Markov chain are put together. That is where I'm going to get the Markov process, renewal process. Okay, now T0, T1, T2, T3, T4 are times of changes, and X0, X1, X2, X3 are the change in the process Z of T at these times. Suppose if you assume that between T0 and T1, I'm going to consider a continuous path from T2 to T1 to T2, the level X1 is continued like a continuous path. This is a path. Then I got a process, not only a discrete time, but the paths are continuous. So if this T1, the inter-arrival times are simply a function of T, I mean, simply means it does not depend upon either time. The only function is T, then Z time is called Markov process. When it also depends upon the starting point and ending point. So here the starting point is X2, here the ending point is X3. Then we have a function depending upon I, initial state, J, final state, and duration time T. Then your Z of T is called the same Markov process. So most of the problem is a same Markov process, you can call it as that, or Markov renewal process, you can call it, but they are the very simple generations of Markov process. But for my problem, this is not sufficient. So what I'm going to do is, I'm going to consider where I call this, okay. There is a time T0, T1, T2, they are the visits to particular state, say 0. Then this T0, T1, T2 can form a renewal process. Here also I have the Markov renewal process, and you can call the same Markov process. The only thing is, suppose Tn does not form a renewal process, because I'm going to consider a general service time. That doesn't mean that they are renewal, because there's an exponential. Then you start at some time, so start doing service. It's in somewhere. So if you consider the time of completion of service, they do not form a renewal process. That's where I am going to bring a semi-regenerative process. For that, I need a stopping time. I don't call renewal times. The renewal time is a methodology used nearly 40 to 50 years in reliability, queuing, inventory. But there are cases where you have some sort of regeneration, but it's not simply a renewal process. We call it semi-regenerative process, and we can find a embedded Markov renewal process there. I think I can. I'm just talking general. Let me go to the problem. I will explain these things. So the idea is I'm going to consider a problem which is not Markov process, which is not Markov process, even same Markov process, no, but a semi-regenerative process. Okay. Now what I did is the joint process, the process of length of Q and unit size at time t is shown to be regenerative. That's the first point. There is an embedded Markov process. I would identify the static distribution is obtained. The giant power distribution this at orbit time or in the steady state, both are obtained, and various system performance measures. That is what is the mean length, what is the Q length, and so on. Particularly, this type of problem cannot be given a full analytical solution. Just 30 years keen to provide analytical solutions, but later, after Marshall F. Newt's coined the term computational probability and algorithmic probability, then there is a in finding an algorithmic solution. So my study, making so much complication, I am going to give a solution in terms of algorithm. That means what? With the available computers, with the algorithm I am going to provide here, you can always compute. More often, the industry people, they don't ask the best question, best answer for their problem. Those days, we have to the optimal solution, this is the best. But many times, when things are getting complicated, your problem cannot be completely solved. The industry people ask only simple question, is there a solution? I will evaluate the solution under various circumstances or various criteria. Then don't say the solution is always available. Tell me a solution or give me a methodology to get a solution. So my research area in this paper is about the algorithmic computation of probability distribution. So I recall the arrival tests are Poisson, and service time is arbitrary. Ordering policy is SS policy. The smallest, capital S, smallest means it is lower than capital S. Whenever the unit drops here, immediately place an order so that it is immediately received. The stock will go to capital S. That means capital S minus small s is the item I'm going to place. But because of random order, random lead time, I may get immediately or after some time. But the thing is, the ordering quantity will not exceed capital S minus small s, because if it is received immediately when I place order at S, without the next demand, if order is received, small s plus this item will make it to capital S. If it is more that the inventory stock level will go beyond capital S. So I always fix the limit for order quantity. Order quantity is capital S minus S. The most important assumption is during stock-out period, any arriving customer is not allowed to enter the system. If you ask them to enter and wait somewhere in a pool or orbit, there are two ways of keeping your customers wait for the turn. But unfortunately, already I made one decision. Service time is arbitrary. So, in order that this problem is solvable, I am going to assume that during the stock-out period, the arriving customer will leave the system. So, I give some notation. X of t represents the number of customers waiting at time t during the Q length. L of t, the stock level. Now, what is the state space? The number of customers can be 0 or 1 or 2. The inventory could be 0 or 1 or 2 or capital S. Please note that here both are discrete state space. Let successive service time completion be generated by T1, T0, T1, T2. For conveniently, I take T0 equal to 0. I have my starting point. We'll show that the Tn are stopping times. Stopping times in such a way that once the Tn are given with associated inventory level or customer level, the process regenerates. Please note that stopping times are sometimes becomes renewal process. But in my case, this is not rule time, but I'm going to call, still I call a stopping time in the sense that once the TN is given, what is the inventory level or customer level or the queue size, then that helps me to proceed further. Proceed means I can compute the other probabilities. That's possible. Okay, this is again, I always told you. Okay. Now, how do you analyze? We consider the Markov process. Please note that T is the stopping time. At time n, at time Tn, the Q length or the stock level is considered. It is given as a tuple, a pair. Then this is a, I call Markov rule process because this is a Markov chain. This is a Markov chain. This will be a set of stopping times so that there is a regeneration of the process.
Sir, sorry for interruption. You have 5 more minutes.
Okay, sir. Then I have almost come to the definition.
Please. Thank you, sir.
Yeah.
Carry on.
Then I am going to compute the C Markov kernel. I am going to define this. It's simply a conditional probability that initially, you just recall Markov chain. Initially, the levels are X and L, the Q size and the unit level. After the next step, next time point, this will become X dash and L dash. The only things I am adding this new quantity, the Tn plus or minus Tn less than or equal to T. Now, something like a distribution function. So it is similar to a distribution function. The only thing is there is a initial state and the final state, and I am able to compute this. This got this here. So I have derived this function. I will show it in some other place. The idea here is the most interesting thing or important thing in the area is, suppose if you want to compute a probability function of some function, some process given Z0 at an initial point. Now I'm going to consider a branch. In one branch, the first stopping time is more than T. The second branch, the stopping time between T and less than or equal to T plus delta T. At this stage, I want to inform that in India, we are very comfortable using this type of definitions. But if you read a foreign article, they won't do this way. They will say T1, sorry. T1 less than or equal to T. Here, T1 greater than T, here T1 less than T. That makes some sense. Because foreign authors always use comfortably with a distribution. But here, we in India, many of us do only the period type. Okay. From this, I am going to type the consider renewal equation. And okay, now I am going to rush through. These are my start point. Finally, I am going to get simply a matrix function equal to a matrix function plus a integral equation that is du t minus u. You can very well see that it's nothing but the integral equation. Actually, there is a similar result in renewal theory, renewal equation, but it is not a renewal equation. It depends on many constraints. Okay. Now, by using the Laplace transform, I get the transform solution of my function by this method. Right? Theoretically, I am able to give. Now, finally, I am going to compute the steady state. For steady state, I need a probability function matrix, and I'm computing performance measures, the expert inventory level, reorder rate, bulking rate, the waiting number of hour waiting number, and so on. And I impose a cost for holding and waiting and so on. This made expected cost, a total expected cost per unit time. Okay, then I computed this because I have given algorithms. I was able to, because I consider a general distribution for a service time, I consider exponential, Erlang over order 4, and uniform distribution over 0 to 2. With that, I have to compute. But this is mu beta lambda parameters, and this is the smallest capitalist, the optimal order quality, and so on. And we have done a lot of numerical problems. Please note that with these numerical results, I am not going to climb. My costs are like this. For industry, I give algorithm methodology. And I have made observation. I think one more picture I left out. So for certain class of parameters and the cost, I was able to show a bowl, that is a convexity. By showing that, I can confirm that our cost function may be convex, a unique optimum exists. But there is no way to prove that, but I know that. But this belongs to algorithmic approach to the problem. So the algorithm is already given there. The computing, you can use any, even R you can use, or MATLAB, or even Julia. The algorithm is very straightforward. There is no calling, recalling, many subroutines. Very, very simple one. Okay. Now, the only thing, I think there are some observations I have made here. The arrival rate increases, the total cost increases. Replenishment rate increases, the total cost also, not total cost, optimal cost decreases, and so on. With that, I think I can stop now. I can ask for your queries.
Yeah. Thank you, sir. Thank you, sir. Now the floor is open for the questions, queries. Please. Yes, Professor Rajgopal, sir, you are speaking something?
Yes.
Yeah, please. Please.
Can I request Professor Arivanjan for reference of this paper? Probably this paper might have been published.
It is sent for publication. Yes.
Oh, thank you, sir. Excellent. Current and live paper. Thank you.
This is not actually published work. I am going to present.
Okay, sir. Okay. Lot of tools combined in single paper.
But, there are a lot of papers we have done. If you want, I will send you my earlier works.
Yes, lot of tools we have used in the single work. Thank you.
Thank you, sir. Any question, anybody?
Yes, there's another question coming here.
Professor Vittal, sir, asking something?
No, there is another problem.
Yeah. Yeah, you wanted to ask something, sir? Professor Vittal, sir, so many queries there? No. I think no question, sir.
Hello, Professor Tirupati Rao.
Yeah, sir.
Look at the Natarajan Bala. I think he is trying to ask.
Yeah, please.
Please unmute, sir. Unmute. Mr. Natarajan, please unmute. What happened? He is raising his hand. Okay.
Any questions, sir? Vittal, sir? No. I think no questions, sir. Let us thank to sir, Professor Arivanjan, sir. Lot of good things and ideas and algorithm develop. That's most important. Yeah. Professor Tirupati Rao, sir. Yeah, please.
Sir, one question.
You are saying?
Sir, one question.
Sir, I have one question.
Yes, sir.
Yeah, please.
Yeah, please.
One by one. Please, one by one.
Yeah.
Who has to speak first?
Tirupati Rao, sir.
Okay. Sir, you have mentioned that lead time follows exponential distribution.
Yes.
That lead time, what is the variable under observation, sir, during that time?
No, the time.
Lead time follows exponential.
Time of order and the receipt. Time of receipt.
Okay.
When you are patient, time, that length is the lead time we call. It's a random time. Somebody is asking.
Viswanathan, sir.
You please unmute, sir.
Unmute, sir.
Not audible.
Okay,
Yeah.
Now I think it's okay. Sorry for the inconvenience.
No
Professor, it's a very exhaustive and lively derivations and other things you have presented. So my question, I have some queries. This is with respect to the part that comes towards the end. You said that there is a matrix equation which you solved using Laplace transform, in which you have a term like 1 minus pi inverse.
Not 1 minus, I minus.
I minus. Okay. Yeah. Okay. That whether in that particular situation, whether you have any difficulty, did you face arise with respect to say something like a singularity of the matrix, that is inverse non-exist?
Play a major role here. Singularity will play an important point, because I minus q power inverse, if it's not possible, you expand it. When you expand it using some Taylor's theorem, then at a singularity around singularity point you take. Therefore, singularity point.
Yeah, whether that singularity, okay, mathematically solving, as you mentioned, you can provide a expansion and we can to some extent bypass. But my question is whether that singularity corresponds to any specific scenario in practical sense.
No, sir, there is no this. When you come into mathematics, mathematics use certain ideas. That's all. That particular idea has nothing to do with your model. Moreover, because of this problem only, they went for algorithmic probability. There is the Mossel F Newts started algorithmic because of the complexity here.
Okay.
So it's not just even Newt was solving with the same type of equations, but it is very difficult. So he went back to computation of matrix geometry like that. Matrix analytic methods he evolved for the last 20 to 30 years.
Okay,
yes, sir.
Okay. Sir, I have one idea about one software which is Arena, which I think you probably that deals with some, if you give some conditions regarding the incoming rate and service rate and other things, it will give various performance, it will simulate and will give various outcomes. And whether such softwares, okay, make use of these type of algorithms, or did they analytically solve and give the output?
No, sir. There's Arena software is mainly for management people. Then there are, of course, there are single variables, many complexities. Arena will handle. But here, there are some general distribution. That general distribution will not come into this. More probably, if you want to use the exponential Rayleigh, you can try to use Arena. But I tried, but this gives a separately different perspective problems. Arena is not for mathematical problems.
Okay.
It's beautifully, it will give all the diagrammatic or animation, everything. But here, this is not easily solvable using Arena.
Exactly. That means it will also, going by the simulation diagram, you can see where the bottleneck is and other things. It's very nice as you are mentioning. Okay, one final question is, sir, what about the structure of your cost function, sir? Can you show it? Structure of your cost function.
This cost function is involving the holding cost per unit time, set of cost per adder, per order.
Okay.
Then it's weightage cost per unit time. When you have everything per unit time, it is simply total cost per cycle divided by the cycle length. Okay, it's a fraction. Yeah.
Okay, some overhead cost plus some n times unit cost.
Yeah,
C plus NC, small c, something of that sort.
You can think this way: for a particular time length t, you consider all the cost divided by the total length of the time.
Oh, per unit time cost.
Total expected cost per unit time.
Okay. Thank you, Professor. Thanks a lot for your complete explanation.
For clarification. Let us thank to Arivaringan sir. So nice presentation and good ideas given by for the younger generation. They definitely need to learn all those things and algorithm. Thank you, sir. Thank you very much.
Thank you. Now, thanks to the Professor and Professor. You also, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you, sir. It's our pleasure.
Now, thank you, sir, for your kind attention. Thank you, sir.
Yeah. Thank you, sir. Now the time for the next speaker, Professor P. Vittal, sir. Now I would like to present.
Please bring.
So next speaker is Professor P.R. Vittal. He is a visiting professor at University of Madras, Chennai. Next, his research interest is differential equation, probability and statistic, stochastic processes. His qualification from PhD from Med Science, Chennai, 1976 to 1980. Thesis, probability and stochastic processes. MSc in mathematics, Chennai, during 1960-61. His academic position holds Professor and Head Mathematics, Department of Vivekananda College, Evening, Chennai, during 2000 to 2005. Principal, Vivekananda College, Chennai, 1994-1996. And Head of Mathematics Department, Vivekananda College, Chennai, 1989 to 1996. Visiting Professor, Western California University, USA, during 1988 to 1989. Professor, Vivekananda College, Chennai, 1980 to 1996. And lecturer, Vivekananda College, Chennai, during 1962 to 1980. And lecturer, Ismailia College, during 1961 to 62. And present academic appointments is here. Visiting faculty, Institute of Chartered Accountant of India, Chennai. And visiting faculty of Institute of Financial Analyst, Chennai. Visiting faculty of Madras School of Management Science, Chennai. Visiting faculty at University of Madras, Chennai. Visiting faculty, Chaitanya College, Hyderabad. Visiting faculty, Harish Chand Research Institute, Allahabad. Visiting scientists at Indian Statistical Institute at Calcutta, New Delhi, Bangalore. And publication, sir has published about 20 papers in national international journals, presented papers in around about 38 conferences, and presented papers in international conferences at Stanford University, USA, Cornell University, USA, Florida University, USA, University of Georgia, USA, University of Tennessee, USA, West Carolina University, USA, York University, Canada, Toronto University, Canada. With this short introduction, now sir, Professor P.R. Vittal sir, and the title of his talk is today on compensation function and the method of images. Now I invite on the behalf of the organizers, all the organizers, Professor P.R. Vittal to deliver the talk. Thank you, sir.
Please. Professor Vittal sir for
yes, Professor Tirupati Rao and his team for arranging this excellent work on the 100th legend centenary celebration of C.R. Rao. I am closely associated with C.R. Rao, and C.R. Rao and myself were in a meeting in connection with the 100th centenary celebration of Sir Ramanujan. Now, C.R. Rao was also chosen my paper as the best paper award in a work very similar to what I am going to present today. That's why I prepared this talk. Now, with my respect and to my interest to the chair. Yes.
Your presentation is not coming, sir. Hello,
yes,
sir.
Presentation is coming. Now you see, presentation is coming. Is all right? Now, you see, now the presentation is on compensation function and method of nature. I likely to tell you that people are very familiar, especially students who are in engineering colleges and physics, that the method of images was introduced in the conduction of heat in a finite rod, again being kept at 0 temperature. Is purely a deterministic function. However, Kielsen introduced the method of compensation function to study the first passage time for bounded Markov process. In his contribution, using the generalized walled identity due to Kepler. Yes.
Sorry for interruption. Are you showing the presentation, sir?
Yes, yes, I am showing the presentation.
Yeah, it is not coming, sir. It is yet not coming.
It is not coming?
It is yet not coming.
But ensure, sir, please.
Oh, so
now again you will make it, sir. Share it.
Is it coming now?
Now you please share first, sir.
It's not coming.
Oh, So, Praveen.
Wait, sir. Ensure after your presentation, then only you present, sir.
Correct.
You have to share now, sir. Present now.
Present, Praveen, share. Is it coming?
No, sir.
No.
Yeah,
now
please kindly.
Now
share.
It's coming.
Coming.
Coming?
It has came.
Now it's okay, sir.
Now it's okay. Now see, my talk is going to be a very simple talk. This talk is based on the long back work of conduction of heat in a rod in hydrodynamics. Now the rod was kept at 0 temperature at the end, and the temperature distribution was studied. However, Kielsen introduced the method of compensation function to study the first passage problem for bounded Barkov process. In his contribution, using the generalized world identity due to Kepperman, we decompose the appropriate compensation function into a series of terms corresponding to the successive attempts of the process to jump out of the barrier, and relate them by a limiting procedure to various orders of images of heat diffusion problem to give exactly the same solution from the well-known method of images. Now, Kielsen's problem of heat conduction in a solid, which is bounded by plane at one side, either side at 0 temperature, is analyzed by celebrated method of images. Method of images is well known in the books of physics. The principle underlying this method is to take a series of images in the bounded planes at x equal to 0, at x equal to a, and then obtain a distribution of sources and sinks which give a temperature function vanishing on the boundary. This method reproduces the Green's function corresponding to the required boundary condition in a physically intuited fashion. Now, Markov process associates the jump probability and the other stochastic process as studied by Kielsen. It is simple to write down the equation governing the process as an integral differential equation for probability distribution. However, the problem becomes very difficult when boundary conditions are introduced. So free boundary with boundary condition. A very important advance in tackling such problem of bounded process is the introduction of compensation function in the study of bounded process. What is compensation function? By their very nature, they have to involve the very relevant idea of first passage beyond the boundaries in the case of jump process. There's a natural connection between the random walk process in one dimension and the passage to the boundaries on either side, for which relations like world identity can be invented without working through the details of the integral differential equation. Since the equation governing the boundary value problem for the Markov process is equivalent to an equation with compensation function corresponding to boundary condition without any more restriction, that's very important, without any more restrictions on the solution, the natural tendency is to break up the compensation function into a series of terms corresponding to the successive attempts of the Markov process to jump out of the boundaries. We are going to consider this as a one-dimensional problem. It is well known that the Markov process jumps governed by jump by simple frequency function for the inputs can be related to the diffusion process. We are now going from Markov jump process to diffusion process. The frequency of the jumps tend to become very large, and the statistical features of the quantum jumps is specified certain condition. This Markov jump process can be converted into a diffusion process. Therefore, it is very tempting to ask the question. It is the interest. It is very tempting to ask the question whether the series of terms composing the compensation function representing the boundary situation can be related to the concept of images for the differential equation for the plane bound. It will be our attempt in this note to link this intuitive equation and elaborate further ideas later. Now, following is the notation of Korsla and Jaeger, the classical diffusion equation, which is very elementary. Even the students of the engineering might be coming across this in the first or the second year. This is a one-dimensional equation where Vxt represents the temperature at any point x at time t, and k is the diffusivity coefficient. The initial distribution of the temperature is given by Vx0 equals f of x. This is purely a deterministic process. Now what we do that, we replace Vx0 by a delta function source at x0 with strength mu, which acts as the initial source for the subsequent time. We also replace the boundary plane x equal to 0 by a negative source at x equal to minus x0, and hence the solution of the problem is obtained by the method of equation. Therefore, this Vxt, which we exhibited in equation 2.4, is the free boundary solution. This is the boundary solution of the diffusion equation. Here we had the boundary at x equal to 0, purely a deterministic. Minus mu is the sink at x is equal to minus x0. The solution by the method of images, we suppose the solid be continued in the negative. The solid be continued in the negative side of the plane with an initial temperature minus fx dash at x equal to minus x dash. With this distribution, the plane is kept at 0 temperature, and therefore the solution that we have seen is the solution by the method of images. Now we consider two boundaries. We are considering a finite rod. The rod is bounded by the plane at x equal to 0 and x equal to a. Therefore, always the temperature at 0 and a are kept at 0. But the initial condition is that the initial temperature is a delta function with source mu. According to the method of images, we have to take images of the sources at x0 in the plane x equal to 0 and x equal to a, and then continue to take the images of images ad infinitum. At two boundary planes at x equal to 0 and x equal to a, we keep a mirror. Therefore, when you go outside one mirror, we look the image at the other mirror and continuing the images after image ad infinitum and the opposite plane. Sources and sinks are created, keeping the boundary always at 0 temperature all the time. Now, for this two boundary problem, the sources and sinks are at x0 plus 2na and minus x0 plus 2na, and the integral values go from minus infinity to minus infinity. Hence, the solution to this two boundary value problem of studying the temperature of a finite rod is given by the method of images by this function. This elegant method of arriving at the solution using the method of images can be looked from another point of view in stochastic processor. We can arrive at the diffusion equation by imagining a Poisson jump process with the independent increment having a distribution Ax and increment frequency gamma square mu. When the frequency of the Poisson jumps go to infinity, and when the statistical features of Ax satisfy certain condition, we can arrive at the diffusion equation for phi xt as in Kilson. In the subsequent section, we introduce the boundary condition for the Boltzmann equations of the Markov jump process and introduce the idea of compensation function. Now, we look at the fundamental equation of the Poisson jump process. We now come to the stochastic process. Earlier, we looked into a deterministic heat conduction equation which resulted in the diffusion equation. Now, we are going to consider a Poisson jump process. X of t denote the position of the point at time t, initially x0, and it takes jumps zi which are independent. All are Poisson jumps, and there are empty number of Poisson jumps up to time t. This is a free boundary problem. Now, we write down the Kolmogorov forward equation for such a process. It is well known that the forward equation of the process is given as an integral differential equation for fxt with the initial condition as a delta function at x0, fxt being the density function for the stochastic process xt.
This is a free bounded process. We have not introduced any boundary. The solution to this problem is the Green's function. Now, the Green's function for the spatially homogeneous process is given by GXT. Now, this AKX is the jump, AKAX is the jump density, AKX is the k-fold convolution of the jump density. The characteristic, we are going to take the double-sided Laplace transform, or otherwise called the characteristic function, convert this integral differential equation into a differential equation which is easily solvable, and the solution to the differential equation in this free space ranging from minus infinity to plus infinity is obtained. So far, we have not introduced any boundary to this type of stochastic process, Markovian in character and Poisson in jumps. Now what we do that, we are going to introduce the boundary. First we introduce a single boundary at x equal to 0. It's like a semi-infinite rod. The initial distribution is AX, and the point x should always be in the range 0 to infinity. The jump density and the transition is given by ax minus x dash or x greater than or equal to 0. Now we go into the forward equation. We are going to remove the condition. Now there is a boundary. See, in the previous slide, I show that xn maximum value is 0. That means it cannot travel to the negative side. Once it jumps to the negative side, it is the first passage to the region minus infinity to 0. Now, boundary is there at x equal to 0. Now, we want to remove the boundary and get the solution to this problem. Give the effect to the boundary, we can introduce the compensation function of Thiessen in the differential equation 3.2. The earlier differential equation is same as this. This boundary current is now removed, and this is going to take as a source function to take care of the effect of the boundary. We now come back to the old equation with an additional introduction of the compensation function CXT, but it is to be treated with no boundary. The question is, what does CXT stands for? Is it really the first passage time? Is it anyway connected with the method of images? Will we go into the diffusion limit? Is our origin of interest? Now, what do we do that? For a free bounded process, I can now write down the Green's function. FXT stands for the this function. Now, dx dash stands for the generation density function, which will enable us to determine the CXT. Effectively, the CXT is going to be the first passage to the negative side of the origin. Now, the CXT is now ultimately simplified in this form. Unless you know CXT completely, it might be difficult to tell in an explicit analytical form what is the first passage beyond the boundary to the 0 to the left. Therefore, we have an initial distribution f0x with the density mu at x equal to x naught, and CXT is given by the coupled convolution of x and t, and CXT is very easily determined in terms of f naught known, g is known, and c is known. Now, what I do that, fxt I write down. This is free motion now. Fxt is the position of the particle at time x, at time t. Fkx is the position after k jumps. Now, what I do that I introduce the compensation function. Therefore, I want to go in for the CXT. CXT is nothing but a negative source in the left side of the origin. Therefore, we now see that there is a term like ck plus 1f. If you look at this, now you will see that ck plus 1f. This guaranteed that the particle has not jumped outside the origin initially. At least one jump is required to go to the origin. Therefore, we see that there is the fkx in fxt, but you have ck plus 1fxt. How we are going to determine ck plus 1fx is the question. Now, fkx is nothing but the number of Poisson jumps, the density for the number of Poisson jumps. I can connect it with ck. I can write out ck, and ck is previously the function is going to be the fk minus 1. From fk minus 1, it jumps to ck. Ultimately, by iteration, I eliminate fk and comes to ck plus 1x totally in terms of previous ck's. Now, I introduce going into the diffusion. This is purely jump process. I call my CXT as the first passage.
Sorry for interruption, sir. You have 5 more minutes, sir. Please summarize like that.
Sure, very good. Now, I go into the diffusion limit. When I go into the diffusion limit, my front density is very large, and the first moment is 0, the second moment is finite, and we take the double-sided Laplace transform. When I go into the double-sided Laplace transform, I am proceeding to the limit, I get the diffusion equation. Therefore, the Markov jump process turned out to be the diffusion equation, and therefore in this diffusion equation, we know already the solution, and hence the diffusion equation of heat conduction will similar to the diffusion equation of the Brownian motion, and the solution is known. Now, the Cxt and Ckx are all there. If we proceed to the limit, my Cxt turns out to be the product of the delta function. That means is equivalent to introducing a negative source at minus x0 at time equal to t equal to 0. That is the first image. This image decides the first passage time to the negative side. If you go into the 2 times boundaries, we go into the 2 times boundary at x equal to 0 and x equal to a. I write down the same process, but now I have the 3 generating function. The generating function within the barrier, the generating function to the left side of the barrier, right side of the barrier. I can go into the Wiener-Roth decomposition to arrive at a generalized word identity for all the generating function. By Wiener-Roth decomposition, I can split up 1 minus Z5 into 2 functions, and using Lowry's theorem of complex analysis, I can go for Q0 in terms of Q1, Q2 in terms of Q1, and similarly I can go for Q1 and Q0 in terms of Q2. That will generate the images of all the refracting barrier. Now we go, since is want of time, Z0 is written as the Poisson jumps, the generating function. Similarly, boundary crossing generating function. Now what is that? Now write down these component, these function for the W line. Introduce C1xt into CTxt integral differential equation. I can determine them. Ultimately, I go into C1xt into C2xt. Now you see that generate. The interesting thing is that all the images on the positive side go into these images on the negative side, C2 in terms of C1, and ultimately I now see that, or C1 in terms of C2, we now see that all these densities correspond to the diffusion densities, and hence we have changed gamma to gamma AN and replace the first moment 0, the second moment is finite, and hence we arrive at, say in the case of single barrier, my C1 dash turned out to be a delta function. Initially starting with x equal to dot, my first image is minus mu, so we go on changing the images on the 2 bounding planes which acts as mirror, and hence I write all these things in terms of C2n, and finally I now see that all these splitter images are now carried out. C1, C2, C3 positive and negative, minus mu indicates sinks, plus mu indicate. See, if you connect them all together, we ultimately arrive at the Cxt, and therefore the solution for the diffusion process. The solution for the diffusion process turned out to be in terms of the Green's function of the process. Green's function of the process is nothing but a solution of unbounded. Effectively, what we see that the first passage time solution can only be expressed in terms of the unbounded solution by introducing the compensation function. In this situation, even though we stated that is valid for in the case of diffusion process, this could be extended to any pure jump process, whether it is single boundary, a double boundary, and a moving boundary, and so on. It has stochastic boundary also we are carrying out. We published a few papers in American Neuronal Journal connecting with barrier moving in time using the introduction of compensation function. These compensation functions play a vital role in modern stochastic processes to deal with the passage time of crossing the boundary, especially in finance, storage models, inventory models, and QA. Several such problems are related to this continuous time, continuous space stochastic process, and hence the compensation function is a very appropriate technique to study the first passage time. Not only that, we can also find out the position of the particle at time t, what is the content of the tank at time t, what is the risk reserve at time t in a finance company, all these things, what is the length of the queue at a time, all these could be arrived at through this process in addition to the first passage to either of the boundary, which especially in neuronal spike trains plays a very important role if you consider the boundaries moving in time. Therefore, I see that with my chair giving me the restricted time to it, I have done little justification to this problem. I immediately go into some of the remarkable earlier journals of Kielsen. Kielsen is the first person who introduced the Green's function methods in probability, and Kepperman is the first person who introduced the winner of decomposition generalized Hydrological. Korsla and Jacker is the conduction of V. They play the immediate role. Our paper in 2018 in Springer Journal is connected with this type of problem, but through backward equation, not through the forward equation. Many more open problems are still there. I am quite sure on the eve of this conference, I like to place that our younger generation will take the initiative in pursuing not only this type of problem, many other interesting research problems. I thank Professor Professor Tirupati Rao and his team, and also the chair for giving me an opportunity to present my talk in this great mega centenary celebration of our C.R. Rao's conference, like virtual conference lecture. Thank you very much.
Thank you, sir. Thank you for your blessing, sir. Now, floor is open for interactions or any questions.
Sure.
Welcome.
Yes.
Professor Tirupati Rao?
Najim Sarif is asking, it seems.
Yes, please, the question.
Yeah, please.
Close the...
Najim Sarif, madam, you have to unmute and speak. Najim Sarif, madam, you have to unmute and speak.
Yes.
No, we are unable to listen to you. Okay. So you can carry on.
Professor Viswanathan, sir, you have any query?
Yes,
Yeah,
Professor.
yeah.
There is one doubt. Professor, this is regarding your Poisson jumps. Okay, specifically, the parameter associated with this Poisson jump, whether it has got any association with your diffusion parameter K.
No. Precisely, that is, they are independent. The Poisson jump is new. To go into the diffusion, we now sense the number of frequency difference is very large, and the average size jump is tending to 0 with a finite variance. But the diffusivity is independent of that. In way, if you want to connect it, the connection comes through the second moment. I can correlate K to 1 over D.
Okay. So possibly what I thought was there may be a K may indirectly influence your jump parameter. Thank you, Professor. Thanks for your explanation.
Professor Tirupati Rao, you have anything?
No questions.
Okay, sir.
I have to thank Professor P.R. Vittal sir for his presence here, sharing a valuable content because of his busy schedule. Now he is not that much idle. After retirement, government of Tamil Nadu make him more busy. He is a policy maker in education, and he is simultaneously visiting professor for many organizations in Chennai based. But in spite of that, he is making his time for us for sharing his valuable thoughts. Definitely, his work environment will help us. We will make it. Thank you, sir, for your humble presence, sir, and very valuable content, sir. Thank you.
Thank you, sir, for your good wishes, presence, and blessings to us. Thank you very much, sir. Thank you.
I like to continue my association.
Yeah. Now,
Madam Arvind Sarif, you are unable to make it audible. You have to unmute your mic, and from the last 3 days, we are facing the same problem. You have to rectify that one. We are unable to listen you. Your mic is not working. You are not making unmute. You make unmute your mic and speak. Please.
Sir, shall I go next, sir?
Just
a
wait, sir. Yeah. No question, sir? No question, madam? Okay, sir. So thank you, sir, Professor Vittal, sir. Thank you, sir, for your good wishes and blessings to us. Thank you, sir. Thank you, sir.
Thank you very much, David.
Thank you, sir. Thank you, sir. Now the next speaker is Professor Rajendra Prasad. Now, Professor is Professor is available? Professor Rajendra Prasad?
Yes, available.
Okay, sir. So I would like to just introduce about Professor. Professor Rajendra Prasad.
Just let me confirm whether screen is visible.
Is it visible this screen, sir? First, I am sharing.
Yeah, it is visible.
Okay, okay. Let I introduce first about our speaker today. Professor Rajendra Prasad, ICAR, Indian Agricultural Statistics Research Institute, and title of his talk is today Web Resources for Research and Dissemination in Statistical Sciences.
Welcome, Professor Rajendra Prasad.
Welcome, sir.
Thank you. Thank you, Dr. Tirupati Rao.
Welcome.
Now,
can I start?
Yeah, no, just a moment, sir. You give me some time, sir.
Yeah.
Now, profile, sir. Sir, NAS Recognition Award 2015-16 for significant contributions to social sciences, and National Award in Statistics for Young Statistician in honor of Professor C.R. Rao for the biennial 2010-11 in recognition of outstanding contribution in the field of statistics from MOSPI, Government of India. Professor P.V. Sukhagne Gold Medal Award 2010 from Indian Society of Agricultural Statistics. ICAR National Fellow January 27, 2005 to 29 April 2009. Dr. D.N. Lal Memorial Lecture Award 2005 from Indian Society of Agricultural Statistics. IARI Best Teacher Award 2002 for excellence in teaching in the discipline of agricultural statistics from PG School, IARI, New Delhi. NAS Young Scientist Award for Social Science from National Academy of Agricultural Sciences for the biennium 1999 to 2000. Best Paper Award for 4 times in the field of Applied Statistics 1995-96. Design of Experiment 1997-98, Design of Experiments 2002-2003, and Design of Experiments again 2010-2011 from Indian Society of Agricultural Statistics. Certificate in Merit under Young Scientist Award Program 1996, Indian Science Congress Association, and Gold Medal in MSc Agricultural Statistics from IARI, New Delhi. Nehru Medal 1988, the Best Student Award for MSc Agricultural Statistics from IASRI, New Delhi. Just a moment. And Dr. VVR Murthy Memorial Award 1988 for the Best Student MSc Agricultural Statistics from IASRI, New Delhi. And sir has 10 projects, published more papers in national international journals, and sir has fellowship, elected fellow of National Academy of Agricultural Sciences January 2011, fellow Indian Society of Agricultural Statistics January 2014, associate of National Academy of Agricultural Sciences since 2007 to 2010, elected member of International Statistical Institute, Netherlands, November 2008. Other recognitions are also there. Invited consultant, biometrician to International Center for Agricultural Research in Dry Area, Aleppo, Syria, Thrace, to April to July 2008, and June 2009, November 2019. Coordinating editor of Journal of Indian Society of Agricultural Statistics 2010 to 14, executive editor Statistics and Application Journal of Society of Statistics, Computer and Application 2010, associate editor Journal of Statistical Theory and Practice, published by Taylor and Francis since 2017, Agricultural Research Journal of National Academy of Agricultural Sciences 2016, Journal of Indian Society of Agricultural Statistics during 2006 to 2009, member editorial board, Journal of Indian Society of Agricultural Statistics 2006 to 10, Statistics and Application 2002 to 10, and Annals of Agricultural Research 2002 to 2008, PUSA Agricultural Science Journal of IARI Postgraduate School 2005-2014, Journal of Wheat Research, and Journal of Society and Advancement of Wheat Research 2014 to till date. Executive President, Society of Statistics Computer Application 2015 to till date. Vice President, Society of Statistics Computer Application 2014, and Secretary, Society of Statistics.
This has become too long.
Yeah. So I can now stop. I can refer to all the audience. Please visit to the ISRI website. I think more detail can be found for their understanding and their to know about SAR. Now it's our great pleasure to invite Professor Rajendra Prasad sir for the CR Rao International Conference. You are welcome, sir, for your presentation. You are please.
Thank you very much for your kind words. I know that many of those I may not be deserving.
No.
At the outset, let me thank Dr. Tirupati Rao and all of you as organizers for providing him an opportunity to participate in this great conference, virtual international conference on Professor C.R. Rao's School of Thought in Statistical Sciences. I have chosen the topic of web resources for dissemination of research in statistical sciences to the stakeholders. I know that being the last speaker in the session, that before lunch, and after
one more speaker is there. One more speaker is there.
Okay. After so many good, wonderful presentations since morning on the deep research in statistical sciences, I'll try to make it lighter and just share some web resources which are available for anybody to use for teaching, for students for learning, and stakeholders for making use of statistics. These are the resources which I'm going to talk about: Design Resources Server, Sample Survey Resources Server, Statistical Computing for NARS, and Krishi Portals. Let me begin with statistics without agriculture has no roots. Agriculture without statistics has no fruits. To quote Professor C.R. Rao, am I audible?
Sir, you have to share your presentation.
Sir, it is shared.
Yes, sir. Just stop sharing and once again share, sir. Sir,
I'll stop sharing and again share.
Yes, sir. Yes.
Is it visible now?
No,
It's
sir.
coming,
Yeah,
sir. It's coming.
Now visible, sir.
Yes, sir. It's coming, sir.
Okay.
Yeah.
Therefore, what I was saying is statistics is not like a discipline like physics, chemistry, or biology, where we study a subject to solve problems in the same subject. We study statistics with the main aim of solving problems in other disciplines. Therefore, this statement itself is source of inspiration for all of us as statisticians. And you all know the famous two quotes from Professor C.R. Rao: if chance is antithesis of law, then we need to discover the laws of chance. And all knowledge is in the final analysis history. All sciences are in the abstract mathematics. All judgments are in the rational statistics. Professor C.R. Rao made a presentation as keynote address during an international conference on statistics and informatics in agriculture research in 2006, sorry, it is not 16, on the topic, has statistics a future? If so, in what form? That was basically for when data science and data mining and machine learning were coming up, how statistics should go ahead. And this paper is available. Anybody can go through this paper. Final thoughts in that paper were: statistical models are competitive with those developed by computer scientists and may overlap in concept. Still, classical statistics may be saddled with a timidity that is not up to the speed of modern computers. And another, we view this pile of data as an asset to be learned from. The bigger the pile, the better if you have the tools to analyze it, to synthesize it, and make yourself more and more creative. And if I go through the International Development Corporation 2018 reports, they have said digital transformation is not about evolution of devices. It is about the integration of intelligent data into everything that we do, and where each station has to play a role. The data-driven world will be always on, always tracking, always monitoring, always listening, and always watching, because it will be always learning. And our Secretary, Department of Agriculture Research and Education and Director General, Indian Council of Agriculture Research, he said statistics is like a salt in the food. No one recognizes its importance when it is there. Everyone feels its importance when it is not there. But I also say that statistics is not only a salt, it is also a sweet. It has to be taken before and after the meals, before starting the study for planning properly, and after the study for better interpretation of the results. To commemorate 100 years of Professor C.R. Rao, we at ISRI has brought out a document which is of C.R. Rao's life sketch and his influence on designing of experiments with a special reference to agricultural sciences. And this document is available at this URL in the Krishi portal. This highlights all his work in design of experiment vis-a-vis Indian context. For anybody who is interested in design of experiments can go through this article. In statistical sciences, important and useful contributions have been made, and synthesis of research in statistical sciences with other sciences enabled improving the quality of agriculture research. But problems of science, other sciences are very complex, and application of statistical sciences to agricultural sciences are known to you. Therefore, for a strong initiative to strengthen e-learning and e-advisory service so as to benefit the stakeholders, we have made the following efforts. Many web resources developed at ISRI. Two prominent among them are Design Resources Server and Sample Survey Resources Server. And there are many more which you can see at isri.icr.gov.in. This is, let me begin with the Design Resources Server. And before starting Design Resources Server, let me quote Professor M.S. Swaminathan, the person who is responsible for bringing green revolution into India. He said, it is the effective use of tools of statistical design of experiments that paved the way for green revolution. Design Resources Server is an e-advisory and e-learning resource. It is open access. I can say it is international public good because no user ID, no password, nothing license is required. Only internet with browser connection is required to use whatever is available on this resource. It is a copyright of ICR. Views across 800 cities of 108 countries. The basic aim of this is to popularize and disseminate research and design of experiments among the scientists in India in particular and researchers all over the globe in general. And this initiative was taken in 2005 and it is hosted at drs.icr.gov.in. This is open to everyone from all over the globe. Anyone can join this and add information to the site to strengthen it further with the permission of the developers. The goal is to spread advances in theoretical, analytical, and applicational aspects of design of experiments among mathematicians and statisticians, both in academia and also involved in advisory and consultancy services. It has 2 electronic books on design analysis of agricultural experiments and advances in data analytical techniques. A lot of lectures and other material is available. Exposition to software packages, particularly SAS, SPSS, and Excel, useful in statistical analysis of data, followed by statistical principles on various topics, and their real-life applications are also available. Here, what we have done is the real-life data sets we have given. For classroom teaching, the data sets can be downloaded. Question asked by the experimenter or the stakeholders are put there, and if we have those software, what are the steps to be used? Those are also given along with the analysis and syntax. Then catalogs of designs useful for various experimental settings and the bibliography are other important highlights of this server. Server also provides links to other sites that are supposed to be useful to statisticians as well as the experimenters. Most importantly, it provides generating randomized layout of online basic designs such as CRD, randomized complete block designs, both for single factor and multi-factor experiments, Latin square designs for single factor experiments, augmented designs, square lattice designs, resolvable block designs, incomplete block designs for making all possible pairwise treatment comparisons, designs for bioassays, block designs with factorial treatment structure, row column designs for factorial experiments in 2 rows, mutually orthogonal Latin squares, all for prime and prime powers, Adamant matrices up to order 1000, whatever is existent, orthogonal arrays can be generated, designs for experiment mixtures, response surface designs. These all designs can be generated using this portal. Now we have also started one more, basically on R, generating R modules and putting it, linking it here, and that we have set as Design Resources Server with R, and that is also available as drsr.icr.gov.in. It has a facility of ask a question, where a question is asked and it goes to the developers, and developer try to answer the question. But more than 250 questions received through ask a questions have answered by now. It is a matter of fact a mobile library on design of experiments, dynamic in nature, and new editions are posted on it from time to time. Ultimate objective of this server is to provide e-advisory service and e-learning. Whole material is divided into 4 broad categories, but mainly 2, for experimenters and for statisticians. When I say experimenters, all direct application things are put under this link, and where more knowledge of statistics is required before making use, those has been put under the link for statisticians. But there is no bar. Statisticians can look into the material which has been provided under the link experimenters, and experimenter can see the material which has been provided for the statisticians. It has links, site information. It is a registered copyright. It has links under Wikipedia. It has links under CGIAR resources. It has also link at many other places, including on SAS, where they have cited our Aram matrices generation under SAS. Then these are the books which are available on this portal, Statistical Analysis of Agricultural Experiments. This book contains all steps in SAS as well as R. All steps for analyzing the data sets with real life data sets. Then there is a significance of experimental design in agriculture research where real life applications have been given. The design resources server, which I have been talking about, a bulletin is available. And then Indian NAR Statistical Computing Portal, I'm going to show you that bulletin is also available on this portal. Then second is sample survey resources server, where which has been put for advances in sampling theory for the statisticians in academia, the practicing statisticians involved in advisory and consultancy services, scientists in national agriculture research and education system, the statisticians involved in conducting large-scale sample surveys, particularly in the national statistical system, with focus on agricultural statistics system. The basic idea is that it should be able to help designing a survey, estimation procedure with support of online software for computing resources, analysis of survey data and e-learning resources, useful to surveyors in agricultural sciences, biological sciences, social sciences, industry, and in statistical organizations in the center and the states in planning and designing surveys and then analyzing complex survey data. These are the facilities which are available. Electronic books on theory of sample surveys and survey data analytical techniques with emphasis on agriculture. E-material content of sampling theory. List of books on sampling theory, sampling techniques. Bibliography on important topics like provides definition of some commonly used terms in sampling theory and history of statistics in timeline. It also provides online calculator for sample size, basically for the 2 situations when interest is in estimating the population mean and population coefficient of variation is unknown, and also when population coefficient of variation is known. When we have to estimate population proportion, it provides sample size calculator for when population coefficient of variation is unknown and values of a preliminary sample are used for estimation of coefficient of variation. Then for nowadays, small area estimation for local area planning is the buzzword because sample size at small area are not enough to have precise estimate. Therefore, small area estimation theory has been developed, and all these literature on small area estimation theory is made available here, along with all R packages that can be used for development of this small area estimation theory and analysis. Therefore, all those have been made available on this. Therefore, this is expected that material provided at sample survey resources server would help the survey practitioners in general and in agriculture sciences in particular. Then next, I am talking about that we have generating a strengthening statistical computing resource. It is a platform for statistical computing for basically for our national agriculture research system. But many manuals, many lecture notes have been provided on this, which can be accessible across the globe. Particularly, there is one which is complete on RStudio on the analysis which are to be carried out in the normal routine. All those steps along with data sets have been given in RStudio, which can be made use of by anyone across the globe. And a lot of those have been downloaded. We have more than 10,000 downloads for that particular manual. And there are several manuals on SAS, JMP, and data mining are also available. We have also done a service-oriented computing module where a user is not required to have software at their desktop. They can access it through IP authentication of their institute, and 24 different analysis can be done. But at present, it is available only for Indian National Agriculture Research System organizations like state agriculture universities and ICR institutes. But simultaneously, we are developing another one in R, which will be accessible to all. And a few modules of this we have already transferred to that we are doing along with Kerala Agricultural University. This has a lot of page views across the globe. Then I can skip through this, and then let me come where many of the resources which can be made use of are available. It is ICR Research Data Repository for Knowledge Management. We call it as Agriculture Knowledge Resources and Information System Hub for Innovations. Data management and research data availability is the must, because they are the bloodline of research data systems and intellectual property rights. We have national level, we have open data government policy, which is hosted at open.data.gov.in, and I request a lot of data from different ministries are available on that site. And my request to this group would be that make use of that data which is available in open domain on that site, that open government data platform, for furthering the statistical sciences, particularly the data sciences research. And similarly, we have for ICR for research data management, and we have 6 repository: experimental data, survey data, observational data, mainly weather data, publication repository, where all publications we are providing, whichever are in open domain, will be available and anyone can download and read them. Technology repository developed by ICR, and then spatial visualization of all spatial data along with analysis. For this I can skip through because may not be of interest much. Here we are providing single window access to all online resources of ICR institutes. If anybody interested in statistical sciences applications or agricultural sciences can go through this. All more than 40,000 publications and 700 data sets are available, which has more than 10 lakh downloads and more than 15 lakh views, including those fetched by other sites. It has been indexed in Google Scholar, Byfield search engine, and directed to open access repository. Then there is an inter-portal harvester, where we are harvesting the metadata records of all open access repository. And at present, we have more than 5,90,000 metadata records, which anybody across any sector across the globe can make use of for literature search. For technology repository, we have more than 1270 technology in public domain. These are very useful, particularly in the period of pandemic, to reach to the stakeholders. And there is ICR Technology mobile app as well. And then there are many videos and audios which can even be used for text mining for the people who are interested in data science. 2,100 plus videos and 54 audios from different institutes are available. More than 300 mobile apps are available on this portal. Then for data management at micro level, particularly for all India coordinated research projects, which are basically the projects where any variety or package of practices which is thought of novel is tested across all the agroclimatic zones of the country before finalizing and recommending it to the stakeholders. We have ICR Geo Portal, where more than 100 layers from 50 themes are available. These are very useful, particularly with respect to natural resource management, animal science, animal livestock population, and others. And more importantly, we are depicting on daily basis points of crop residue burning at all India level of all crops from June 1, 2019 till date, and paddy residue burning in the month of October and November till date. Then we have this resource available on Open Government Data Platform and many other platforms. These are technology mobile apps. Then if you want to have any information about ICR Institute, that is this proper management practices itself contributes around 20 to 30% increase in yield. And whatever may be the good amount of seed we take, if you do not do proper management, it will not give you the good yield. Proper management is much necessary.
Organically grown food grains, do they have a better pest resistance than a chemically grown food grain? Just last question.
Not necessarily, sir. Not necessarily.
Because
not
I did an experiment.
Organic, if the proper integrated pest management strategy has been followed by the farmer and it has been certified, then only there is a chance that it will not have any pest problem. Otherwise, that's why I said that I would prefer a safe and heavy metal free food rather than having an organic food.
To get an expert like you is a very rare thing. I have done some small work for ITC where neem versus malathion. I found that the neem is capable of killing the pest better than malathion, but malathion had 14% residual in the food grain. This was the outcome of my statistical study. What do you say about
that is true. That is true, because residues is the problem in chemically grown food. Residue is the basic problem, and that's why Government of India now has introduced neem coated urea. Because neem coated urea has two basic facilities. One, it is a slow release. Therefore, small 5 to 10 kg per hectare can be saved in urea. And secondly, when it is neem coated, it takes care of many of the pest problems as well. Yes, neem is one, and there are many other natural insects and our plants which take care of pest problems naturally.
Why not neem coated become made mandatory? Finally, why can't
it is mandatory by government now? It is mandatory. Only urea which is available in the market
because
is
we
neem
have
coated
another
urea.
speaker is waiting from a long time.
Thank you, sir. Thank you, sir.
Thank you,
sir. I appreciate your patience.
Thank you, Professor Rajendra sir. He has given a lot of ideas in spite of busy schedule. He has given a lot of inputs to our people. I am sure people will definitely will benefited with this your ideas what you given today, sir. Thank you, sir. Thank you very much for your nice talk. Thank you, sir. Thank you. Now the next speaker I would like to call upon Professor. Just a moment. Dr. Deepak Yam Sakte.
Yeah.
Whether sir is available?
Yeah, I'm here. I'm here.
Okay, sir. Okay, sir. Sir, yeah. So I'd like to share. Just a moment. Yes, Professor Deepak Sakte is going to have a talk today on smooth threshold estimating equations based variable selection in zero inflated Poisson regression. Today, yeah.
Who is speaking? Tell me again.
Yeah, the last I just the last speaker is Deepak Yam Sakte. Yeah. Just a moment. Yeah. So, sir, I have professional experience, associate professor, Department of Statistics, Applied Mathematics, Central University of Tamil Nadu, and assistant professor, Department of Statistics, Shivaji University, Kolhapur, and postdoctoral fellowship during 2015-16, Department of Biostatistics, Epidemiology, Augusta University, Augusta, USA, and sir is project fellow and during 2009 July to December, Department of Statistics, Shivaji University, Kolhapur. Sir has prize and awards here. Stood first in order merit at MSc Statistics, Shivaji University. Stood first at third year BSc project competition conducted by SUSTA 2006. Stood second at third year BSc level quiz competition conducted SUSTA 2006 and received certificate of merit in 4th National Science Olympiad in 2004. And his research interest is robust estimation and model selection in regression, non-parametric inference, and research paper 13 paper he has published, and major research project ongoing on variable selection in zero inflated model for regression analysis of count data, and by DST solve, and teaching experience during 2009 to 19 and he has given invited talk and in symposium workshop 13 and workshop seminar conference organized 11. With this introduction, I would like to request and welcome sir, Professor Sakte sir. Please deliver your talk, please.
Thank you, sir, for your nice words. Good afternoon, everybody. At the outset, I would like to thank the organizers of this conference for giving me an opportunity to share my work in this esteemed gathering. So, without wasting much of the time, since already we are at the end of this session, I shall directly begin the presentation.
Yeah, please.
Today I'll be talking on smooth threshold estimating equations-based variable selection in zero-inflated Poisson regression. The plan of my talk would be like introduction to what are zero-inflated models. Then I shall throw some light on STEE, and then I shall give some glimpses of my method which I have proposed, and I shall conclude through some simulation results. So zero inflated models, they are actually used to model count data, and as we can see, like in practice, there are a lot of situations wherein count data is encountered. For example, like if somebody is interested to manufacture, somebody is interested to model defects in manufacturing as a function of some regressors, or some like number of school absences as a function of regressor. Usually what comes to our rescue is a zero inflated Poisson regression model. There are some other models also available, but in most of the situations, one can find the zero inflated Poisson regression model to be more appropriate, as it takes care of the extra Poisson variation which is present because of this unnecessary occurring zeros in the data. So as a remedy, Lambert in 1992 proposed a Poisson regression model, in which the response variable is actually considered to be mixture distributed. Like one can see that there are some zeros which are coming from a degenerate distribution pi or pi, and the remaining component is from Poisson with mean mu I and has probability 1 minus pi. As we can see in the Lambert's paper, a fantastic computational approach has been presented through EM algorithm, and one can easily estimate the parameters involved in the zero inflated model, which has two components, like one is zero component, other is Poisson component. Unlike in generalized linear models, wherein we have just one component, that is the response component, here we have like two components. One is the Poisson component and the other one is zero component. Both can be affected by the regressors differently. So we may have like two set of regressors, and the problem becomes more complicated when it comes to variable selection. So variable selection is actually one of the important steps in the model building, and identifying suitable variables, or rather necessary variables to be included in the model is an important task. If we fail to identify proper regressors to be included in the model, the prediction ability of the model can come into question. So, so finding necessary variables becomes really vital. There are several approaches in this direction. One can look into the literature, but very few approaches are available as far as zero inflated Poisson model is concerned. If you look into the regression, there are two broadly speaking classes, like one is all subset methods and other is like a regression, penalized regression approach. Penalized regression approach works in a fantastic way, in the sense that in a single go, one can identify which variables are necessary, and at the same time the estimates of the non-zero coefficients can also be obtained consistently. So this is really overwhelming, and it was given by it started through the paper of Tipchirani when he proposed lasso as an alternative to ridge estimator, but as a byproduct he could notice that it is also providing variable selection. So penalized regression came into existence as a byproduct of some shrinkage estimator. given by Mishra. Later on, it was developed by many people and currently SCAD, that is smoothly clipped absolute deviation penalty, has been used to perform variable selection in models like linear regression model or generalized linear model or even generalized linear mixed models and so on. If you look into the literature for the zero inflated count data, very few methods are available for performing variable selection, and those I have listed on the screen. One can see like Bu, Zheng, and Wang. So these all proposed some variable selection methods. The Bu and Wang, they are actually having some SCAD penalty-based estimation method, while Zheng has used adaptive lasso to propose a variable selection method. They are, of course, as far as theory is concerned, they are perfect. But when it comes to actual fitting of data using this model and finding the estimates of the coefficients, their performance is not so good. That motivated us to propose another method for variable selection in zero inflated Poisson regression. We base our method on the estimating equations given by Ueki in 2009, which were initially given for linear regression. The concept is fantastic, which was again carried forward by Gao and others in 2017 to propose variable selection in GLMs with high dimensional setup. And now we are actually trying to use these smooth threshold estimating equations to define a variable selection method for zero inflated Poisson model. So let me just take you through the smooth threshold estimating equations. The standard way of doing variable selection is to add penalty to loss, and here the loss function is negative of the log likelihood, and we have a penalty over here. This is the penalty function. There are several penalty functions, and as I told you, like lasso, adaptive lasso, SCAD, MCP, and there are so many penalty functions available in the literature, but they exhibit performance differently, and sometimes one is better than the other. There is no universally best method as such available, and this motivated us to come out with one more method, which may be considered as an exceptional alternative to existing methods. So Ueki proposed the substitution of this penalty function by some weight functions, and it is given in this particular way. So once we substitute that as this Wj into x squared divided by 2 in this form, then the resulting estimations can be given in this particular form, where D denotes the dimension of the covariate space. So under the reparameterization, we can see that the same equations can be expressed as like what is mentioned in 4, and the same thing can be expressed in matrix notation like this. So the entire framework can be seen in this particular way, and we can immediately see that these estimating equations involve some constant like lambda and tau. So these lambda and tau, they are actually some thresholding constants, and they can be chosen in a proper way in order to get the computational algorithm converged. Now what we do is we use these smooth threshold estimating equations in the context of zero inflated Poisson model, and develop a computational algorithm for estimating parameters involved both in zero component as well as Poisson component. The parameters involved in zero component, they are denoted by gamma, and those who are involved in Poisson component, they are denoted by beta. So these are the steps for computing these gammas and betas using smooth threshold estimating equations. Now, as I told you that there are two tuning constants present in this setup. One is lambda and the other one is tau. We need to select these tuning constants properly so that the resulting estimator will enjoy some nice properties. I shall talk about those nice properties shortly. Before that, let me throw some light on like how these tuning constants are selected in some other methods which are already available in the literature. Earlier, people talked about using cross-validation or generalized cross-validation for selecting tuning constants. But later, it was showed that GCV is not producing consistent estimator for estimating those regression coefficients. So Wang in 2014 defined a BIC type selector for zero inflated Poisson setup, and actually we also use the similar kind of stuff with the coefficient estimates replaced by what are obtained using our proposed algorithm. The structure of the selector or the criterion is same as our BIC criterion, Bayesian information criterion, but it is not exactly BIC because the estimates which are replaced in this are not maximum likelihood estimates. They are obtained through some other method, and therefore it is the word type comes into picture. So minimizing BIC type selector results in the estimate. So we choose that value of lambda which produces minimum BIC for a given problem. Tau is actually set to be 1 in our entire simulation studies because it was suggested by Gao that setting tau may usually lead to a suitable choice of lambda, and further we get whatever the estimates we get, they are satisfying some nice properties. So we try to establish some theoretical properties for the new method. The first theorem essentially tells us that the consistency of our estimator, we can see that the resulting estimator is Rootian consistent. And second theorem essentially tells us that the variable selection procedure what we have proposed is actually consistent, and as n goes to infinity, the subset selected or the variables set of variables selected by our method is equal to the set with probability approaching to 1 as n goes to infinity. These results can be they have been proved theoretically, and also empirically we could see it in the simulation study. I shall just demonstrate the results from the simulation study. And of course we are one more thing I just forgot to mention, we are still in the developing stage of this method, and asymptotic normality we are establishing, and we are almost at the end of the step, but still we need some additional things so as to come out with the full-fledged result about their asymptotic normality. But other results can be empirically validated as well. So simulation study, this is just a set of parameters which we have used for, we can see like there are pretty large number of regressors chosen, and 20 regressors we are talking about with the different values of the coefficients. And regressors are generated from multivariate normal distribution with the sigma matrix with like all diagonal elements are 1, variances are 1, and off diagonal elements they are not 0, they are generated according to like sigma ij is equals to rho to the power absolute I minus j. And we can see that the value of rho is changed throughout the simulation study. Rho is chosen 0, which makes all regressors independent. Rho is also taken to be 0.4 and 0.8. So slight multicollinearity is introduced into the setup. And 3 different sample sizes are considered, and the samples were drawn 1000 times, and median relative mean square error and some other properties of the estimates were recorded. So we can see in the table that the proposed method, that is ZIP STEE, produces the smallest mean square median relative mean square error, and we can see the as far as this Poisson component is concerned, exact fit achieved is at a higher percentage than the existing methods for the same setup. As sample size increases, it is almost approaching towards 1. For 0 component, we can see it is sometimes ZipSCAD is sometimes better, but as we increase the multicollinearity component, then the proposed method becomes better in both the cases, both in zero case as well as Poisson component case. So these are the results for rho is equals to 0.8 Poisson component and also the 0 component. So essentially the take-home message from this is that the smooth threshold estimating equations, which are easy to handle, can be applied to almost any type of modeling situation wherein we have a well-defined likelihood function, and the variable selection can be done consistently, and even the it will be very early to say that the estimates possess oracle property, since we have not yet established the asymptotic normality, but soon we'll be able to say the same thing, that they will be oracle, they will be satisfying oracle property. These are some of the references.
Thank you, sir.
Thank you for paying attention.
Thank you, sir. Thank you for your nice presentation. Now floor is open for the audience. Any questions, query, please welcome. I think there is no question. Any question is there? Any query? Yeah, please, sir.
I want to have a small clarification from the presenter.
Yeah.
Dear Prof, sir. Zero inflated Poisson distribution, as you suggest, probability that there will be zero defects will be 1, and elsewhere it is 0. It means that a system with 100% good products. Can you throw some light on this?
And actually, in zero inflated Poisson setup, usually we have a mixture, like zeros are coming from two sources. One is a degenerate source and the other one is the Poisson source. So there is no like complete thing like probability that 0 is equals to 1. It is not always there. It is 0. The probability that 0 is not exactly 1, but it is coming from like two sources. We can see one is from degenerate and the other one is from Poisson.
Okay, Professor. Thank you.
Yeah.
Anybody else, sir? No. I think.
Sir, I have one question.
Yeah, please.
Sir, when you are establishing your consistency of your estimators, you have a statement like probability of AN goes to A0 and this probability goes to 1.
Yeah.
And what about, how will you fix that A0?
Yeah, so what I'm trying to tell is AN is actually the index set of the regressors, and A0 is the optimal set. A0 is the index set of the optimal set of regressors. These are not the estimators, they are indexing set. And what we do is we try to show that this set essentially becomes A0 as n goes to infinity.
Yes, sir. That A0, how will you fix it?
That is the set of necessary predictors.
No,
it's just like our true coefficient. We cannot fix it. It is the true set of coefficients.
That means in case of simulation studies, we can have such things because we are generating, we have A0 and sample will give AN so that we can verify convergence. If it is not a simulation case, I think fixing of A0 is going to give some trouble, is it not?
Yeah, see, it will give some trouble, but it can be sorted out. We can have like two different sets of models. One is like correct model and the other one is like wrong model. Now, correct models are those models which have regressors. Along with the necessary regressors, there may be some additional regressors. And in case of wrong models, necessary regressor, at least one necessary regressor can be missing. We can show in the first step that the model selected using our method falls in the class of correct models. And in the second step, we can show that the criterion, whatever we are using over here, like we are using the estimation process, that estimation process leads to the selection of the optimal subset in the class of all correct models. It can be done, sir.
Okay, sir.
A detailed proof is available. I can share it with you later.
Yeah, thank you, Professor. And one more thing is very fundamental regarding the model itself. See, in the model you have a probability attached with 0p, Okay, and 1 minus p for the Poisson component. Okay, so can you have, because you have done many simulations and you have done EM estimators and other things, do you have any suggestion that if this p is less than certain cutoff value, we can either go for pure see, it's something like a zero component, or if the p is greater than this, you can go for, sorry, it's the other way I'm talking about. If p is greater than some cutoff point, okay, we can go for pure Poisson, or less than something, we can go for zero component with something like a binomial, Bernoulli sort.
It can be done, but we have not yet found that particular value for p, because here in this case, like p is not constant, it is pi. For every I, the p is changing.
Okay.
If we fix value of p for every I in the regression setup, the variables are not identically distributed. So for every yi, we are having a pi. So there is no single constant which we can fix it over here. It may happen for distribution setup. What you are saying?
Okay, see, having a different pi, even we can have something like a maximum of pi if you can have a cutoff. So I will put the question in that way.
In that case, we can do that, but we have not yet thought in that direction, like how it can be done. But the but the thing is really fantastic. I would be looking into this aspect soon. Thank you, sir.
Thank you, Professor. Thanks for your nice explanation.
Okay, sir. I think one more person wanted to have. Yeah, Saman.
Yeah. Can I pose a question to Dr. Deepak?
Yeah, sure.
Yeah, Dr. Deepak, I'm from IIT Kanpur. I have a question, but I don't belong to the statistics field. So please, I have apologies right at the beginning. This Poisson, if you have to choose between Poisson and negative binomial, are there any tests that you can apply? And second, is it necessary to have a right tail distribution for applying Poisson or zero inflated Poisson? And third, if it's a panel data, there will be extra conditions to apply this zero inflated panel?
Okay. So
Poisson. Sorry.
So let me begin with your first question. You said that Poisson, you have to choose between Poisson and negative binomial. If you are in distribution setup, you can go for the goodness of it, and you can check the AIC or BIC criteria, and accordingly you can choose which one is better for your current data. And if you are still in regression setup, still the same thing can be applied. You can go for AIC or BIC criterion to choose amongst which one is better. It depends on the data in your hand. If it is over dispersed, negative binomial may be more appropriate than Poisson. And the last thing I'm missing, can you repeat the last question?
Yeah, the second question, that for Poisson or zero inflated Poisson, is it necessary to check for, say, right tail distribution, that lower values come with higher probability? Is that necessary? Like your visits to the health center, lower one or two should come with higher, and the larger values come with, say, lower. Is that necessary?
Poisson is already a positively skewed distribution. So essentially, if your data is showing positively skewedness, then you can, I guess, go for this. You don't need to verify again whether it is still positively skewed or not.
Okay. Thank you so much.
Now, so let us thanks to the speakers. Thank you, sir. Thank you very much for your nice talk. Now,
thank you very much for giving me this opportunity.
Conference, Professor P. Tirupati now, please.
Thank you, Dr. Naveen Chandra, for your nice way of conducting the proceedings. I will come to you back again. Thank you, Dr. Deepak Sakate, for your nice presentation. And right now you are working with Central University of Tamil Nadu, am I right?
Yes, sir.
Good. Your work is very novel. Hope your Poisson zero inflated Poisson regression is having a very good scope of research, and you have chosen a very nice topic, and it is very apt for the platform. So I congratulate you for making this topic as for presentation purpose.
Thank you, sir.
And today we have 8 speakers. Start from Sarath Gore from Pune University. Then Muralidharan from MSU Baroda. And Rahul Gupta ji from Jammu University. Shila Mishra from Lucknow University. Professor Aram from right now from MS University Tirunelveli. And Professor P.R. Vittal from Chennai, a leading mathematics professor. And the next speaker, last but one speaker is Professor Rajendra Prasad, and now Deepak Sakate. All talks are very lucid and having good thought-provoking, and some are informative, some are innovative, some are thought-provoking. So therefore, I am very much thankful to all the speakers of today's morning session for their sparing of valuable time as well as valuable content to present on it. And we want to announce one thing. All the speakers are requested to share their presentations. If there is no any published work is there, okay. If there is any unpublished work, you need not share it also. But if you make something modifications, if you would like to provide that soft copy, it will be helpful for the participants. I request you to send a portion of the part at least, if not all, to the participants so that we can give the circulation. And one more proposal, it has come. We are making some what we call it as evaluation of papers for picking the best papers for in 2 categories. First category is invited talks. Best talks we are going to pick the papers. And second one is technical papers also, we are picking best papers. We have conducted the quiz competition yesterday with around 1,500 people participation. And finally, with 4 rounds of quiz competition, we finalized 3 names. And that 3 prizes are cash prizes, 5,000, 3,000 and 2,000. And that prizes and the best papers or best speakers among the invited talks, best papers among the technical papers, all these things we are planning. We are making some conversation with Professor C.R. Rao, and if his health and other things permits, we request him to give the date and time of valedictory of length of 1 hour or 2 hours. So if it is good on us, if God is in our favor, he may agree. So in that case, we will make one event add-on program, because some speakers we are unable to accommodate. By accommodating that speakers as well, we will create one valedictory function event. Like inauguration, it was happened on 10th September. Like that, we are planning valedictory function on some other day, not tomorrow. So at that time, we are expecting the participation of Professor C.R. So virtual award ceremony may be there. We are hoping, if that is the case, we will inform you all people again. And I request you all to make your time convenient to join the valedictory function exclusively. Okay. So with this request, I thank once again the speakers as well as our chairing session, Professor Naveen Chandra, for their very effective way of running the program. Naveen Chandra is very particular of conducting the proceedings on time based. So time management is very much concerned about Naveen Chandra. He did it well because 8 speakers, all speakers, very lucky that all are presented and all have given their valuable talks.
Thank you, sir.
And regarding the speakers on the screen, Harivarignan has given a very wonderful talk that embedding inventory theory and queuing theory, it is now actual requirement. Professor Vittal Saab already having a commendable work on the storage models, and he's a giant in stochastic processes, and really sparing the valuable time by them, a real fortune or luck part of the participants today watching. Some are watching through Google Meet, some are watching through YouTube. So throughout the globe, people are watching our program because it is spreading from morning 9 a.m. to evening 10 p.m. So they are choosing their selected talks only. We cannot compel all the people to attend all the sessions without break. There are so many issues, technical issues, and other practical issues also. The sparing weekends also is another issue. So, in spite of all these issues, and resource persons are kind enough to spare their valuable talks, and participants, among participants, there are very valuable people are there. Very knowledgeable people also there in the participant side. So I congratulate and I thank all the people to spare their valuable time for morning session. Now I declare that invited session for morning time was completed. Actually, our lunch time is 1:30 to 2:32 today. Now it is the technical session will be started as usual. So now we can declare that the invited talk session of morning part is completed. Thank you, Randall. You be on the board if you wish. Otherwise, you can log off and log in also. That is up to you.
Thank you.
Hope everybody received my links. There are 2 parallel sessions. Will be started from 2 to 5. 2 to 5. You can choose your liking session basing on the link. If you have any issues, if anybody is having issue, please let me know. I will act accordingly. Thank you. Thank you, one and all. Thank you, sir.
Thank you.
సతీష్ రాలేదా ఇంకా అక్కర్లేదు.
Good afternoon. Hello.
ঠিক আছে।
Yes.
Madam,
Hello.
if you want, you can start now. Shall I stop the presentation?
Sir, Ramakrishna sir.
No, I am the admin.
Good afternoon, madam.
Sir, am I audible?
Yes, madam. Is
Sir,
audible.
good afternoon, sir.
Good afternoon.
I joined other link, then sir said
Acha.
in the
Okay.
my calendar it came like this. Okay, sir.
Acha.
Okay.
Okay. Just within a few minutes, we will start our session, madam.
Okay, sir. Okay, sir. I'll wait. I'm not late, no? That's okay.
Good afternoon, madam. Good afternoon, madam. Hello.
Sir, good afternoon, sir. Good afternoon, sir.
Ma'am, from yourself you can send the PPT, ma'am. Hello.
Okay. Oh, so hello.
This is
Sir,
technical
actually, I will send today night, and I
yes,
will. Sir, my presentation tomorrow invited talk regarding invited talk. You are asking the PPT. Sir, am I audible?
No, ma'am. I am presenting.
Yes, madam.
Session presentation.
Sir, okay.
This is a technical file section.
Yes, sir. You want what do you want, sir? You want your PPT
From here,
to
I have
share?
to present the paper, ma'am. Yes.
Okay.
After.
Sir, Ramakrishna sir, he wants to present there itself. Okay.
Okay. Just after introducing the chairperson, then you can start our session. Okay. We can wait for 2 minutes. We will start our session. Satish.
Yes, sir. Thank you, sir.
Is it Ankita Sharma is available? Ankita Sharma?
First person.
Sangeeta Das?
Yes, sir. I am available.
Okay. And yes, Satish is already now he is contacted. Richa Saini?
Okay.
Yes, sir. Yes, sir.
Okay. Gulbun Farik Dar?
Yes, sir. I am available.
Okay. Right. Next. Muhammad Hussain Yam?
Yes, sir. Yes, sir.
Okay. Yam Tiruvanchu Korusu. Tirunav Korusu. Wasma Jan is audible. Okay, Venkata Ramareddy. K. Venkata Ramareddy garu. Sachinarayana. Yogeshi Bangar.
Yes, sir. Yes, sir.
Okay. So, before going to start our session, let us introduce our chairperson, Captain Dr. K. Shweta. She is a professor and head of the Department of Mathematics, St. Joseph College for Women, Visakhapatnam. Captain Dr. K. Shweta is present head and professor of mathematics and statistics, has 23 years of teaching experience in St. Joseph College for Women, Visakhapatnam. She completed BSc with combination of mathematics, physics and electronics and stood college first with 87% in the year 1992. She completed MSc Mathematics from Acharya Nagarjuna University with a distinction and stood University second in the year 1994.
Ramakrishna.
Yes.
Hello, Ramakrishna.
Tirupati.
So you have you received the presentation of Captain Had you received the presentation? Rahul Krishna. Speaker presentation, PPT we have sent.
Did you click on present now? Presentation profile వచ్చింది. We got the profile. We got the profile of Sujata madam.
Yeah, profile. Profile you have to disclose and introduce her.
No, already. We have to share it.
Yeah, you share it. Share it and then you introduce.
Yes, sir. I know that. Yeah, you know that, right? Okay. Yeah. One more announcement to that. Whoever is presenting, please turn on the camera because we are recording all these presentations. Okay. So we have to turn on the camera as soon as the presentation.
Please mute.
Okay.
Audio, sir.
Present now mode. You have to make it.
Okay, I'll do it.
Sir, I'm not able
Sir.
due to some problem.
Yes.
Sir, நீங்க வந்து இன்னொரு செஷன்ல லைன் பண்ணீங்க அத ஆடியோ மட்டும் மியூட் பண்ணுங்க. ஆடியோ நீங்க டிஸ்டர்ப் ஆகும்.
Sir, I did it and rejoined and did present.
நீங்க விஷ்ணுவரன் சார் லாகினே இருக்கீங்க. அவங்களோட செஷன்ல இருக்கீங்க. டெக்னிக்கல் செஷன் 6 ஆல்சோ. உங்களுடைய ஆடியோ மட்டும் கரெக்ட் வால்யூம் கரெக்ட் கம்மி பண்ணுங்க. ஓகே. இப்போ நீங்க Yes, sir. Continue, sir.
Ramakrishna, any problem to you?
Just I'm putting her profile here. Just now downloaded.
Okay.
Okay, we'll do one thing. So we'll take another presenter. Maybe I'll let him join.
Unmute and speak, sir. Ramakrishna, sir. Other participants, please mute your mic yourself. Don't disturb to other participants. Mr. Satish, please mute your mic.
Are you ready? Yes, sir. I'm ready. You can start.
Sir, Tripura, sir. Sir, Ramakrishna, sir, you just continue, sir. Ramakrishna, sir. Sir, please unmute your mic and speak, sir. Yes, speak. Continue, sir.
Okay.
Yes, sir.
So, can you share that madam's profile there? Or photo? Tirupatra?
No, sir. No, sir.
Okay.
We're just having a PDF or a PPT, sir.
Sir, I have a profile with me. Just I'm reading her profile now.
Oh, okay.
So, Captain Dr. K. Sujata madam is a head and professor, Department of Mathematics and Statistics, has 23 years of teaching experience in the St. Joseph's College for Women.
Ramakrishna, we are unable to see your presentation. There is no disclosing. There is no disclosing of your presentation.
The data we taken from the 2001 sheet. And this is the distribution of the number.
Sir, I'll display it, sir.
You display it?
Yeah,
You just share, ma. You just share.
So now is it visible, sir?
No, it's coming. Okay, right. No, it is present visible.
Okay, sir.
Okay. So now I can introduce our chairperson.
Yes, sir. Yes, sir.
So she is Captain Dr. K. Sujata, head and professor of professor in Department of Mathematics Statistics, and has 23 years of experience in teaching in St. Joseph College for Women, Visakhapatnam. She completed BSc with combination of mathematics, physics, and electronics, and stood college first in with 87% in the year 1992. She completed MSc Mathematics from Acharya Nagarjuna University with a distinction and stood university second in the year 1994. She was awarded MPhil degree in 2007 and she got a doctorate degree on 29th December 2016 from the Department of Applied Mathematics, Getam University, under the able guidance of Professor A. Chandrasekhar, Department of Mathematics. And her title of PhD thesis is Contribution to the Fixed Point Theory in Cone Metric Spaces. She completed one UGC minor research project in the year March 2016 for 2 lakhs rupees. She participated and presented a paper in international conference at Harvard University, Boston, USA, held from 23rd to 27th May 2016. And also this paper was published in the International Journal of Arts and Science, IJSS, and Academic Journal of Science and CD-ROM. She participated and presented papers in 21 international conferences and 65 national conferences or seminars in the surrounding country. And also she attended 65 international and national conferences and seminars. She published 55 research papers in international journals and 12 research papers in national journals. She has been serving for St. Joseph College as an NCC officer since 20 years. She received 3 times Best Associate NCC Officer Award at the group level among 3 districts, Vijayanagaram, Visakhapatnam, and Srikakulam. She is one of the Board of Studies members in various colleges in Andhra Pradesh and chairperson in St. Joseph College. She is the organizing secretary and coordinator for 2 conferences organized by the Department of Mathematics, namely UGC sponsored 2-day national conference on recent advances in mathematics and its applications. And the second one is recent advances in mathematics and mathematical sciences in 2016 and 19 respectively. So one of the editor of the editor board and the journal, namely Bulletin of Mathematics and Statistics Research, with ISN number 2348/0580, and she is the coordinator of national workshops in 2019 on multiple integrals. She is the life member of the various prestigious professional bodies like APSMS and IMS and UASMS and Professor Meenakshi Sundaram Memorial Society. And she received so many awards in academics as well as in NCC. She got Best Teacher Award in 2016, presented in each year by the college to make the contribution of the faculty for the Best Performance Award. And from Girls Battalion also for her meritorious service. And she received Bhartaki Anmol Ratna 2019 Award for extraordinary contribution in education, mathematics towards the development of the Bharat in true sense, presented by Tejasvi Archita Foundation, New Delhi. Adarsh Vidya Saraswati Rashtriya Puraskar, National Award for Excellence in 2020, presented by the Gelser Research Journal Foundation and Global Management Council. And so ILDC AMP Women Excellence Award 2020, presented by International Leadership Development Council, and Academy of Management Professionals. These are simple, brief biodata of our chairperson who is chairing today's technical session. Now I welcome you, madam, to to chair the session of today's technical sessions. Thank you, ma'am.
Thank you, sir. Thank you for your nice presentation.
So, now Ankita Sharma is available. Ankita Sharma.
Yes, sir.
So please present your presentation.
Okay, sir.
Take 8 to 10 minutes. Please start, ma'am.
8 minutes, sir. I am sharing my PPTs.
Okay.
1 minute, sir. Sir, is it visible?
Yes, ma'am.
Can I continue now?
Continue, ma'am.
Okay, sir. Good afternoon, all of you. I'm Ankita Sharma, research scholar of Department of Statistics, University of Delhi. Today I am here to present my research paper. The title of my research paper is Multi-State Markov Model for Predicting the Natural Disease Progression of Type 2 Diabetes based on Hemoglobin, that is HbA1c. The outlines of this paper is: diabetes is a common non-communicable disease, especially in developing countries like India, posing a huge economic burden on the family and nation as a whole. Type 2 diabetes can lead to complications like skin disease, heart disease, kidney disease, foot ulcer, and etc., and can increase the risk of dying prematurely. The multi-state Markov model is a useful way to describe state of a disease over time. In this research article, we have illustrated the usefulness of multi-state Markov model in the analysis of follow-up of type 2 diabetic patients. The valuable information provided by the HbA1c test has rendered it as a reliable biomarker for a diagnosis and prognosis of diabetes. What is the objective of this paper? The main objective of this paper is to assess the importance and significance of HbA1c as a useful disease marker for type 2 diabetic patients by using a 3-state Markov model. For this, patients are classified into different 3 states on the basis of their available baseline value of HbA1c. Here clearly you can see state 1 is based on the ranges of HbA1c, when HbA1c lies between 4 to 5.6 value, and state 2, the value of HbA1c vary from 5.7 to 6.4, and state 3 is when the value of HbA1c goes greater than 6.5. State 1 is a normal state, and state 2 is a pre-diabetic state, and state 3 is a diabetic state. Additionally, to capture the effect of transition intensities, transition probability, mean sojourn time in each state, and also expected state specific survival time have been assessed. To find out all these components, I have employed multi-state Markov model in a modest way. The literature review is: historically, HbA1c was first isolated in 1958 and characterized in 1968 as a glycoprotein. The elevated level of HbA1c in diabetic patients were reported in 1969. Baum et al. Identified the pathway leading to the formation of HbA1c in 1975. Shweta et al. Concluded HbA1c as a reliable biomarker for the diagnosis and prognosis of diabetes. In studies of many chronic medical conditions, the health status of a patient may be characterized using a finite number of disease states. A wide range of situations like HIV, AIDS, breast cancer, dementia, diabetic retinopathy, and liver cirrhosis had presented the use of multi-state Markov model to assess the dependence of risk of death on marker level or disease state. Marshall et al. Discussed the application of a multi-state model to diabetic retinopathy under the assumption that a continuous time Markov process determines the transition time between disease stages. Begum et al. Had developed in 2016 a 9-state continuous time Markov chain model for quantifying disease progression and the time-dependent influence to relevant risk factor for diabetic foot patients, and then tested this model on the real-world data. To the best of our knowledge, no study has been conducted for evaluating the disease progression of type 2 diabetes using HbA1c as a disease marker in multi-state Markov model. What is a Markov model? Multi-state model is a model for a continuous time stochastic process allowing individuals to move among a finite number of states. In this analysis, the 3 states of disease progression of diabetic patients are defined based on the established ranges of HbA1c. The 3 reversible transient states are defined as follow: state 1, state 2, and state 3. The systematic representation of the proposed model is shown here. The state 1 is a normal state, and state 2 is pre-diabetic, and state 3 is a diabetes. This is a systematic representation of 3-state Markov model. This is a modeling of multi-state Markov model. Here you can see lambda is a transition intensity, and the transition intensity, these are the properties of transition intensity. This is a P is a transition probability that is defined by P11 when individual in state 1 at time 0 will be in the same state at time t. That's after the calculation I have found out the expression for P11 is e raised to the power lambda 11 t, and for P12 is when an individual in state 1 at time 0 will be in state 2 at time t, and this is the expression which I have find out after the calculation. All these are the expression for P21, P23, and P22, P3, and all for the matrix component. Classification of the states. This is the classification of the state. To study the transition of diabetic patients from one state to other, we have decided that the states will be categorized on the basis of HbA1c value, which have been observed, and then on the range of HbA1c, the 3 transient states can be defined as table 1 presents the classification of states. Material. The study population include 246 type 2 diabetic patients who were diagnosed during January 2000 to December 2011. The mean age of patients at diagnosed was 26.12 year, and standard deviation was 7.60, ranging from 10 to 49 years. The descriptive characteristics of important prognostic factors are summarized in table 1. This is in table 1. Here, all the important prognostic factors have defined, and mean value standard deviation is also mentioned there. This is a result and discussion. The study population, table 2. Table 2 is a number of observed transition between the states. This is a number. Here clearly you can see there is only 4 transition to go from state 1 to state 1, and only 3 transition I have find out from normal state to pre-diabetic state, and only 2 transition from normal to diabetic. Here I have observed that the maximum transition is among the diabetic state to diabetic state, that is 59. And on the basis of my system, on the basis of my data, it is a 76% for the transition between diabetic state to diabetic state. Table 3 is the estimates of transition intensities with 95% confidence interval using multi-state Markov model. Here, this is a transition intensities to goes from one state to other states. It's mentioned there. And table 4 represent the estimated 1-year transition probabilities. And table 5 estimate 4-year transition probabilities. Table 6 is the estimated mean sojourn time with 95% confidence interval. Here we can see the maximum mean sojourn time is in diabetic states and minimum in pre-diabetic states is a 0.38 and in the diabetic state is 1.65. Mean sojourn time describes the average period in a single stay in a state before moving to the state, which is found to be 1.14, and the 95% confidence interval is 0.43 to 2.99 for state 1, and 0.4 for state 2, and 1.65 for state 3. The estimated total length of time spent in each state is forecasted to be 4 months in normal state, and 5 months in pre-diabetic state, and 39 months in diabetic state. Implies that once a patient has diabetes, it is difficult to move to normal state and pre-diabetic state. The conclusion of my article is, in multi-state Markov model, by using transition probability and intensity, we are able to find out the probability and intensity to move to other state from another. The patient who have HbA1c, the value of HbA1c that is greater than 6.4%, showed a less chance of getting back to normal and pre-diabetic state, consequently more prone to develop complications. It means it is very difficult to move from if patients come in a diabetic state. If patient progress toward the state 3, then it is more likely to persist in that state. This research reinforces the common public discourse and lifestyle changes may delay the onset of complication. These are references.
Hello, a nice presentation.
Thank you, ma'am.
Any questions from the audience? Participants, any questions from the participants? Really, it is very useful presentation, madam.
Thank you so much.
This data is very useful.
Yes,
and that is exactly true. Yeah, given in the conclusion second point, no, HbA1c is greater than 6.5. If we get the diabetic in the future, so we will not get back non-diabetic. That is practically it's true.
Yes, ma'am.
Okay, ma'am. Any doubt, sir? NRK, sir.
So, any questions?
Yeah, I have one.
Stop?
You can stop, ma'am.
Okay.
I have one.
Sir, madam, somebody is asking something.
Okay.
In your study, could you decipher which factors lead a patient moving from state 1 to state 2 and from state 2 to state 3?
Sir, now my next paper is based on covariates. So now I am not reached on the conclusion. After reaching the conclusion, I will discuss with you.
Okay, thank you.
Which probabilistic factor is based more?
Okay, thank you, ma'am.
Thank you, sir.
So, Sangeeta Das, next presenter. Sangeeta Das, is it available?
Yes, sir.
Okay, please present.
Is it visible, sir?
Oh, now is coming.
Okay, so can I start? Hello?
Yes, you continue, ma'am.
Hello.
Yes, continue.
Okay. Good afternoon, everyone. I am Songita Das from NIT Rourkela. I am a research scholar. Now I am going to present my presentation, whose entitled Ordering Results for the Smallest Claim Amount from Exponential Location Scale Model. This is a joint work with Professor Esquel and Professor N. Balakrishna. And this work has been published in Methodology and Computing in Applied Probability. This is the outline of my talk. And now let x1 up to xn be in IIT random sample, and consider x1 and x2 and xnn are their corresponding order statistics. Due to different application of order statistics plays an important role in different area of statistics and probability. For example, we can take the minimum order studies here represent the x1n. Is very helpful in reliability and survival analysis. And whereas the maximum order statistics represent xnn, this is mainly this is often applied in stochastic modeling of flood and other meteorological phenomena. For more details on this, one can see these references. Now let us define what is the distribution function of xnn and x1n, which are given in equation number 1 and 2. Suppose x and y, two non-negative random variable having PDF, CDF, surveyable function, hazard rate and reverse hazard rate are these. Now let us discuss some basic definition which will be used to prove our main result. The first definition gives several stochastic orderings between two random variable x and y. Second definition gives the definition of Shore-convex and Shore-concave. This definition gives some measuration based orderings between two n-dimensional vector A and B. The claim amount. Suppose xi be a random claim amount which can be made by a policyholder in a particular insurance period, and also suppose capital II be the Bernoulli random variable which is associated with the random claim capital Xi, where capital II takes the value 1 if the ith insured person makes the random claim Xi, otherwise it takes value 0. Ti is the product of capital II into and Xi. This represents the total claim amount for the ith policyholder in a portfolio of risk. These are some lemmas which will be used to prove our main results. Now let us define our model. Here you consider exponential location scale family of distribution, and whose distribution function is given in equation number 4. It contains three parameters, lambda, theta and alpha, which are known as location scale and shape parameters. This model, one can easily see that if we fix the parameters, then we can easily reduce this exponentiated location scale family of distribution to location scale family and proportional reverse hazard rate family. These are some references from these literatures. We have considered our problem. So let us define our problem. Suppose x1 up to xn and y1 up to yn be two heterogeneous portfolios with n components, where each xi and yi follows exponential location scale family of distribution with different parameter alpha, lambda, theta and beta, mu, delta. And Ti with the product of capital IIXI and Ti star is the capital II star YI, where capital I and II are capital I star be the independent Bernoulli random variable independent of Xi and Yi respectively, with expectation Pi and capital Pi star. T1n and T1n star represent the smallest claim amount which are taken from T1 up to Tn and T1 star up to Tn star. The aim of this work is to develop different sufficient condition under which anyone can compare two smallest claim amount in several sense of stochastic orderings like usual stochastic order, hazard rate, reverse hazard rate, and likelihood ratio order. Now the distribution function of T1n and T star 1n are given in equation number 5 and 6. Before starting our main result, so let us assume these assumptions. Now the first theorem states that if under this assumption and if the location and scale parameters are fixed, then the reciprocal of the scale parameters are if the reciprocal of the scale parameters are connected with P larger order, weakly supermeasurized and weakly submeasurized order, then two smallest claim amount T1n and T star 1n can be comparable according to the usual stochastic order under this assumption. This theorem consists of two parts. In the first part, under this assumption 4.1, and if the parameters location, scale, and shape parameters are fixed, and if there exists a function psi which is increasing and convex, then if psi p is psi p measurizes psi p star in weak sense, then smallest claim amount of T1n is stochastically less than the smallest claim amount T star 1n. And the second part provides if the location parameters are connected with weakly lower supermeasurized and submeasurized ordering, then two smallest claim amount can also be compared according to the usual stochastic order under this sufficient condition. Theorem 4.1 and 4.4 gives different sufficient condition under which we can compare the smallest claim amount T1n and T star 1n according to the hazard rate order, where the former says more heterogeneity in the shape parameter and the reciprocal of the scale parameter leads less claim amount, and states that if the location, scale, and shape parameters are connected in this relation, then the smallest claim amount T1n is always larger than T star 1n according to hazard rate. Similar to the previous two theorems, here theorem 4.5 represent such type of sufficient conditions for under which one can compare the two smallest claim amount according to reverse hazard rate order. This is the last theorem in my presentation, and this states the two smallest claim amount can also be compared according to likelihood ratio order under these sufficient conditions. Thank you. Hello.
And any questions from presenters?
From the participants. What are the real-time applications for your research?
Madam, your comment. Shweta, madam, your comment on this.
Ma'am, in real life, there are so many realistic data like insured data or survival data, which are to feed this data, we have to consider the location parameter, this lambda. So this to compare to feed this data, we have to use this. It is better to use this exponential location scale model, and for the real life application, we can for insurance. Insurance company always try to calculate the total annual premium which is taken by insured person. They are always conscious about that. Either it becomes a loss or gain for this company. So From this, as an application of these theorems, we can say that under these sufficient conditions, which smallest claim is better for the company? This.
Thank you, Sangeeta ma'am.
Okay. So now, Satish.
You can start.
Yes, sir. Good afternoon, sir.
Satish.
Yes, sir. Shall I present now, sir?
Okay. Please present your paper.
Yes. Sir, shall I click present now? Sir?
Sir. Yes,
Please
sir.
share
You have to,
sir?
you have to press present now, sir.
Yes, sir.
Present now.
They are showing your entire screen. Yeah, window tab.
Click there. Click there. Click there.
Your entire screen. Okay, ma'am. Thank you, ma'am. Then share will come, ma'am.
No, now you just open your PPT.
Yes. Sorry, share it didn't open.
Please share your PPT.
No, you just go to a present now.
Yes, sir. Present now. Okay,
Tamil
sir.
தானப்பா?
தமிழ் தான் சார். ஷேர் காமிக்குது சார் அது.
ஷேர் கொடுங்க. அந்த உங்களோட ஸ்கிரீன் ஷேர் ஆகும்.
ஆனா ஷேர் ஆக மாட்டேங்குது சார்.
அது மேல செலக்ட் பண்ணுங்க. என்டையர் ஸ்கிரீன் மேல ஒரு டயலாக் பாக்ஸ் வருதா? அதை செலக்ட் பண்ணுங்க. செலக்ட் பண்ணுங்க.
ஷேர் அண்ட் கிளிக் ஆக மாட்டேங்குது சார்.
அது மேல என்ன செலக்ட் பண்ணுப்பா. மேல டயலாக் பாக்ஸ்ல கிளிக் பண்ணுங்க.
ஓகே சார்.
ஜஸ்ட் ரைட். அதுக்கப்புறம் செலக்ட் பண்ணிட்டு ஷேர் பண்ணுங்க.
எஸ் சார்.
இல்லையே ஷேர் ஆகலையே. வெயிட். இப்போ நான் நீங்க கீழே போய் உங்க பிபிடி வந்து ஓபன் பண்ணுங்க.
ஆமா.
உங்க பிபிடி ஓபன் பண்ணுங்க. உங்க பிபிடியை டவுன் ஓபன் பண்ணுங்க.
Okay, sir.
Continue பண்ணுங்க.
Good afternoon to everyone. I am Satish, the doing assistant professor in National Institute of Technology, Bhopal. Casting method. The stochastic process of time series analysis with reference to the hydrological data resource. So special thanks to Professor Tirupati Rao sir. He is a research advisor. My guide is Dr. Kadra Babu, associate professor. So my topic is the stochastic process. Basic is stochastic process and forecasting method. So using various statistical parametric approach, that is a hydrological data set. Okay. So the study has proposed to approach the time series analysis based on the stochastic process that are observed in hydrological data resource that consider different statistical measure for estimating the parameter. So is the Thomas Varying model. This model is more popular understanding the dynamic hydrology time series data. So the testing the seasonality in fact the core objective of this study. The prediction through the time series model explored from the stochastic process have carried out. So the generated downscaling data. Downscaling means you have to some undertest data. We have to segregate. So should about the when you predict the value future, you should know about the present value. The present value always depend on the past value. So that is the resultant analysis, hydrological evidence, the benefit at upcoming period with the respect to the water level, the water flow production, water power hydrology measuring model. This application of stochastic process, which are trained in hydrology, management science, seasonal period, and climate change can be predicted stochastic development, ARIMA, and MLE method. So these are some collected for literature survey. The Walsh and Pendle pointed out the highly popularized ARIMA model could be successfully applied in time series forecasting related to many areas. So it's also the promising tools, the modeling, empirical, the dependence between the success times. Lewis and Array, they mentioned the non-linear modeling by using the time series analysis, change and Boyer estimate the low flow using watershed and climate parameter are adequate, simulating the daily data set. So these are my locations. Still now in Tamil Nadu, I covered the 2 locations. First one is Satunu Dam, other one is Andhra, that is Mantralayam gauge site. So I went to Satunu Dam physically and observably collected from the Public Work Department. The Satunu Dam is located in Tirunelveli district from 54 km and Vellore district from 106 km. This is the location of the study region. So I collected from there March 2019, that is 12 days, daily data set. This is 25723 is the water level. 232.37 is the predicted, that is the ST, that is the normal equation. ST equal to A plus BT, stochastic fitted value. So from this equation, the table 1, so I have to using the R code, that is the auto correlation function per day's data, then observed value. So then here you can see that the auto correlation function and the standard error, and using the box Jenkins statistics, it will be standard error will come 0.176, 173, 170, 167. It will be decrease the water level based on the environment. So I'm doing the using SPS software, auto correlation function observed value per day's data at Shantanu Dam. Table 3 is represented as the result of partial autocorrelation function daily data set, and table 4 is the fitted value result of autocorrelation daily.
Madam, maybe she is stuck due to any internet network issues. No?
Maybe, sir.
Hello?
Okay, proceed.
Okay, thanks. So this is table 4 is represents the fitted value of residual autocorrelation function daily stage data. Thomas varying model. The equation 1 is represents the extended Thomas varying model in order to analyze the time series for daily data, that is water level data from Shantanu Dam. Linear stochastic model known as both Thomas varying model and Aram used in this study. So I'm giving some symbols, that is alpha ij is the predicted discharge for the jth month from j minus 1 month at time I, and the qj is the mean monthly water level data during month j. Then in comma j the correlation coefficient for the jth month and j minus 1 month. In the comma j plus 1 is the coefficient of j plus 1 and the jth month. So this is the result, that is equation 2 is represented as the root mean square error, and the equation 3 is represented the mean absolute error. So finally I have derived as RMSE and MAU will be the root will be 0.9. It will be offset the data. Is the maximum likelihood estimation of the water level data using Gaussian distribution. Equation 2.1 is represented the per day's data, that is 1 to 31 x minus mu whole square to 2 sigma square. Equation 2.2 is represented as taking original expression, they given the value. You have to take the logarithmic equation. Then we have to finally 2.3 is represents the logarithmic to obtain the 31 days or 12 days. So after that, the equation 2.4 is represented as the some value you have to find it with respect to mu, and finally we obtain the mu, that is the mean. Then similarly we get the sigma, that is standard deviation. So finally I have to comparison which model is the best for suitable for the data set. So comparison of the result from Shantanu Dam water level data on extended Thomas varying and the MLE method. Here you can see the extended Thomas varying model MLE method will be same. It will be equal to same, that is mean and the mean be same, 228.4, 228.4, and the standard deviation also same, 3.03, and the standard deviation 0.03, 3.03. Here I have mentioned this error estimate, root mean square error, that will be 0.9. So our data will be accepted. Mean absolute error will be 0.03. The figure 8 is represented as the residual value for autocorrelation function, partial autocorrelation function. So I given the mention this R code, that is random series. Suppose you need some 1 year data, unless the daily data, or 5 years data, you can use this code for using R language, that is lag under the main random series of n of 0,1. So the figure, the 9 is shows the discharge level 15 to 16, November to February daily data set. So what is the main objective? What is the conclusion? That is the predictor, that is the future value using all hydrological data set. So now only I'm doing the research work in the hydrological department. Next research work I'm going to COVID-19 bioscience, like that only. So what is the conclusion of this article means the statistical gaps between the water level not having the current time series of the data. It is inevitable use modeling presenting an appropriate trend and close to the calculate the data. In present study, to find the future trend among the water level, the local downscaling time series model were used. The time series model have rich level, different and diverse structure in modeling discharge level forecast. However, the present model is perfectly suitable for water level. To predict the local future time series can be generated. Therefore, the mentioned method can be used for being aware of the water level, the probability occurrence of the flow in the future years. So these are the reference. Thank you for attention. Hello, any questions, sir?
Any questions?
So please stop your screen.
Sir?
Stop sharing. Stop sharing.
Stop sharing. Okay, sir. Thank you giving this opportunity for Professor Tripati Rao, sir. Can any questions?
Thank you, sir. Nice presentation.
Okay. Thank you, ma'am.
Any questions from the participants? Okay, sir. Sir, you can continue.
Yes,
okay. Okay. Thank you, Satish.
Sir, thank you, sir. Thank you so much for.
Richa Sani?
Yes, sir. Yes.
Madam.
Yes, sir.
Please present your presentation, ma'am.
Okay, sir.
Richa, madam, please share your PPT, ma'am.
Yeah, sir. I'm just trying. Sir?
No, madam. Yes, madam. We are not able to see. Are you presenting, madam?
Yeah, presenting, ma'am. I have just started doing it, and that is on my screen.
Please just click your person now. Or
yeah.
trying to present. Yeah.
No, it's coming.
No, it is coming.
Started?
You just open your PPT or presentation in our screen.
Present. Okay. This is from mobile. Now, are you able to see?
No,
madam.
So just try in your laptop or desktop. No. Try in your mobile.
Yeah, I'm trying from my laptop.
You just
I'm able to see.
Just try in present now. Just click a present now.
Yeah, present now. Yeah, I'm just trying.
Just click that entire screen.
There only.
You just click entire screen.
Yeah. I clicked on the entire screen.
You just select that dialog box is coming, right? You just select that screen and click share.
Shall I stop and again share? Shall I stop and again share it?
Just
try.
Just leave the meeting and just again.
Just give me a minute. Wait, sir. Tried and it was happening. I tried from my own link in Google Meet.
Just leave the meeting and just rejoin me.
Okay, sir. Okay, sir. See?
No, madam.
No.
No?
No.
Yes, it is
Just
coming.
wait.
It's coming.
Yeah, it's coming.
Something is coming.
It is coming.
Now open your PPT.
Okay.
Now
Maybe
just open your
it is
PPT.
due to network
Desktop
issue. Maybe.
screen. It's coming now.
Just continue.
Okay, proceed, ma'am.
Yeah, it's coming.
It's now coming.
Okay, sir.
Proceed.
Okay. Thank. Good afternoon, everyone. Honorable chairperson and the organizers and coordinators of the conference. I first of all, I would like to thank you all for organizing such a conference and providing us the opportunity to attend and present in the conference. And this conference was, I have attended the invited talks as well. So this conference is really very informative. Now, introducing myself, I'm Richa Saini, a research scholar from Delhi University, and the topic, my current topic on which I am going to present has been written under supervision of Professor Gurpreet Grover and co-supervision of Dr. Vajala Ravi. The topic of my presentation or the paper is Markov chain modeling of persistency for life insurance in India. Let us be introduced with the life insurance and the problem of persistency, what exactly they are. Life insurance is a long-term contract which remains alive through the periodic payment of premiums. However, due to non-payment of premiums on mandatory due dates, the contract ceases to be enforced. For life insurance sector, this is known as problem of low retention of customers, or more precisely, the problem of low persistency. In Indian scenario, persistency has been found to be considerably low over the decades. Life insurance products include term insurance, which are also known as high-risk plans, saving plans, health plans, pension plans, and unit-linked insurance products, which are also called ULIP plans. However, the data under ULIP and pension plans are scanty, due to which it is difficult to evaluate the performances of these products in market. But yes, in the present study, we would be evaluating performances of other three products: term insurance, saving plan, and health insurance. And the cohort of policies is studied for assessment of status of policies every year for the next 3 years after the inception of policies. Analogies which have been used broadly in this paper, throughout the paper. Enforced policy is a policy when insurance premiums are coming or on time or regularly paid at every due date to cover the risk insured. Critically lapsed policy is a policy which is lapsed for not more than 2 years and may be revived again. Finally lapsed policy is a policy which is lapsed for 2 years or more than 2 years and cannot be revived. Such policies exit the book of the insurance companies as per the latest IRDAI amendments in Insurance Act. The study are to estimate the one-step transition probabilities for the transition probability matrix with crucial states, namely enforced, critically lapsed, and finally lapsed policies under each broad type of insurance product, to evaluate 3-year period probability of persistency for each type of product, to test the validity of Markov chain model of order 1 in the study, and to identify the gray insurance products out of the 3, namely term, saving, and health insurance products. Our status of policies is assessed exactly after a year only. That is, multiple transitions during the year have been passed over, as these transitions are really very difficult in real life also, practically also, to be captured by the insurance company. So they don't have the robust system for doing so. Due to the grace period of 1 month for paying premium, the policies are assumed to be enforced if their first unpaid premium date lies in the month of evaluation of status. Lapse sessions are concentrated during the mid-year and revivals occur at year end. Required model is the Markov chain model of order 1, and the methodology is explained in the subsequent slides. The stochastic process under study is uh, having the discrete state space, namely enforced policies, critically lapsed policies, and finally lapsed policies, which are also denoted in subsequent slides by 0, 1, and 2. This is the transition graph shown in the slide uh, for our model. The transition probability matrix is also displayed here, whose transition probabilities are like from 0 to 0 the transition is possible, from 0 to 1 the transition is possible. That means the enforced policy may remain in force next year also. An enforced policy may transit to critical lapsation state, but no direct final lapsation in one step. Similarly, from state 1, that means from critical lapsation, the policy may again be revived and may transit to state 0 or the enforced state, or next year it may transit to state 2, which is the death or the final lapsation status, cannot remain in state 1. Like the critical lapsed policy cannot be critically lapsed policy next year also, because for 2 or more than 2 years the policy has to exit the book. State 2 is an absorbing state, like a death state, and that means once the policy gets finally lapsed, it is lapsed forever. It rarely happens practically that insurance companies organizes special revival campaigns after 5 years or 10 years, where the such a long lapsation period despite the such a long lapsation period of 5 year, 10 year, 15 years, the policy can be revived. Although this is also practically very impractical from customer point of view, because after such a long period, some other products with low premium and with almost the same benefits appear in the market. So that's why we have kept state 2 as an absorbing state. Above TPM shows that the model is similar to the 3-state illness death model with recovery, but no transition from a life to death state. That means from enforced to final lapsation state. And this is similar to the model introduced by Chiang. The only difference is that transition from alive to death is there. Using Chapman-Kolmogorov equations and taking into consideration the two contagious time interval, following differential equations are obtained for evaluating the transition probability from 0 to 0 and from 0 to 1. But there does not exist any intermediate state between state 1 and state 2. So evaluating the expression for these probabilities is rather easy and straight and direct. So we have direct. But to solve the above system of first order linear differential equations, Euler's approximation is used. And these are the approximate expressions for one-step transition from 0 to 0 and from 0 to 1. But as we can see that these expressions, these approximate expressions are also depending upon the transition intensities. So before estimating the probabilities, we need to estimate the transition intensity. intensities. For estimating these intensities, the multiple state model as described by Seveldrup and Waters is employed. For evaluating the transition intensity using above approach, the estimation of transition probabilities is also carried out. I will be showing the results in the subsequent slides. But before after estimation, the research doesn't get over here. After estimation, it is essential to check the validity of applied Markov chain model of order 1, what we have fitted. For the purpose, following two tests are utilized: the chi-square test for goodness of fit proposed by William P. Lowry and Donald Guthrie, the test for randomness of data proposed by Agar. In both approaches, the alternative hypothesis is same, being the Markov chain model of order 1, the best fit. This is the alternative hypothesis under both the tests. Model results. Here are the model results. The transition probability matrix estimated under health insurance shows that there is a least probability of being revived from critical lapsation to revival and going back into the enforced policy, and 42% are the approximately 42% chances are there for the health product to be enforced next year or the next in the next step. The probability of transiting from critical lapsation to final lapsation is highest, which is approximately 78%. For Markov chain model of order 1 under the product did the favorable result and established that the model is a good fit. Persistency for 3 years period is evaluated as 0.174566, which is pretty low. Transition probability matrix under saving insurance is displayed in this slide, and here we can observe that approximately 54% chances are there for a saving product to have to be enforced every year, and fact the highest. In subsequent slides we'll be noticing and we'll be observing that this is the highest probability of being enforced under this type of product only. But the probability of lapsation from critical lapsation till final lapsation is also highest for the product. Validity check for Markov chain model of order 1 again yielded the positive result in favor of the model, and the probability of persistency for 3 years period under the savings product is little higher than that under health insurance, and it stands at 0.249945%. 0.249945. Transition probability matrix under term insurance shows that there are 44% chances of a term product to be enforced, and the probability of getting lapsed from critical lapsation till final lapsation is around the health product. Validity check here also provided the favorable result. The probability of persistency is again evaluated under the product which is nearing the other three products, and it is also pretty low. Insurance product, the one-step probability of being enforced is lowest. The probability of persistency for 3 years periods is also lowest. The one-step transition probability from critical lapsation to final lapsation is high. And for saving products, the one-step probability of being enforced is highest among 3 types of products. But the probability of transition from critical lapsation to final lapsation is also again highest for the product. Of persistency for 3 years period is quite low for saving insurance too, and the similar results are existing for term products also.
Richa madam, please conclude, ma'am.
Yeah, we are. I'm just on conclusion. There is lot of network issue at my place. All the three conclusions are all the three products are not performing well in Indian sector on the basis of probability of persistency for 3 years period. Still, savings insurance is best performing among the three on the basis of one-step transition probability of being in force as highest. Term insurance product is performing better than the health insurance product, and the grayest area is health insurance offered by life insurers. The major reason for low retention for all the three types of products could be bogus policies, which happens on a large scale for health insurance offered by life insurers. Mis-selling of products, this also happens in case of saving and term insurance products. Comparison between benefits of health insurance with those under Mediclaim, and people understand that Mediclaim is the better policy rather than the health insurance, which is not. A health insurance is a complete product. Comparison of returns on saving product with those offered on other high risk pure saving instruments available in the market, whereas they forget or they don't understand the importance of death cover also offered by the insurance companies along with the returns on saving elements in the savings insurance products. Poor after sales service by agents. Term products are considered to be useless in young ages, and accidents are considered as rarest of the rare event kind of a thing. That's why the persistency problem exists, and how it is exist, and how which areas are the gray areas if we compare product wise, we have evaluated here. These are the references. The references. Thank you so much for attending my presentation.
Any questions from presenters?
Yes, I have a question.
Sir is asking.
Sir, I have a question.
Yes, sir.
Okay, sir.
Here is the question. Richa Rawat.
Richa madam, sir is asking.
Richa Rawat. Okay, nice presentation, and your work of application of transition probability matrix approach to explore the probabilities of its likelihood is a very interesting work. Is it real-time work or what you have done? You just come out of the presentation, no problem. Come out of the presentation. Okay, now you have given
okay, I just stop sharing. Yes, sir. That's okay. I'm out.
So you have given.
Am I out? Am I out, sir?
Yes. Okay.
Okay.
You have given three states of transition. I may a little bit late arrival. So may I know what are the state names? 0, 1, 2?
So 0 means the enforced policy state, then it may move to critical lapsation, which policy has lapsed but not for more than 2 years. And 0 state means enforced state. It is the notation. It is the notation only for denoting the state. If the policy is enforced, it will be denoted by 0. If it is lapsed, it will be denoted by 1. If it has been finally lapsed, it will be denoted by 2.
Okay, one state 1. What is the state 1 definition? Am I audible?
Answer where the policy does not get. Yeah, sir. I'm just saying. Are you able to listen, sir?
Yeah. Yes,
Actually, state one is the critical lapsation of. State 1 is the critical lapsation of policy, where policy is cannot be lapsed for more than 2 years. In 2 years, it has to be lapsed, and it could be revived again also.
So you have given a states that what is the? It is a maturity state. Second 2 means state 2 means.
State 2 means a final lapsation. If it is lapsed for more than 2 years, then it has to the the insurance company.
Is it something like a maturity state?
No, no, sir. It is the final lapsation state. If the policy is lapsed within 2 years, the lapsation is 2 years. The lapsation is final lapsation. Cannot be revived. It cannot be revived. The policy has to exit company's account.
Okay.
Amended
Okay.
IRDAI Insurance Acts.
Okay.
So
So
to categorize it into 3 states because a policy. What, sir?
what is the data source? Where you got the data?
Sir, commercial line of business and my. Yeah, sir. It is the commercial lines of business. The social line of business I worked in LIC, sir, as actuarial for 5 years. Right? So I had data
Right
from
now,
LIC.
right now, what you are? Hello?
She's not there, I think, sir.
The network issues are there. Very, very interesting work. That is what I
Yes,
want to make something. Anyway, I will contact her later. I will contact later her with my address. No problem.
Actually, she worked with
Because
LIC.
my two research scholars are working on finance modeling. So this work is more similar to them. So therefore, I am interested. Anyway, she has some issues. Okay, no problem. Carry on, madam.
Okay, sir.
Continue, continue.
Next present.
Just G. Faruk there. Is it available? Faruk there. So Faruk there.
Yes, sir. Yes, sir.
Not
I'm
there,
ready,
I
sir.
think.
Yes, sir.
He's there.
Please
Share your
share your
PPT.
PPT.
Actually, he is working. Gulbadinder is my student. He is working on financial modeling. Of course, just for change, he is just applying it to COVID related. Extension of Markov models to hidden Markov models. Let us listen to him.
Okay, sir.
Am I audible, sir?
Yes, sir.
Is the presentation coming, sir?
Yes.
Okay,
Thank you, sir.
Your presentation is partially visible. I think you have to scroll it. You have to see that slide.
Is it coming now, sir?
Yes, coming.
Is it full?
Yeah, now, no. It is something missing completely. Note down. Okay, no problem. Carry on.
Okay, sir. Respected professors and other participants, good afternoon, one and all. I'm very thankful to the organizer for giving me such a great opportunity to present my paper. My name is Gulbadin Farooq Dar. I'm a research scholar from Pondicherry University in the Department of Statistics under the supervision of Professor Tirupati Rao. And I'm going to present my paper under the title Hidden Markov Models for Studying COVID-19 Prevalence in Tamil Nadu. So first I would like to read my abstract, then we will go to the proposed study. COVID-19 prevalence is influenced by several uncertain factors. It is a communicable disease. In this study, we propose hidden Markov model approach to estimate the intensity of COVID-19 by considering visible states as rise and fall there is a rise of COVID-19 patients and fall of COVID-19 cases per day in Tamil Nadu, which is influenced by over prevalence in Indian context is hidden, and hidden states is transition, namely increase and decrease COVID number of cases, cases in Tamil Nadu. We assume visible states here is V1, we denote it by V1 and V2, where V1 denotes the rise of COVID-19 cases in Tamil Nadu and V2 denotes the fall of COVID-19 cases in Tamil Nadu. However, there are two hidden states that are influencing the visible states of the COVID-19 prevalence in Tamil Nadu. They are denoted by H1 and H2 respectively. But H1 in this case is the increased COVID-19 cases in India, in the whole country, and H2 is the decreased number of COVID cases in the whole country. The study aims to explore the probability distributions for the visible states for a run of 3 days ahead. Mathematical relations for different statistical measures are derived in this study. We consider the data source from Wikipedia daily observations on COVID-19 test positive cases. And further sensitivity analysis carried out with the developed model. Predictions for projected values are obtained from the derived mathematical relations. This study will help the healthcare management in finding the key statistical indicators. And these are my key words for this paper: hidden Markov model, COVID-19, transition probability matrix, and statistical predictions. This is the overview of my presentation. The overview starts with the introduction regarding COVID-19, and then it follows the stochastic models, then Markov processes, then transition probability matrix, then we will go towards observed probability matrix, and the final proposed hidden Markov model, and then we will see probability distributions for sequence of different visible states. There's probability of, as we have denoted this V1 and V2 as visible states. We can calculate probability of V1, probability of V2, and probability of V1, V2, and like. This is the introduction related to COVID-19. So I would like to skip all these slides because the time will not permit me. And this is the literature review.
Go to the model. Go to the model.
Yes, sir. Notations and terminology of hidden Markov model, or the model which we have proposed. Hidden Markov model is characterized by the number of states in this model are 2. The number of observation symbols are M is equal to 2. The state transition matrix, which is denoted by A, and the observation probability matrix, which is denoted by P, and finally initial probability matrix, that is denoted by pi, and this is the model. Now we will go towards the specifications. Here n is equal to 2. This is the number of hidden or invisible states. Here I1 and I2 are invisible states, where I1 is the increased number of cases and I2 are the decreased number of cases per day in Indian context. And M is equal to 2. These are the number of visible states, and here the number of visible states we denoted above V1 and V2, where V1 is the number of cases will rise in Tamil Nadu, and V2 is the fall of COVID-19 cases in the same state. And for A, the state transition probability matrix, where the elements of this matrix are denoted by Aij, where this Aij is equal to probability of xn is equal to j, given xn minus 1 is equal to I, which is that means the state of the system will be in state J, given that the system was in state I. These are the elements of the transition probability matrix, and we have observation probability matrix. This matrix is denoted by B, and the elements are Bij. These are from hidden states to visible states. That is here from Indian context to the Tamil Nadu cases. And finally, we have pi, the initial state probability distribution, where pi is equal to probability of invisible states. Probability of I1 is equal to pi1, and probability of I2 is equal to pi2. Here, probability that the number of cases will increase is equal to pi1, and probability that the number of cases will decrease is pi1. Okay, here in this model, we use the property called Markov property. It is also called the Markov chain. The state of the system at time t plus 1 depends only on the state of the system at time t. That is, this process depends on the future, depends on the current only, or the current depends on the immediate past. That is, past and future are independent, and here we use the stationary assumption. And this is the literature review related to hidden Markov model. Now, This is a schematic diagram for our model. We start with the invisible states I1 and I2. This pi1 is the probability of I1 and pi2 is the probability of I2. This pi1 is the probability that I have explained it, probability that the number of cases will increase, and pi2 is the probability that number of cases will decrease in Indian context. And A11 is the probability that the state of the system was in state 1. It will remain in it will be in I1 in the next state, and this A12 is that the state of the system was in I1 and it will go to I2, and like these are the elements of transition probability matrix. And same IB11 is a probability that the system was in state I1 will go to V1. It is from invisible to visible status. This matrix is denoted by matrix B, and this Bij are the elements of that omission or observation probability matrix. These are transition and omission probability matrices we have calculated here, where Aij is equal to probability of Xn is equal to J given X minus equal to I, which are R get equal to and row sum for these elements, for row sum of this matrix is equal to 1. And this is finally matrix A, which is called the transition probability matrix, and elements of probability omission probability matrix B, same, the rows, then the elements of each row is equal to 1, and this is finally the observation probability matrix, and this is the initial probability vector. Now, this is the proposed model, hidden Markov model with 2 visible and 2 invisible states. A random variable X omega, where X omega is which denotes the number of times V1 happens, is said to follow the given probability distribution if it takes the integral values 0, 1, and 2. If it is, and its probability mass function is given by this expression. This probability of X omega is equal to X is equal to this for X equal to 0. That means for no V1, here V1 appears 1 time and V1 appears for both the times for X equal to 2. And otherwise, if we are going to find the probability of this, it will be 0 if V1 will come 3 times or something. That is not possible here, while the notations A, B, and pi have their usual meanings. Now, probability distributions for sequence of different visible status. This model is made in order to find the probability of visible status for one time or taking sequence of 2 visible status. So here we have obtained the probability of Vj, probability of V1, and probability of V1 can be obtained by this expression now. That is probability of V1, probability that the number of cases will rise in Tamil Nadu, and probability of V2 is equal to probability that the number of cases will fall in Tamil Nadu. These probabilities can be obtained by using this expression. And for probability of the string of the 2 visible states can happen, say V1 and V2, by the influence of 9 possible ways of hidden status. This I1, 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 I2, I2, I1, I2, I2. That is probability of V1. V1 can happen by this, I1, I1, or by this, or by this, or by this. So we have obtained the probability of sequence of 2 visible states. There is probability of V alpha, V beta. We have obtained we can obtain probability of V1, V1, probability of V1, V2, probability of V2, V1, and probability of V2, V2 can be obtained by using this expression we have derived here. So we can use the expression to find the probability of sequence of visible states. Also, statistical measures for this proposed study are also obtained. We have obtained the Rth movement about origin of the proposed model. That is mu r dash we have obtained, and then from this Rth movement we calculate mean and the variance for the proposed model. Which in turn, since these expressions seems to be quite big, we can use we can simplify this expression in terms of mu1 dash and probability of V1 only. And from for using mu3 and mu4, we can obtain movements and curvacies for this proposed model. The third central movement for the proposed model is this expression mu3, and which in terms mu3 can be simplified in terms of mu1 dash in terms of mean, and probability of V1 can be use this expression to obtain mu3, and similarly mu4 can be obtained by using this expression. And using mu3 and mu2 cube, we can obtain the coefficient of skewness for this proposed study, which is the expression given below. And this expression is quite big. We can use this expression also to obtain the coefficient of skewness for this proposed model. That is mu1 dash minus 1, and this expression we can use to find beta 1, and same for the beta 2. And we obtained gamma 1 and gamma 2 also for the proposed model. Apart from all these statistical measures of the proposed model, we have obtained generating functions like movement generating function and probability generating function are obtained for this model. And we have done empirical study for this proposed model. We made use of the data on COVID-19 published on daily basis by the Ministry of Health and Family Welfare through Wikipedia. The necessary variables here we obtained date and the number of cases. There was a number of cases every day, and from that we have obtained the number of cases per day by successive differences. All mathematical and statistical computations and graphical displays were made using Microsoft Excel and R Studio for this proposed model. And this is the transition probability matrix for this above data, and we have obtained the observation probability matrix also. Here, this is the probability of phi1 and probability of phi2 and a11, a12. This is the numerical analysis of this schematic diagram, and this is observation probability matrix and from. And also pi initial probability vector is also obtained for this above proposed model for the following data. And probability of V1 is also obtained. Probability of V2 is also obtained. And probability of visible states taken 2 at a time are also obtained. Probability of V1, V2, probability of V2, V1, probability of V1, V2, probability of V2, V2. It is probability of V2, V1. The total sum of all these probabilities equal to 1. Mean and variance are obtained for the data, and mu3, mu4, beta 1, beta 2, gamma 1, gamma 2 are also calculated. And these are some recommendations for the proposed study. Conclusion. Summary pointers. References.
So, any questions from the presenters?
Yes, sir. I have one question.
Anki statistics.
So, what is the difference between matrix A and B? That is a transition probability matrix and observed probability matrix.
Yeah, matrix A is obtained from the invisible states only. That is, the elements of this probability transition probability matrix are denoted by A11, where this A11 is equal to probability of xn is equal to 1, given xn minus 1 is equal to 1. But this observation probability matrix is that these are also the transitions, but from the hidden status to the visible states. This is the difference.
So, which technique have you follow for find the visible states? Which technique have you followed for find out the visible states?
It's hidden Markov model only.
Only that is a one is a Viterbi algorithm. Many algorithms are there.
No, here hidden Markov model is used. Hidden Markov process we have used that to find the probability of visible states and probability of visible status for 2 string, and like that we can obtain.
Okay, sir. Thank you.
Sir, can I see one's recommendations, sir?
Go back.
States which predominantly maintain health state should strictly regulate migrations in and out of the region. And the second one is for states which show off and uninfected states, focus should be on those who may potentially get infected. These may be health workers or people who typically interact with large number of people or move around a lot. For states which maintain symptomatic status, the focus should be on non-pharmaceutical interventions such as social distances and containment, like this.
Yes, sir. Good work.
I have one question.
Yes, sir.
I have one question that the cases is changing day by day. So you have taken the data of a particular day or of a time period?
It is not a particular day. It is data of almost 6 months from March to, I think it is, if I remember correctly, it is up to August, September.
Means you have taken for a time period. The data is taken for a time period.
Yeah, it is for a time period.
Yes, because it is changing day by day.
Yeah, it is changing.
Yes.
Please stop your sharing.
I want to interact with that Ankita. Is Ankita on the board?
Statistics.
The previous presenter? No. Previous presenter is what's the name of it?
Yes, sir. I am Ankita.
Richa.
Richa Seni, sir. Richa Seni.
Richa is not there on the board? Okay. Right. Okay, thank you.
Madam, shall we go for next one?
Yes, sir. Yes,
Shweta,
sir.
madam?
Yes,
Shall
sir.
we go for next?
You can proceed, sir. Yes, sir.
Madam, just a moment.
Sir.
Ankita, madam.
Yes, sir.
Because I am also associated with this work, I would like to clarify your doubt on this one. Of course, my student has given a correct clarification, but I will give you some additional point. In hidden Markov models, what we are proposing is there are some states which are invisible, we call it as hidden, and some states which we call it as observed, okay, which are visible.
Okay,
yeah. So what our understanding is the prevalence of Tamil Nadu cases might be influenced by overall scenario of India. Okay. So therefore we have considered the data which is Indian data fluctuations, increasing and decreasing as hidden states, and that are influencing the value of Tamil Nadu cases as observed one. So we need in hidden Markov models 3 parameters we need. One is transition probability matrix, which is linked with hidden states. Another is observed probability matrix. It is linked with hidden and visible states. Okay. The third one is initial probability matrix for hidden states. Okay. This is how we have to develop in a hidden model. First, what he has done, he has explored the probability, transition probability matrix using these 3 concepts: hidden, visible, and initial. Right? Finally, derived on probability distribution. That probability distribution will address the concern of the sequence of happenings. Sequence in the sense he has studied only for 2 at a run. Okay, actually we did this case for up to 7 days a run. 7 days a run we did it. Okay, so that concept is what it is. We can, for example, if we observe 7 consecutive days, what happened? All the consecutive days, what is the chance that all are increasing? Or 3 days increasing, 4 days increasing, 5 days increasing, that way type of things he has done, exploring the probability distribution from the transition probability matrix. It is something like he has not stopped. The previous speaker, she spoke on up to transition probability matrix and she gave a conclusions regarding her findings regarding the insurance policy movement predictions. But his
sir, I am also working on Markov model. I also present a paper on multi-state Markov model. So I am interested in the hidden Markov model.
Okay, definitely. Definitely, we will be in touch with you. Then be in touch with me. I hope you have my mail ID. Let us have one thing. And
in future,
one more thing, off the track I will inform. We have a group called Researchers of Stochastic Processes and Operations Research, right? Every Sunday we are having from 3 to 5. I am the mentor. I am giving teaching part from 3 to 5 every Sunday. Okay.
On which platform?
There is one WhatsApp group. Okay. I will share you that group if you join in that group. Okay.
Yes, sir. Please, definitely, I will join.
Sir, please repeat the name of the organization, sir.
Not organization, sir. It is a group, WhatsApp group created by me. Yes. And we have regular Sunday sessions from 3 to 5.
Yes, sir.
Our group name is Stochastic Processes and Operations Research. Okay.
Operation.
I am the admin, and we are working group on the stochastic processes. Okay. So those who are interested, my WhatsApp number is 9629862241. Note down.
Sir, please,
Repeat.
once again.
Please repeat again.
My WhatsApp number is 9629862241. My name is
9629862241.
Yeah, 9629862241. You make a WhatsApp call to me. We will discuss later off the dashboard. Okay?
Okay, sir.
Right.
Okay. Thank you. Thank you, sir.
So next, yes, Raka is available. Yes, Raka. Sorod Raka.
Sir, Hussein is there.
No, sir. There was a change in the session. The new schedule was sent to you, no, sir.
Muhammad Hussein.
Ramakrishna. That S Raka was shifted to tomorrow's session.
Okay.
The latest
Muhammad
one.
Hussein.
Yes, correct.
Yes, sir.
Yes, sir.
Please share your PPT.
Now Hisham. Okay.
Sir, is it visible, sir?
Yeah.
Yeah. So my name is Mohammad Isham. I'm a research scholar from Pondicherry University. I'm doing my research under Professor Tirupati Rao, sir. And this work is a combined work by myself along with my supervisor and my senior Aparna. So my talk is about sequence modeling using a truncated lifetime distributions. So I planned for using 3 distributions, but now currently I'm only presenting 1 distribution. So this work is we are applying it on the plant related stuff like fertilization in plants. So we are dealing with something like multi-seed fruits or something like that, wherein multiple fertilizations happens as a sequence. And so we are intending to see how an nth state would look like. Nth one will be a success or failure, basing on on one of the situation which we have already have. So suppose if we have the first ovule which is fertilized is a success or failure, then we'll see how the nth one will look like. So these are something regarding the plant pathologies like ovule fertilization and how the things works out. And these are some of the reported studies. I'm just skipping it up as we don't have time for that. So the objective of the study is, as I told, it is like the ovule fertilization, seed formation, and all these things. We are just combining everything together and seeing that whether the seed is being formed or not. And the formed seed, we are assuming that it is a fully fertilized. So we are in this study, we are putting forward 2 models. Basically, I was planning for a 6 model. So anyways, let's stick on to the 2 models, and the 2 models will be explained later. And we have used their statistical measures to see how the model behaves, and the simulation was also carried out. So this was one of my previous work which is related to this. So like 2 states, which is a success and a failure. A success, we can stick on to the success, and then or you can switch to the failure. So we have something like either you stick on to the same state or you move from one state to the another. So every time you move from one state to the another, you call it as P2. We are defining it as P2, and whenever you are staying back on your same state, you are telling it as P1. So the diagram is shown. I guess everybody will be clear with the diagram rather than the equations below. So we can and when you have something like the first equation Pij is shown, and so when you have an n times trial is occurring, and the nth trial you wanted to know whether how much probability it has for a success and the failure. That is what is written by this Pij power n. That's the nth order transition probabilities. So from here we are putting on a conditional distributions where the state in which we are in is a success or a failure, defining it, and then going to see how the nth state will look like. So the type 1 we are telling it as like if the current state is not fertilized, that means you are in a failure now, and what will be the nth state, whether it will be a success or failure, and what will be the probability of their success or failure. And simultaneously the type 2 distribution, which speaks about the full, like you are in a success state now, and then you wanted to see the nth state will be a success or failure. So that was regarding my these are all my previous work. So we defined this, the two distributions which I have already said, their PMFs are shown here. So this was the nth state PMFs. So now what I'm intending to present here is regarding the lifetime distribution. So we have something like lifetime distributions like exponential distributions, variable distribution and all. So I'm using the truncated form because we have something like only the fertilization can happen during certain period of time. So say from 0 to B. So suppose you are in a starting stage of a fertilization and you have something like a 10 days or 16 days for something to happen. So I'm restricting it to a truncated form so that we would have beyond that it's not possible for us success rate. So we're using truncated. Now in this presentation I'm planning to do with the truncated exponential distribution. So already the mathematics for the remaining two were done, but I am not presenting it currently. So this will be the model 1. So you have the P2, which I said already. Suppose you are in a failure, you wanted to go to the success, or you want to go from a success to a failure. So that is the P2. So I'm assuming that the P2 follows truncated exponential distribution. And so by substituting back P2 in my equations, like previously the nth state model. So in the type 1 distribution, I'm just fitting it, and we get the new distribution as T. I'm calling it as TM, like truncated exponential model 1. And similarly, we have that model 2. The same thing again repeated. So I'm just skipping it up. So then what I've done is like we have a distribution here. So it has its mean, variance, and all the statistical measures. So I've used I've derived all this statistical measures for this distribution, and so these are the mean, variances, and the coefficient of variation beta 1, beta 2, and similarly for characteristic function and the moment generating function and the probability generating functions. So this for the model 1, and similarly for the model 2 we have mean, variance, coefficient of variation beta and beta 2. So and characteristic functions. So now going to the research, like what I wanted to say is like we have to see how this distribution works. So this was when I guess it's clear, like the average success rate with changing values of theta and x. So what we have is this is for the distribution 1. So the distribution 1 states that you have a failure now, and whether you will be in a success or failure the next, like the probability attaining to this. So what we can see is that the probability comes down, like it decreases drastically when it is n is like we have the nth state. That means that the next one or after some 10 trials. So in the first picture shows the n is equal to 1, and the second one shows the n is equal to 10. So we can see that in n equal to 1, we could see that it was coming very drastically down, and the probabilities were going to 0 very fastly. And similarly for when n is equal to 10, it was not going that fast, but for certain cases it was very drastic, and the other was like a smooth curve. So, and similarly for we have checked for changing values of theta. That means the parameter which we are explaining here was the rate of change, and the theta, that means like on an average how many can get fertilized on a day or something like that. So here I was taking it up to a 17 days time, and per day the theta value is 1. That means per day one only gets fertilized, and the remaining we should wait for the next day. So something like an arrival thing. So this is about this is when theta has been changed from 1 and 10, and similarly we have changed the n values from 1 to 15, like I have shown with different curves. And similarly for the distribution 2, that is the other distribution, which speaks about like you have a success now. What is the probability that next one will be a success or a failure? So what we can see is the probability of success goes higher. That means the next time, if you have a success now, the next time the next one getting fertilized is getting more. Like you have more chance that it will get success. So similarly for n is equal to 1, the graphs have been shown, and n equal to 10. And similarly for theta is equal to 1 and theta equal to 10. So now for a small comparison, I've just used n and theta is equal to 5 for a normal case and checked out how the mean and the mean plus or minus variance looks like. So what we can see is that in the model 1, we have it's a decreasing case. Like suppose if the first ovule did not get fertilized, then the second one getting fertilized, the probability comes down, and similarly it goes down drastically. So suppose in a tree, in a plant, if a flower, the first one ovule did not get fertilized, and the second one getting it fertilized is low, and similarly, so that means that we could see that mostly some 5 or 10 flowers used to be there, and finally you get only one or the other. So that is what we can see. Only if the first one gets success, we could admit that it will have a success in the next case. So similarly, type 2 distribution talks about this getting success afterwards. So we have these were the two models which I'm here to explain. And so as a part of conclusion, I would like to say that if the fertilization did not happen in the first day, that means then the possibility of happening on the second day will be lower, and as the time goes up, it goes down. That was for the model 1. And the model 2 shows that if we have a success in the starting day, then the second day and the third day, as the time progresses, we will have more successes afterwards. So that's my talk about. And the next slides are about the variable distribution, which I have ordered. I've only done the mathematical part. I have to do the remaining simulation works. So with that, I would conclude. Yeah, these are my references, some of my references. And yeah, thank you.
So, any questions from presenters?
No, sir. Nice presentation.
Isham, please stop your sharing.
Yes, yes.
Sujata, ma'am.
Nice, sir. Nice presentation. No questions.
Thank you, ma'am. Thank you.
Okay.
Proceed.
Madam, shall we go for next one?
Yes, sir. Yes, sir. Sure.
Yes, sir. Thank you, Isham, for your nice presentation. Now,
yes,
next one is Tirunavukarasu. Tirunavukarasu. Is it available?
Using statistical modeling.
Tirunavukarasu?
It's not there. Huh?
Madam, shall we go for another one?
Yes, yes, sir. Maybe he's not there.
Esma John?
Yes, sir, I'm here.
Esma
Yes,
John.
sir. Yes, sir, I'm
Okay.
here. Sir,
Madam,
shall
please
we start?
present.
Okay, sir.
Okay, please share your PPT, ma'am.
Sir, is it visible?
Sorry for interference. As per my details were given in the chat box, those who are interested, they can refer the chat box. This is Tirupati Rao.
Okay, sir.
I audible and is my presentation
Audible and
visible?
your presentation is visual, ma'am. Please go ahead.
Sir, thank you.
Good. You are from Kashmir University?
Yes, sir. Yes, sir. I'm from
Who you are working?
Department of Statistics.
No. Who is your research guide?
Sir, research guide is my Sheikh Parvez Ahmed.
Huh?
Sheikh Parvez Ahmed.
Parvez Ahmed. Okay.
Yes, sir.
I came to your department. Actually, 4 times it seems.
Yes, sir.
Okay, you are not be there. Last year also came. Now Anwar Hassan is the HOD. Now became dean. No.
Yes, sir. Dean. He is the dean faculty now.
Arranged one talk last year. It was so happened on that day, very festival day. It was happened Ramzan holidays. It was happened. Very few people came. Okay. Right.
Okay, respected chairperson, Dr. Sujata ma'am, the coordinators of the conference and the participants, good afternoon. The title of my presentation is Assessing the Flexibility and the Efficiency of Inverse Weibull Model, and I'm Uzma Jan presenting this paper from Kashmir University. So the outline of my paper comprises of the following sections. First, we have first is the introduction to the paper. Next, we have proposed a model that's transmuted exponentiated inverse Weibull distribution. We have obtained the reliability analysis and studied different statistical properties of our proposed model. Further, we have studied the quantile function, median, and random number generation. The different parameters of the model have been estimated using the maximum likelihood technique. For comparing the efficiency and flexibility of the model with its submodels, we have used two real-life data sets. Besides, we have used a generated data set as well. Finally, we have presented a conclusion along with the references. First, the introduction. The Weibull distribution, first of all, was given by Valery Weibull, a Swedish physicist, in 1951. It's one most widely used probability model for analyzing lifetime data and reliability of components. The basic model of inverse Weibull distribution was studied by Keller et al. 1982 and Rapella 1993. It worked on inverse Weibull model and suggested the name complementary Weibull distribution. Alim and Pasha 2003 studied some additional distribution properties of inverse Weibull distribution. This model is very much applicable in reliability analysis, studying medical sciences, modeling infant mortality rate, wear-out periods, degradation of mechanical components, etc. Further, a generalization of exponentiated exponential distribution was presented by Gupta and Gundu 2001 as an alternate to gamma and Weibull distribution. A generalization of inverted Weibull distribution called exponentiated inverse Weibull distribution was introduced by Flay et al. 2012 by introducing a new shape parameter, that's theta, through exponentiation technique to the distribution function. A random variable, we consider a random variable x, and it's said to follow the standard exponentiated inverse Weibull distribution if its distribution function is given by the equation 1. Here we have two parameters, that's beta and theta, and both the parameters are the shape parameters. Now coming to the probability density function of the standard exponentiated inverted Weibull distribution, it's given by the equation 2. Again, we have here two parameters. Proposed model is we have used for formulating our proposed model. We have used a technique, transmutation technique, which was proposed by Shah and Buckley in 2009 using the quadratic rank transmutation map technique. It's more it's used for generalizing different classical models, and it provides a flexible extension of these models for live testing and best fit. It's used to convert hard quartile functions into simpler ones. It's used for adding skewness and kurtosis in the model. This technique helps in generating the models from the samples already existing. Now, a random variable x is said to follow transmutation distribution if CDF is given by the equation 3. Here we have an extra parameter, that's lambda, which ranges between -1 and 1, and this is known as the transmuted parameter. Here we see that g of x is the transmuted distribution, while f of x is the CDF of the base distribution. Differentiating the equation 3 with rest, we get the equation 4, which yields the probability density function of the transmuted model. Here we see that small g of x and small f of x are the corresponding PDFs of capital G of x and capital F of x respectively. Also, it may be noted that when lambda, that's a transmitted parameter, is kept to 0, the model reduces to the parent distribution. Now, using the equation 1 and 2, we get the cumulative density function of our proposed model that's transmuted exponentiated inverse variable distribution, and it's given by the equation 5. Now, we see that here we have three parameters, beta, theta, and lambda. Beta, theta are the already existing parameters, which are the shape parameters, and lambda is the transmitted parameter. Further, we see that using the equations 2 and 4, we get the probability density function of the proposed model that's transmuted exponentiated inverse variable model, and it's given by the equation 6. These are the graphical representation of the probability density function and the cumulative density function. We see that as the value of the, for keeping beta and theta fixed, and we vary lambda, that's we increase lambda, the graph of the probability density function gets increased, or it's increasing. It becomes more and more peaked, or we can say that it helps in studying kurtosis. Also, the graph of the distribution function, as it is always an increasing function. Further, we see that the relationship of this proposed model with 11 its submodels. We see that when lambda is equal to 0, it reduces to 2-parameter exponentiated inverse variable distribution. When theta is equal to 1, proposed model reduces to 2-parameter transmuted inverse variable distribution. When theta and lambda, when theta equal to 1 and lambda equal to 0, it reduces 1-parameter inverse variable distribution. And when beta equal to 0, it reduces to 2-parameter transmitted inverse Rayleigh distribution. When beta is equal to 2 and lambda is equal to 0, proposed model reduces to 1-parameter inverse variable inverse Rayleigh distribution. When beta is equal to 1, it reduces to transmitted inverse exponential distribution. When beta is equal to 2 and theta is equal to 1, it reduces to 1-parameter transmitted standard inverse Rayleigh distribution. When beta is equal to 2, theta equal to 1, lambda equal to 0, it reduces to standard inverse Rayleigh distribution. Beta theta equal to 1, it reduces to transmitted standard inverse exponential distribution. Beta equal to 1, lambda equal to 0. Proposed model reduces to 1-parameter inverse exponential distribution. And when beta equal to 1 and theta equal to 1 and lambda equal to 0, it reduces to standard inverse exponential distribution. So we can say that our proposed model generalizes 11 different submodels. In the section 4, we have studied the reliability analysis. We have studied the reliability function of a proposed model. We have studied the hazard function, and we have studied the reverse hazard function of a proposed model. Further, we have studied in the structural properties of our proposed model. We have studied the mean. We have calculated harmonic mean. We have calculated moment generating function and the characteristic function. We have given the different graphs for the survival function, graphical representation of hazard function, and the reverse hazard function. Survival function is always a decreasing function. The graph of hazard function shows an inverted bathtub graph, and the reverse hazard function is a decreasing function. In the section 6, we have obtained a quantile function which is used to calculate different parts of our probability density function for when when u is kept to equal to 0.5, we obtain the median of the proposed model. Further, this quantile function also helps in generating the random numbers. So we have obtained the random number generation function. In the section 7, we have obtained the Rayleigh entropy. The entropy of a random variable is a measure of variation of uncertainty. It gives us the exact amount of useful information that can be obtained from a system. The Rayleigh entropy was first of all given by Alfred Rayleigh in 1960. It's denoted by IR rho, and it's a measure of variation of uncertainty, and is defined in the equation 7. Considering the probability density function and the cumulative density function of the proposed model, and substituting the equations in 7, we get the Rayleigh entropy in equation 8. The beta or Q entropy introduced by Harvrada and Charvat in 1967 is defined by equation 9, and substituting again the PDF of the proposed model, we get the beta entropy as in equation 10. Further, we have studied the order statistics of a proposed model, the nth order statistics or the probability density function of the nth order statistics using the PDF and the CDF of our proposed model. We get the equation 11, that's the probability density function of the nth order statistics. For the smallest order statistics, when R is equal to 1, in equation 11, we get the first probability density function of the first or the smallest order statistics. Substituting R is equal to N in equation 11, we get probability density function of the largest order statistics in equation 13. Now we have estimated that now the section of parameter estimation. We have estimated the unknown parameters, that is 3 parameters that are involved in our model, that's beta, theta, and lambda. We have estimated them using the maximum likelihood procedure. We consider a sample of size n, and the likelihood function of a proposed distribution is given by the equation 14. The corresponding log likelihood function is given by the equation 15. This differentiating the equation 15 with respect to the unknown parameters beta, theta, and lambda, and equating them to 0, we get 3 normal equations, that is 16, 17, and 18. Solving these normal equations, we have solved these normal equations in the R software and obtained the estimates of our parameters. Part, that's the application part, where we have used this proposed model. In this section, we have studied both simulated as well as real life data sets. We have compared this model with its 11 different submodels. The criteria of comparison we have chosen as a Kite information criteria and Hannan-Quinn information criteria. The distribution, which provides us the lesser values of AIC and HQIC, is rendered as best. The value of AIC can be calculated from the formula AIC is equal to 2k minus 2 log likelihood, 2 log of likelihood, and the HQIC can be calculated of 2 log n minus 2 log likelihood, where k is the number of parameters, n is the sample size, and minus 2 log likelihood is the maximized value of the log likelihood function. These the analysis of both the data sets, that's the simulated as well as real life data sets, have been performed through the R software. We have obtained the MLEs of the parameters. Further, we have obtained the standard errors of the MLEs. Besides, we have obtained the 3 criteria of comparison, that is log likelihood values, AIC and HQIC, which have been displayed in the table 1 and 2. Now, considering the simulated data set, we have in our simulation study we have considered a sample of size 100, which we have obtained from the R software using the inverse CDF method. We have chosen the values of the parameters as beta is equal to 0.7, theta is equal to 1.3, and transmission parameter we have considered as 1. The data the summary of the analysis has been displayed in the table 1. In table 1, we see that our proposed model, that's transmitted exponentiated inverse variable model, the log likelihood values and AIC and HQIC values are lower than all other submodels of the proposed model, and we have also obtained the estimates of beta, lambda, and theta, that's our unknown parameters, since the values of our criteria for comparison, that's AIC and HQIC, is less than all other submodels. So we can state that our model, that's proposed model, is better than all other submodels and is more efficient and flexible than all other models. In order to validate our facts, we have considered 2 real-life data sets. We have studied a sample of 124 bladder cancer patients, which was studied previously by Lee and Wang in 2003. And besides, we have studied the survival times of 121 patients, which was given by Ramos et al. In 2013. The numerical analysis have been displayed in the table 2. In table 2, we see that in the data set 1, we see that our proposed model, that's transmitted exponentiated inverse variable distribution, has lower values of AIC and HQIC as compared to its 11 submodels. Further, we see again in data set 2, our proposed model has lower values of log likelihood function, AIC and HQIC, than all other submodels. In this way, we can say that our proposed model justifies or is more flexible than all other submodels and is more competent than all other submodels. Finally, we present the conclusion. In this paper, we have studied a mu distribution. We have generalized inverse variable distribution using the transmutation technique to improve its flexibility, to analyze its competence than its submodels. We have studied different mathematical properties like reliability analysis, movement generating functions, etc., Renyi entropy, etc. In order to assess or analyze its flexibility and applicability, we have used as well as real-life data sets. Due to the lesser values of our criteria for comparison, that's AIC and HQIC, it can be concluded that our proposed model is more flexible and competent than all other submodels. These are the references. Thank you.
Any questions from presenters?
Okay, nice presentation on transmuted exponential Inverse variable distribution. Very
Yes, sir.
good. While calculating the descriptive statistics, you have derived certain formulae. Okay. So
Yes,
in
sir.
that list, I have seen that there is a derivation for harmonic mean.
Yes, sir.
Right. What is the need of that?
So it's just calculating studying different characteristic properties of the distribution.
No. Harmonic mean, which property it will address?
So, sometimes rate of degradation of a mechanical component.
You have calculated mean, no? First order moment mean you have calculated.
Yes, sir. Yes, sir.
You have calculated harmonic mean also. First
Yes,
mean is that is arithmetic mean. Second one is harmonic mean.
Yes, sir.
Usually harmonic mean may not be that much important in other distributions.
Yes, sir.
You have derived this harmonic mean means that might be a special reason for it.
No, sir, not for a specific reason. Not for a specific reason.
Specific reason means if you are handling any phenomena come rates or ratios like data, for
Yes,
example, happening per unit case, happenings, total number of happenings per unit time, per unit case.
Yes, sir. Yes.
When you are handling your variable with rates and ratios, then there only we need this type of calculation. Otherwise,
Rates and ratios, we use the harmonic mean.
might be
Absolutely.
your distribution having that type of variables. That's what my interest to learn.
Sorry, sir?
So, what type of variables it will be handled with transmuted this TEIWD. There should be some random variable. Every probability distribution have some type of random variable. Okay.
Yes,
Whether
sir.
your random variable deals with rates and ratios or ordinary quantifications. What are that?
So ordinary quantification. It's we study usually inverse variable distribution is studied is used to study the degradation of mechanical components or in reliability analysis, biosciences. So we can take any random variable or any case of study for that.
Okay. Well, nice presentation.
Thank you.
So nice presentation, Madam Uzma Jan, Madam. And in the real life time, how many samples have you taken in that which year, Madam?
Ma'am, I have actually taken the data online. We have taken a sample of 100 first generated sample, which we have calculated from the OR software using the inverse CDF method. Further, in order to validate that effects, we have constructed two real-life data sets from Li and Wang and Ramos et al.
Okay. Okay, ma'am. Thank you.
Thank you, ma'am. Any other questions, ma'am?
Okay. So next presentation, please stop your sharing. Okay, Madam, shall we go for Anwan?
Yes, sir. Yes, sir. You can.
So Charudatta A. Nimbalkar. Is it available? Charudatta A.
Yes, sir.
Nimbalkar. Yes, sir. Please present.
Hello, sir. Myself, Yogesh Bangar. I am the one of the co-author of the paper.
Okay.
So I will present this paper.
Okay. Somebody has communicated. What is
Yes,
the,
sir.
what is the
Dr.
name?
Nimbakar. Dr. Nimbakar, sir.
Right. He has. Yeah, you can present now.
Okay. Please share your PPT.
Okay, sir. Visible? Is it visible, sir?
No, sir. It's coming.
Visible hai, sir?
Yes, sir, it's visible only. But keep it slideshow, sir.
Okay. Okay, respected chairman, member of organizing committee, and my dear friends. Myself, Dr. Yogesh Bangar, I am working as a scientist at the Department of Animal Genetics and Breeding at Knowledge in Animal Science. Before starting this presentation, I want to tell you that, like other disciplines, the statistic also plays a very important role in animal sciences, especially in animal breeding, epidemiology, other subjects. Especially the estimation of genetic parameters, in response to selection and other selection indices and other techniques are solely based on statistical assumptions and the applications. And the paper regarding of these techniques, they are publishing in very high impact journals. So I will start my presentation now. The topic of my presentation is genetic and phenotypic parameter estimates of growth rate in Deccan sheep using mixed modeling. As we know, the sheep production system in animal sciences, sheep production system plays very important role. It provides meat, wool, and other required income for poor farmer, especially in arid and semi-arid regions of the India, especially in Rajasthan. Total sheep population of India is 7, and India ranks second in the world after China. Continuously, the population of sheep is continuously increasing since last decades. Now, major states for sheep population are Telangana, Andhra Pradesh, Karnataka, Rajasthan, and Tamil Nadu. We choose this breed, Deccan sheep, because there is one center from ICR, that is Network Project on Sheep Improvement at the university, Mahatma Phule Krishi Vidyapith. So they are maintaining around 600 animals. So we use this data for this study. This breed is very important. Its population around 62 lakhs and mainly found in Maharashtra, Andhra Pradesh, Telangana, Karnataka. It is medium-sized breed, especially reared for mutton purpose. As we know, the growth is very important parameter because all the profitability of sheep farming is depend upon the growth rate. The growth rate from the birth to the weaning. In sheep, the weaning period is 3 months, means the lambs, the young ones of the sheep, they are separate from the mother. So this period is very crucial from birth to weaning, and the growth in that period is very important, and it is of very we can say point of interest so many researchers. So average daily gain, we choose this average daily gain since it gives us idea about the we can say growth rate during the initial period. A genetic evaluation of this trait, we can go for which forces are affecting these growth rates. Like we can find out what is the contribution from genetic effects and what is the contribution from the environment. So this identification is very important because all these projects, they're having some targets and some we can say selection criteria. They select animal on the basis of 6 month body weight, because their 6 month body weight having high heritability. There is a high, we can not high exactly, but moderate genetic variability. So this gives us chance to select animal, so they we can have better genetic progress. So objective of this study was to estimate genetic parameter of growth rate in Deccan sheep. The material method, we collected information from the ICR Network Project on Sheep Improvement from Rahuri. Total 953 lambs we use in this study. The data records regarding average daily gain from birth to 3 months, then 3 to 6, and 6 to 12 months been used in this study. Other details like year of birth, sex of young one, or we say lamb, and the season of birth and their mother's weight at the lambing also compiled from the registers. First, we use general linear model. This is specifically for to understand the effect of different fixed factor on these growth rates. So in fixed factor, we use year of birth. It was 2015, 16, 17, 18. Then season of birth, it was categorized into 2 parts. It is October to March. That is main season. and April to September, that is off season. And the sex of lamb, male or female, and dam age at lambing, that was less than 2 year, 3 year, 4 year, 5 year, and 6 and above years. So this was general linear model, and significance, we can say effect was considered if p-value was less than 0.05. So purpose of this fixed effect was first to identify the most important or most influencing factor which contribute to the variation in growth rate, and another purpose was to identify those significant effects and include those significant effects in further genetic analysis.
Sir, excuse me, sir. Yogesh sir, please make it as a slideshow. Better visible, it will be visible. Slideshow, sir.
Okay, okay.
Sorry for the interruption. Huh? Okay.
No, ma'am. No.
Okay, good.
The genetic evaluation was carried out by using those significant effects and genetic effects. So this is standard genetic model. Y is equal to XB plus Z, ZE, A plus E. Now here Y is our growth rate, that is vector of data of targeted growth rates, and B, A, and E are the different factors. B is for fixed effects, A is for the genetic effects, and E is for residual effects. We use dyadic mix model because we know the effect of sire and dam influence the performance of individual. So we consider dyadic mix model. This model is based on pedigree data, which do the partitioning of the individual variation into range of environmental and genetic variance component. We use R software for this purpose. There is a DMM package, that is dyadic mix model package. And then after estimating heritability, we estimated genetic and phenotypic correlation. These are the results of growth rate. So ADG1, ADG2, ADG3, first one is birth to 3 months, then 3 to 6 months, and 6 to 9 months. So overall was 113 gram daily gain per day up to weaning stage. It's ADG1. In ADG2, it was 93 gram, and ADG3, it was around 35 gram. There was significant effect of periods, years, different years, then significant effects of season and sex also. In sex, higher growth rate was observed in male category. In season, higher growth rate was observed in main category, and in year wise there was we can say varied estimates, because it was high at initial in 2015, but then it got decreased, and then 2018 it was again coming to high. So these are the different, we can say, graphical representation of same effects. So we can see the difference for the season and sex. So in ADG1, ADG2, we can see clearly difference in the season. The season first, that is main season, having more growth rate, and in case of sex, the male is having more growth rate. After that, considering only those significant effect, like ADG1, we consider year, sex, and season. ADG2 also again consider with 3 effects, but ADG3 there was no significant effect of this fixed factor. So for ADG3 we use only genetic effects. We estimate the genetic parameter. So diagonally we can see the estimate of heritability, and above diagonal there was genetic correlation estimates, and below diagonal there was phenotypic correlation. The estimate for ADG1 was 0.16, ADG2 was 0.22, ADG3 0.12. Now this estimates gives us idea about the how much proportion from the genetic part. And correlation, genetic correlation, we can see here ADG1 and ADG2 is having positive correlation. ADG2 and ADG3 is having also positive correlation. So we can see here among all these traits, ADG2 is having, we can say, a little bit higher estimate of heritability, which falls under medium range of heritability. Generally, if the estimate of heritability is greater than 0.2, we go for selection. In that case, selection will be effective. If it is less than 0.2, we cannot go for selection. So based on all the results, we concluded these findings. We come to this conclusion. First conclusion, these growth rates having periodical fluctuations, and this can be improved by controlling managerial practices right from birth to yearling stage, means up to 12 months age. The male lamb and the lamb born during main season having higher growth rate. So we should focus for lambing during this main season, because they are getting that winter we can say cold or comfortable environment during that period. And maybe that is the reason for the higher growth rate. Or maybe we can say the grazing area is also available for dam or that sheep, so they are getting good feed, and also that giving good growth rate. The estimates were 0.16, 0.22, 0.12 for ADG1, ADG83, and ADG2 specifically having had a positive genetic correlation with ADG1 and ADG3. So based on this one, we can say we concluded that medium level of altitude genetic variation at ADG2, that is means from 3 months to 6 months, that was the period for ADG2, having medium level of altitude genetic action, and also it having positive genetic association with other trait, that indicates if we go for selection for rate selection for this trait, there is chance for further improvement, and we can achieve the desirable results. These are the references, and
any questions?
No, sir. Nice presentation. Sir will ask, I think. Tirupati Rao, sir, can ask.
You can ask from the participants, sir.
So shall we go for another one?
Yes, sir.
So Venkat Ramareddy.
Yes, sir, I'm there, sir.
Sir, please share your presentation.
Yes, sir. It is visible, sir?
No.
Okay. Okay. You cannot share your screen. Error has been occurred.
Reddy, or you know how to
Sure,
present?
sir.
Just click that
I know,
person
sir.
now.
I clicked on it shows entire screen on window.
Yeah. It's coming.
Now it's coming now.
Yes. Okay.
Right.
So people to use, sir?
Yes. Put it in slideshow.
Yes, sir. It is taking some time. Okay. Good evening, respected professors, associate professors, assistant professors, and my dear scholars. My name is K. Venkatramreddy, full-time research scholar from Geetham, Hyderabad Business School, at Ram, Department of Financial Management. Present my research paper title called Analysis of Preferences of Individual Investors Towards Open-Ended Equity-Linked Savings Schemes Using Linear Regression Model. Introduction, literature review, research gap, objectives, hypotheses, research methodology, conclusion, and references. My introduction, we know that most of the individuals and investors looking for different avenues to secure their financial goals, like to secure his old age, their children education, or their children marriage, or their own purpose. So for that checking what are the different avenues available in the market. So there are different avenues available, like post office schemes, or mutual funds, or capital markets. So nowadays, the mutual fund market is the attractive market because 2014, for the first time in India, the mutual fund industry crossed 10 trillion crores. Span of 3 years in 2017, It's cost 1,000 trillion. Now 2020 expecting 30,000 trillion. See, this is the this shows that the mutual fund market is nowadays is attractive market for the investors based on their financial goals. Like the investors, they will choose mutual funds according to their preferences or their needs, or if the youngsters have risk taking ability, they will invest in mutual funds. So, followed by this introduction, the literature review says that they are saying in their study, mutual fund markets are more attractive rather than when compared to bank deposits. In 2019, they said that the mutual fund is the more attractive market because of portfolio diversification is there is a professional management, there is a risk reduction, flexibility, transparency, and low transaction cost. Gandhi and Joshi, they said that the mutual fund markets are attracting the investors based on the personal financial managers, or based on their advertisement like internet and advertisement in televisions. In 2018, they said like this. See, research gap is, if you see literature review, they are saying holistic view of the mutual funds, but they are not concentrated on particularly tax-saving mutual funds. So there is a gap to study about what are the different factors preferring to invest in equity-linked, which means tax-saving mutual fund schemes. So this is the gap I want to find out. To fulfill this gap, I collected, I created the objective and the hypothesis. Objective like different factors of preferences towards open-ended equity-linked savings scheme individual investors. Hypothesis is the impact of different factors of preferences on their satisfaction level towards the individual investors. My target population is in Hyderabad. Only tax-saving mutual funders. The region is Hyderabad, Telangana state. Design is non-probability purposive sampling. Sample size 200 respondents. And the design is using parametric like a linear regression model. There is primary data through questionnaire, and the secondary data to different websites. Analysis means this data I utilize it in SPSS 25, and by taking Crodbax alpha to test the reliability of the questionnaire and see the impact between the factors by taking the exploratory factor analysis. Reliability statistics, the Crodbax alpha of these 10 items, I took 10 factors of preferences. These factors, is there any impact on the satisfaction levels? The Crodbax alpha is 8, means it is more than 0.6, it is acceptable. The KMO test says that the sample advocacy is fit for this analysis or not, means yes, 0.8. It is more than 0.6, means it is the sample is enough to study for this EFA. It is significant also. I did for these 10 factors. It says that the overall variation is 72%, and it divided into 3 components: first component and second component, third component. In first component there are 5 factors, in second there are 3 factors, in third there are only 2 factors. These 10 factors contributing 69%, means 0.69 means 16 R squared, 69% satisfaction levels. Model, means the regression model is fit or not, the overall ANOVA says that significant. Yes, the overall model is significant. I want to analyze the each and every component. One is impacting on satisfaction are either component 2 or either component 3. Which component is impacting more than the satisfaction level? If I say component 1 means it comes return liquidity, capital appreciation, and reduce investor risk. Component 2 means 3. Means professional management, varieties and benefits, transparency. In 3, safety and security, affordable. Just this is the coefficients. I said satisfaction level. See, the component 1 is unstandardized coefficient. 42% is impacting on the satisfaction level. It is significant. There is a significant difference. Component 1 on the satisfaction levels and component 2. It is significant as it is significant means there is a difference. So component 2 is impacting on the satisfaction level. It is significant or not? Yes, it is significant. It means the regression model satisfaction level equal to function of component function of significance minus 1.123 plus into component 1 plus 0.08 into component 2 plus 5.145 into component 3. This is the overall is significant. And the conclusion is I already discussed the ANOVA table shows that it is significant, and the component 1, component 2, component 3 are the factors, and at the 5 point of significant it is significant, and hence it is inferred that the component 1, component 2, component 3 are positively influenced. Within this, the component 1 is the 42% means more impacting when compared to other component 2 and component 3. It means safety, security, capital appreciation, and reduce. These are the factors are most influencing on their satisfaction levels to invest in equity savings schemes only. Conclusion, brief discussion, and here are the references. And sir, for giving this opportunity to present in this conference.
So, any questions from participants, presenters?
Sir, I have one question. Sir, actually mutual funds nowadays, if we put it in the for savings, but we will get the result in the long run, no? Have you identified that one? Is it okay? Have you identified that one, sir, about the mutual funds? Will get the result in the long run. So nowadays they are telling. Have you identified in your research? Sir is... hello? Ramakrishna sir, am I audible?
You are audible, ma'am. But I think Ramareddy sir net is working, not working.
Okay, okay. Okay, sir, we can carry on next one.
Dr. Ramareddy garu, please stop your sharing, sir.
Maybe network problem, I think.
Okay.
But he has to stop, I think.
You have to stop the sharing.
He stopped.
Okay, right. So next one is Sachinarayana, sir. Sachinarayana, is it available?
Yes, I am there.
Okay, sir.
Okay,
so
sir.
please share your PPT, sir, and go on presentation.
Okay, sir. Okay. Sorry, is it visible?
No. Now it's coming. Okay. Put it in a slideshow.
Okay, sir. Okay. Okay.
Right.
Good evening, all. My research topic is hybrid model for improving classification accuracy. Myself, Satyanarayan, I have done this paper under the guidance of Dr. Ismail B., Professor of Statistics, Anapa University, Mangalore. So let me begin with the brief introduction. So as all of you are aware that KNN and a decision tree can be a powerful tool to analyze large volume of data to get the useful information for decision making. So these two are most useful because they are very simple, easy and efficient toolbox for the researcher to deal with the challenges posed by rapid improvement in the technologies, both in terms of time complexity and computational complexity. And because of this simplicity, these tool techniques have wide variety of application in many fields. KNN and decision tree both are the non-parametric algorithm. It could be a best choice in any prediction study that involves little or no prior information about the underlying distribution. But Sadegh et al. In 2013 has identified that KNN is too much sensitive to irrelevant or redundant feature because while computing the distance matrix or similarity matrix will take all the variables into consideration. So therefore, if there is any relevant or redundant feature will be there. So it is sensitive to sensitivity. So it will affect the result when you apply the KNN. So decision tree also a very simple technique and it has a very easy interpretable capacity. So what we propose is we have identified that the main disadvantage of classification, so decision tree classification is it assigns same predicted class for all the tuples which satisfy the corresponding splitting criteria. That means if you consider a branch, if you consider a branch, sorry
for interruption. Satyanarayan Pujari, can you on your camera because all proceedings are recording.
Sir, my camera is not working, sir. I have to open that in the.
Carry on.
Okay, sir. I have to open in the mobile, therefore it will be echo.
Noise.
Okay, sir. After presentation, I will open my video. Okay, sir. So you can see that in each branch, it will assign same class for all the values. So similarly, this is the one disadvantage of decision tree. That means it predicts same class for all the tuples. And even though, in fact, after predicting the same class in a decision tree, even though you may get a high accuracy level, but you know that predicted class of a response variable is great interest rather than the accuracy. And one more disadvantage what we observed from the KNN is sensitive to irrelevant or redundant feature. So what we thought is, so we proposed an hybrid classification model which based on decision tree and the classification, but which it will overcome the above two problems. The proposed model overcomes the problem associated with the KNN by applying KNN to each group after selecting the significant variable from the decision tree. That means here each and every time you no need to consider all the variables while computing the distance matrix. After selecting the significant variable from the distance decision tree, we are applying the KNN technique. So the proposed model is also based on the Gini index, which instead of searching K nearest neighbor directly in the entire data set, it will take much time. So first grouping of the element will be done based on the Gini index criteria, then KNN will be applied to the each group. So the proposed model will be mainly depending on the two parameters, namely data what you are using, so data set with the variable list and the variable selection method. So we have make use of a Gini index as the variable selection method to select the best splitting variable as well as the best splitting point. So the novelty of this work is after construction of cart, instead of predicting the same class for all the tuples in a branch, for each branch the data will be arranged first, then KNN will be applied to the each branch to get the predicted class. Hence it will be overcome both the problem of decision tree as well as the KNN. So the algorithm, I have just roughly represented the algorithm. So what the input we use for the algorithm is data set, variable selection list, variable list and the variable selection method. The output will be the hybrid decision and KNN tree. The rough idea of the algorithm goes like this. First we will prepare a decision tree using CART algorithm, but this will be having only the branches or the division classification will be there. There will be no prediction will be there. We will consider the first leaf node and note down the position of the tuple satisfying the corresponding splitting criteria. Then we will rearrange the variables, both the x variables and the output variable. Both the variables are rearranged according to the position we have noted down. So after arranging the positions, we apply KNN to the arranged data, so that will get the predicted class based on the appropriate values in the particular leaf node only. We'll repeat the same 2 steps for all the leaf node. Finally, the hybrid model hybrid tree will predict the class along with the original class of the response variable. So after saying that, we have seen that Cambone, Todeshani, and these are the many they have worked and they have investigated the effect of distance measure on the KNN, and they have reported their best distance measure. Since there are several number of distance measures are available to use for the KNN, so we thought that our model is also based on KNN. That's why an attempt is made to answer evaluation of performance of our proposed model and the KNN for the various distance measure. How will be affected by the various distance metrics? What are the top 3 methods we can use for the analysis of KNN as well as our proposed model? So for this, we have considered these 10 distance similarity matrices. Then we will identify that what will be the top 3 distances and similarity measure that can be used both for the KNN as well as the proposed model. Then I will come to the simulation part. To highlight the distinction between proposed model, we compare the performance of our proposed model with the decision tree and the SVM and the KNN model. The decision tree was constructed using the R package, that is R part. We have taken 3 variables generated from the normal distribution. We have taken some samples, 30 small sample to 400, 500 up to 3000. Each sample is repeated 5000 times. And the stopping criteria, what we have put for the decision tree is the 0.01, and we fix that each time there will be only 3 leaf nodes to make it a better comparison. So then the decision tree is constructed based on the trained data, and its performance will be evaluated based on the test data. And to evaluate whether our proposed model is robustness to the distribution assumption, we have taken the observation from the T distribution also. So this is the one rough, I have not reported for all the sample size. For most of the sample size I have reported. You can see that this table will explain how the model will be performing, decision tree, KNN, and the proposed model and the SVM, super vector machine learning method. You can see that for the sample size 30 and 50, the super vector machine learning has overcome all other remaining model in terms of classification accuracy. But as the sample size is to 80 and above, our proposed model has overcome in terms of performance. Similarly, we have compared the performance of various models based on the T distribution observation. And in fact, for all the sample size, our proposed model has overcome the decision tree, KNN, and SVM. Therefore, our proposed model shows the robustness to the distribution assumption. Then we check the performance of our proposed model for 4 different types of data set. The one data set we have considered is the diabetes data set, which we have taken the number of pregnancies, body mass index, blood pressure, and these many variables you have considered. This data is related to female of at least 21 years and age. So data is collected from the Kaggle website. Then the second data set what we are collected is the heart disease data set. We are having 270 observation and 8 variables. These are the variable I have reported. And then we have taken the problem of classification of glass, whether the particular is a glass of type 1 or glass type 2 based on some chemical composition, sodium, magnesium level, aluminum. And finally, we have taken the data from the northeast of Andhra Pradesh data. So the data set was used to evaluate prediction algorithms to reduce the effort of doctors. So suppose if we are able to identify a predictive algorithm which will correctly identify whether the particular patient will have the liver disease or not, it will little reduce the effect or sorry, burden of doctors. So based on all the 4 data set what you use, we will make the train and test data set. This is the performance based on the test data set. So you can say that for the diabetes data set, decision tree, KNN, SVM proposal model I have considered while computing the performance in the real life data set. We have considered all these three: accuracy also considered, sensitivity also, and specificity also considered. You know that sometimes we may get the higher accuracy level, but sensitivity is the amount of percentage of correct classification of the group 1, and specificity is the percentage of how much percentage of correct classification will be there for the group 2. So that's also will be the matter along with the accuracy. Therefore, we have taken accuracy, sensitivity, and the specificity. The fourth data sets are clearly shows that our proposed model has overcome the remaining 3 model under consideration. In fact, this is a working paper. The effect of distance measure on the proposed model is not completed. So therefore, I have not reported that result. It's under working. The 10 distance measure what I mentioned, we are working. So under the simulation is to report. The final conclusion, what I say that, so we have compared the performance of proposed model using Euclidean distance based on the decision tree, SVM model, KNN in terms of accuracy through a Monte Carlo simulation study. The Monte Carlo simulation study shows that our proposed model performs better than all the 3 models, irrespective of the sample size when the observations are from the normal distribution, and the same results were obtained when we generated observation from T distribution. This shows that hybrid model is robust to the distribution assumption. The working of the proposed model is also illustrated for 4 different types of real-life data set. The result shows that for all the 4 data sets, the accuracy, sensitivity, and specificity is high for proposed hybrid model. Hence, the proposed model, along with overcoming the disadvantage of decision tree, disadvantage of KNN performs better than the remaining 3 models. We thought that instead of introducing something new, so decision tree and KNN are the already known techniques. Suppose we are able to address the problem within that, and since all of them are really familiar with those 2 things, so if you are using the proposed model, it has overcome those 2 problems. These are the paper I have used for my reference while doing this research work. Thank you, sir.
So, any questions from participants or presenters?
Sir, I have a question.
Okay.
Satyanarayana, sir.
Yes,
The presentation is nice. Excellent, sir. In real life applications are good. Whereas when compared to the diabetes and heart diseases, so what are the real life applications when you compare this diabetes in this and heart diseases, sir?
No, so those are the data set separate analysis. So one
Separate
will be
analysis.
separate analysis, means one will identify whether the patient will have diabetes or not. Second one will be again separate classification.
Okay. Sir, Indian liver patients means?
So liver disease, whether the particular patient will have the liver disease or not.
Only Indian. Okay.
Classification related problem.
Liver related problems. Okay,
Yes.
sir. Thank you. So
Thank you.
good, sir. Presentation is good.
Thank
Real
you.
life applications are good.
Okay, thank you.
Next, Gautam Mitra is available. Gautam Mitra.
Available.
Sir, please share
Hello,
your
sir.
PPT, sir.
Yogesh is also there.
Yogesh, already you are.
No, this is another one.
This is another one.
This is a goat.
Okay.
That one is
At the end of that session, you can present.
previous
Okay.
one is a sheep. This is the goat.
So can you see my slide?
Sir, is presenting.
Yes,
please put in slideshow, sir.
I have already, can you see my slide?
No, yes, sir.
Yeah.
Go ahead, sir.
Yeah. Actually, usually, the title is already shown. So usually gold price and stock price have inverse relationship. Usually, if one rises, the other things falls. But what about the pandemic period? Our main motto was to search whether this inverse relationship exists even during the pandemic period. More particularly when we do not know when this pandemic will be over. It is still going on. while the volume in the derivative segment is many times larger than its cash counterpart, is it not relevant to experiment with data from derivative segment? So with these two main idea, we have designed our research. We have 3 specific research questions to address. First research question, and my presentation is something like this, that I will put my research question in support of, in response to my research question, I will be presenting my data and method, and finally I will tell you what the result I am getting. My first research question is, what kind of relationship?
Sorry for interruption, Mr. Gautam Mitra. Can you adjust your camera to see your face? So it is above your head. So because it is being recorded.
Okay.
Yeah.
So can you see me, sir?
So let us know. No, still you have to adjust your face. I mean, camera to be adjusted to, yeah.
Okay, can you see me? I mean,
okay, now it's okay.
Okay, so what kind of relationship would persist between forecasted price of Nifty future and gold future? And we have tried to predict, so far as our first research question is concerned, from 4th quarter 2019 to 1st quarter of 2029. It is a forecasted data. And we have considered a bivariate regression, gold future X, that means it is independent variable, and Nifty future as Y, that is dependent variable. And it is basically a bivariate regression we have run. And what is the result we have got? That is R square value we have got. And before running the model, I am coming to the model later on, it was 0.798 with p-value 0.000. And I will tell you the regression result after running the model. Now we are looking, now we are addressing towards the model. What model should fit in? So we used quarterly data for prediction. We used quarterly data from 4th quarter 2003 to 3rd quarter 2019. Please remember that we have used quarterly data, not daily data. Why? Because once it is future market, there is an effect. 3-month cycle is there. So we have used quarterly data, and we were looking for ARIMA model, auto-regressive integrated moving average model. Now again, we are in search of what specific ARIMA model will fit into. Is it ARIMA model 1.12, ARIMA 2.1, or ARIMA 2.2? Before we try to specify our specific ARIMA model for these 2 variables, we have initially gone for correlogram, autocorrelation function, and partial autocorrelation function, and we checked different alternatives as I have referred to. Finally, we have come to the decision that ARIMA 1.1, ARIMA 1.1 model is fit for Nifty future, and ARIMA 1.2 is fit for gold future prediction. And after our model is fit, we have again run our regression. And we found that the R square is now 0.9946. So there is no doubt that there exists a relationship between these 2, at least among our forecasted data. Now I go for, as I have said, it is 0.9946, and adjusted R square is something. This is after running the model. Now we go for the second question, second research question. Whether short-term and long-term relationship persist during the COVID period. And what is the data set we are using? We are using daily data from 1st March 2020 to 28th October 2020. Look, my data period is very small. That is from 1st March. So March to October. March to October is basically, 1st March. So it is 8 months, almost 8 months. And if you consider quarter, it is basically 2 quarters. So 2 data points cannot frame a time series model. So in order to avoid this problem, what we have done, we have taken daily data. We have taken daily data to address our second question. And we have used very traditionally, of course, Johansson co-integration test in order to know our long-term relationship, and ECM model, error correction model, to know the short-term relationship. And we all know that ECM can be used only when we are sure about the long-term relationship as depicted by Johansson co-integration test. But even before we approach to this specific test, we have gone for ADF as well as Philip-Perron test for checking stationary. And the result we have found both long-term relationship and short-term relationship. So now finally we approach to our third specific research question, whether there is any causality. Look, right from the beginning, our focus is on the small investor. So if we finally got a causal relationship between these two variables, we may have some useful policy implication for the small investors. What causes what? That means, is there any unidirectional relationship or bidirectional relationship? So we have done pairwise Granger causality test, and the result is shown, and the result is already there in the slide. And our result is that it is the gold future price that causes the movement of Nifty future and not otherwise. So we conclude that this is a unidirectional relationship from gold to share, gold to Nifty future, and not reverse, So it's a unidirectional relationship that we have obtained. One more useful suggestion and one more useful result, that is the disequilibrium that we have noticed. It is being adjusted at the rate of 11.28% on a daily basis. 11.20%, 28% on a daily basis. So these are certain results that we have got. Now, future scope of study, we have a lot of limitations, we admit. The study confined to the fact that it considers only the past data, and it totally ignores the investor's psychological aspect. Nowadays, we have not only CAPM, but even behavioral CAPM. So much of advancement is there. But we have not considered the psychological aspect. We have used only the historical data set, and we have got it from different websites that also we have referred in this particular slide. So, and when we are talking about daily data, why not? We ask it to ourselves, why not by hourly data? That is also possible. Even tick by tick data can be used, or real life online data or real life data that we are talking about in different other papers. The good researchers have done it. Other different sophisticated prediction techniques, for example, we have used ARIMA. But apart from ARIMA, the more the days are going ahead, many sophisticated models are coming in econometrics every day. So we could use those models also, but it is a fact that we could not, improvise ourselves to that level. So we further believe that we have considered only Nifty future of index, but furthermore, the study can be extended on other index also. We all know that within Nifty there are so many other indices. So that can be done. The study could be enhanced by incorporating more variables. For example, why only gold future and Nifty future? There could be other variables also. For example, in Indian stock market, there are 4 derivative products are being sold. It is index future, it is index option, it is stock future, it is stock option, and gold could be compared with all these things. And why not silver? So there are so many why nots. A study can be conducted with financial instrument and equity market. Portfolio selection and optimization could also be a bunch of research. So once, yes, it is this kind of relationship is there. But what the specific portfolio a small investor should look for? What should be the risk return matrix? That can be done. So what I'm talking, recommendation. Finally, every research should come out with some, extremely original policy recommendation, and that shows the uniqueness of that particular paper. So I believe authorities relating to the financial market should organize the kind of seminars and conferences for, creating awareness, what we are doing in Pondicherry University. Apart from this, I believe we can speak further once the questions come from the listener side. Thank you very much. Thank you very much.
Sir, can you go back to your slide where you have mentioned about beta coefficient values? Go back. Yeah, keep it here. Next slide. Next slide. Next. Not previous, sir. Future. Go there.
Is it that slide?
Next one. Next slide. Next slide. Next. You keep it here.
Yeah.
You have fitted a regression relation. Am I right?
Yeah. Bivariate.
Bivariate.
Yeah.
What is the dependent variable?
Dependent variable is, X. Gold is dependent, and
Nifty price or something like that. You are saying.
Huh?
Nifty price and gold price. Huh?
Nifty future is Y. Okay. So it is Y is equal to alpha plus beta X.
You are assuming linear relation. Am I right?
Yeah. Future is Y and gold future is X. Sir.
Being it's a time series data.
Yeah.
Okay. You are claiming that Y equal to A plus BT. Am I right?
Y is equal to alpha plus beta X. Yeah.
All right. Alpha plus beta C. So when you see that original data, when it is a time series data,
right?
Okay. Had you verified that pattern? Because there might be a phenomena that autoregressive and moving average also may be there.
Yeah.
We cannot apply the linear relation. How many observations you have considered?
We have predicted fourth quarter of 2019 to first quarter of 2019.
Okay, that means around 365 means around 300 observations are there. How many observations are there?
Yeah, four quarters. So every year 4 quarters, and it is 40 to 43 data points are there.
43 observations are there.
That's 43 into 2. Yeah.
Okay. So 43 into 2.
Yeah, because one observation from gold, another observation is from Nifty future.
Okay.
Every quarter, sir.
Okay.
Sir.
So you don't have any time series related. That only one is dependent variable and another is independent variable.
Yeah. Bivariate.
Am I right?
Yeah.
Then if you saw that exhibiting of the graph, you have shown the graph is time axis is on x-axis, time is on x-axis, or what is the independent variable on x-axis? What is that graph? You just go through the graph. Yeah, keep it here. What is x-axis and what is y-axis?
Sir, this is gold. The right side is gold and the left side is, this Nifty future.
No, what I am asking, what is on x-axis value, what is on y-axis value?
This
probably
is
on x-axis you are making time variable. Am I right?
Right.
Y-axis it is the cost of the gold for second graph.
Quoted price. I should say y-axis is revealing the quoted price. Y-axis is quoted price and x-axis is
basic consideration of the data. You have considered the time series data for 2 different variables.
Yeah.
You are speaking about the data, stating that one is independent variable, gold price is independent variable, which are influencing that Nifty price. Am I right?
Yes.
So in that case, it cannot be a time series data. It is a bivariate data. We agree.
Okay.
In that case, are you having this way of point of plottings may not give the correct picture. It cannot give correct picture. Exhibiting of the graph, x-axis you have to take the gold price, y-axis you have to take the Nifty price. Then only that graph will indicate the relation between these 2 variables.
Right.
You have shown the time series data, but you have fitted the regression line.
Acha.
It makes that your fitted line indicating that T should be an independent variable your y should be an dependent variable. In that case only you can go for your regression. Otherwise, as per this graph, otherwise you have to show the graph in other way.
Acha.
Yeah, this graph and study requires some sort of modification, sir. Sir, which university you are?
Sir, Bardhaman University. West
Where
Bengal.
it is, sir? Where it is?
West Bengal. West Bengal.
West Bengal. Okay.
I'm from.
So what I understand, we will have a one-to-one discussion later.
Yes, sir.
Okay.
Yes,
I will bring you to many things that are supposed to be refined. I will talk to you later. Thank you, sir.
Yes, sir. Yes.
Work is nice. Work is nice. But the presentation we have to tune, sir. Fine tune we have to. We have to make fine tune. Thanks.
Hello. Can I have one point?
Yes, sir.
Yes, sir. Yes, madam. Yes, madam.
Now, the stock market data on the gold, you have taken it as a bivariate.
Right.
Now, stock market behaves in multivariate situations.
Yeah, yeah. I have.
Okay, now, no, let us not simplify it to that extent. And the stock market, the brokers will be misled by this situation. As Tirupati Rao said, when time series analysis is there, time is one variable. We cannot introduce some other variable and call it as a time series analysis. Number two, inflation. You are looking at small investors situation. They are sensitive to small time changes in this situation, and also the bank rates that are prevailing will also have effect on this Nifty. I have done this work myself. I find that it is very more complex. You have simplified to a large extent. Will this be a leading factor for us? Now, I think globally people are watching your presentation, and if the stock market feels that if it is so simple for us to estimate a Nifty, I think hats off to your situation, but we have to be a little more sensitive to other factors which are silently working on that. And also, it is never linear, sir. It is curvilinear in the whole situation. Also has to be adjusted. I am only making as a novice looking at the graphs and the simple situations.
Yes, sir. Yes.
Please build it into something else so that it will give direction to the stock market. This is one important thing that is happening now. Today, when the epidemic death rate has gone up, immediately the whole stock market plunges into some other level. When gold and these things are not factors of the situation. Those factors have to be built into the whole thing. Thank you, Professor Tirupati Rao, for giving me one more minute.
Professor Lakshman Rao has pointed in a way that when we are speaking the relationship between two variables, right, we have to take so much of consideration, sir. Okay. Your work, no doubt, your work is very worthy work, but it requires some small fine tunings. I will be let you know, sir. Please. Good, sir. Work is good. Thank you. Your efforts are worth appreciation. Thank you.
Thank you, sir. Thank you.
Sujata madam.
Sir, thank you, sir. Nice presentation, Gautam Mitra, sir.
Thank you, madam. Thank you, madam.
You can carry on, sir.
So last presenter is Yogesh.
Okay, sir.
Yogesh is there?
Yes, sir. Yes, sir.
Yes, sir. Please.
Visible, sir?
No.
Now, sir?
No. Now it's coming.
Yeah. Dr. Yogesh, I want to announce something. You make it brief, and because we have to start the next session by 5:30. Okay?
Okay, sir.
Right.
Okay, sir. Should I start, sir?
Yeah.
Start.
Okay. Respected chairman, member of organizing committee, and my dear friends. Myself, Dr. Yogesh Pangar, working as scientist at Department of Animal Genetics and Breeding, Lal Lajpat Rai University of Veterinary and Animal Sciences. This is previously I presented paper, one paper on sheep. It was estimation of genetic parameter for growth rates. Now, similar kind of study we also conducted in the goat. Now, this paper is from our university, Lal Lajpat Rai University, and in this paper we've tried to do the modeling for growth curve data, and then also try to estimate growth parameters for traits. So initially I will explain something about goat population. India ranked first in goat population and having 100 around 150 million goat in the India. Major state are Rajasthan, West Bengal. In this study, we use this breed, Jakrana breed. Jakrana breed is very important breed of goat population. Population is around 15 lakhs, and the different body measures, we can say appearance is, this breed is having white spot on ear and muzzle. This is dual purpose breed. The people, they are rearing for milk and meat purpose. We know the growth curve. Growth curve is show the pattern or show the growth over the time from birth to, we can say, maturity, or up to, we can say, lifetime performance or growth. We can measure that growth in terms of the growth curve. Now, study of growth curve is very important. It's very important for establishing some of the farm strategies. We can optimize some farm strategies. We can go for early culling, early selection, and other, we can say, to determine the best slaughter age. In order to increase farmer income, there is need to be improvement in production of this animal. So growth curve is the important criteria which can be studied by using mathematical equations, and further the biological important parameters of the growth curve can be interpreted. Again, the interpretation, or we can say estimation of growth curve parameter is not only sufficient, because we have to find out, is there any genetic variability between these growth curve traits. If there is enough genetic variability, we can go for selection on the basis of these traits. So this can be very good selection criteria if there is genetic variability. There is no such paper on this breed regarding growth modeling and genetic evaluation on growth curve characteristics been published. So this will be first paper on this breed. There are so many papers on so many different breeds. We have published this kind of studies, but for this breed, there is no such paper. Objective of this study to feed different non-linear growth models for growth curve traits in Jakrana breed, and second, to evaluate the genetic parameters for these growth curve traits. So study area of Jakrana breed from our department, Animal Genetics and Breeding, Lal Lajpat Rai University of Veterinary and Animal Sciences, Hisar, Haryana. We obtained weight records of 115 kids who completed their yearling weights, that's up to 12 months age, and the records of birth weight 3 months, 6 months, 9 months, 12 months we obtained. These are the different models we used for fitting the growth curve. First was Brody, then Bertalanffy, logistic, Gumpert's, negative exponential. Here, a dependent variable was body weight at particular time point. T is indicating the time point. The birth 3 months, 6 months, 9 months, 12 months. A is asymptotic weight, that is mature weight. B is inflection point, which is integration constant related to the initial animal weight. K is rate of maturation rate or rate of maturity, and E is the exponential function. And comparison of these growth models was done on the basis of different goodness of fit criteria. It's coefficient of determination, root mean square error, case information criteria, and Bayesian information criteria. The model which is having highest value of R square value or least value of RMSE, AIC, and BIC was considered as a best model. After that, after obtaining the best model, we use that best model and estimated parameter for each animal. Then we fitted this animal model to obtain genetic parameters. So growth curve parameter under Brody model, the method is restricted maximum likelihood method. We use Wombat software for genetic analysis purpose, in which Y is the trait, XB, B is the For fixed effect, A is for genetic effect, E is for residual effect. In OMBAT software, we have to go for multiple iterations. So convergence of this RML solution was assumed when the variance of function values was less than 10 raised to -8. Further, we estimate genetic and phenotypic correlation for these traits. Result, these are the growth curve pattern in male and female kids from 0 to 12 months of age, maximum age up to 25 kg in 12 months age. The result of growth curve parameter, we fitted these different models for 3 categories, for male, female, and overall. So we estimated this A, B, K parameter under this 5 normal model. We can see the parameters for male, for female, and for overall category. You can see here the maturity weight is lower in female as compared to male. B was equal and K was also equal. The comparison of different models was done on this goodness of fit criteria, and we can see here among the all model used, only Brody model shows the best goodness of fit criteria, is having highest R square and the lowest value of RMSE, AIC, and BIC value for all 3 categories, male, female, and overall group. After that, we estimate parameter under Brody model and fitted that animal model that under OMBAT software, and we got this kind of estimates for the heritability. So heredity variance, residual variance, and phenotypic variance. And estimate of heritability was very low, 0.01, 0.10, and 0.01. So very low estimates, means it indicates there was very low genetic variation among these traits. So there is very, you can say, very low scope for improvement if we do the selection on the basis of traits. Means selection will not be effective if you go selection on the basis of ABK. The conclusion, we use 5 growth model for describing the growth curve characteristics in Jacaranda goat, and odd models show the good fitting, describe these traits analytically. Among the all models, Brody model was found to be most best. The ranking of model on the basis of goodness of fit criteria, Brody model was best, then Butterfly, Gumpers, autistic, and negative. Maturity rate was almost equal in male female. Female kids had low maturity rate than male kid. The additive variability among this trait was low in magnitude, which indicate there was high environmental variation. Means we have to focus more on management practices like feeding, rearing, housing, or health practices instead of selection or breeding practices. Overall, it was suggested that Brody model, which can be used for adopting appropriate management practices in order to achieve desired shape of growth curve and to develop partial selection strategy for the overall improvement in the breed. That's some references regarding other sheep and other goat. Thank you.
Okay. Madam, please.
Yes, sir. Nice presentation. Their presentations almost on animals, goat and sheep. Nice presentation, sir.
So this technical session is over, madam. Thank you very much. You're sparing your valuable time with us, and thank you very much for chairing this session. On behalf of the organized committee, I thank you very much, madam.
Sir, 1 minute. Shall I conclude, sir?
Conclude, ma'am.
So, good afternoon, one and all. Yesterday was a dream and tomorrow is a vision. But a day well lived makes every yesterday a dream of happiness and every tomorrow a vision of hope. These were really inspiring presentations. All presentations are really nice, and it is a real honor and privilege to share the same platform as yours. The presentations were enlightening and fabulous. Thank you, one and all, for your gracious presence and spreading smiles and knowledge. Once again, thank you so much for the organizers to chair the session, and enjoyed the lot. Mostly researches and that research works in statistics in different topics. Stay safe, everyone, and have a great day. Thank you, sir. Thank you, one and all.
Thank you, ma'am.
Thank you, sir.
So we can close.
Thank you, madam, for chairing the session. Thank you, Ramakrishna, for organizing this session. And now we are going to start the next session. Actually, it is supposed to be completed by 5 o'clock. Due to the of many members.
Presentations are nice, no, sir. Very interesting, and so it will go on.
Interactions are very interesting, so people are very active. So thank you, one and all. Right.
Yes, sir.
So if you wish, you can continue. Otherwise,
thank you for giving me the
Thank you so much, sir. Thank you. We will leave.
Now, Ganapati, are you there?
Yes, sir. Yes, sir.
Ganapati, what you do is you just give a break for recording, and then again start, because it will be lengthy video otherwise.
Yes, sir. Yes, sir.
Okay.
Yes, stop, sir. Stop, sir.
Oh yeah. You just stop it and again you start it.
Yeah.
That is one thing. Now it's already 5:30. Now next session we are going to start. Now this session is going to be chaired by my colleague, Professor Sudesh Pundir. Sudesh Pundir, madam, is already online. Madam, you just adjust your camera. You light. Yeah. No. All right, this way. All right. It's okay.
Right,
So,
sir. Thank you.
Now, it's my pleasure to invite my colleague, Dr. Sudesh Pundir. She did her post-graduation and doctoral program at Punjab University, Chandigarh. And she joined in our university in 2010 as assistant professor. Now her promotion for associate professor is in June. So time being, we can call her as associate professor, no issue. So our vice chancellor is very interested to make all our faculty members welfare. So therefore, soon all our dues will be clear, what I understand. And with due thanks to our university administration for permitting and providing all the necessary infrastructure support, we are organizing this program, virtual international conference. Now, in the evening session, we have 8 speakers. Right now, the names I will just read out. The names that are supposed to be day 3, yeah. That are Dr. Kimya Tinani from MS University, Professor S. Chandrasekhar, Dr. M. Ramakrishnan, Professor K.K. Singh from BHU, and Ramakrishna from Chennai, and Professor Kanchan Jain from Chandigarh, Professor Gadde Srinivasarao, Professor Manish Kumar Sharma from Jammu University, Gadde Srinivasarao from Tanzania, Professor H.K. Lakshman Rao from Chennai. These are the speakers for today. And I request all the speakers, if they are available, we will make the program as per the schedule. Yeah, Tinai Kimya is there. Tinani Kimya.
I'm there, sir. Yes, sir.
I request, you're madam. So sorry.
Yes, sir.
Sorry, I'm impressed that you are. I don't know what is the identification of gender through your name.
Yes, sir.
Sorry.
No, sir.
Okay. Now I request my colleague, Professor Sudesh Pundi, to take up this program and chairing the session. Madam, you can carry.
Yes, sir. Thank you, sir. Thanks a lot. Good evening, everyone. I welcome you all. So let me introduce our speaker. Let me share the slide. I think everyone is able to see. Sir, is it visible?
Yes, yes.
Okay, okay, thank you. So our first speaker in this invited session 6 is Dr. Kimia Tinnani, and she's from Department of Statistics, Faculty of Science from Maharaja Sayaji Rao, University of Baroda. She is having the teaching experience.
Rao and Kimia, please mute off your mics.
Okay, okay.
Yeah. Now you can carry on, madam. So this one there.
Okay, okay, sir. Okay. So, Let me start it. Dr. Kimia Tinnani, she is having the 22 years of academic experience of teaching statistics from first year BSc to final year MSc students. 6 years of experience of teaching statistics to MSc biostatistics students as a visiting faculty in the Maharaja Sayaji Rao University of Baroda. 4 years of experience of teaching statistics to first and second year students of BBA as a visiting faculty in the same university. 3 years of experience of teaching research methodology and medical statistics to the students of MD Ayurveda program, Government Ayurveda College, Vadodara, as a visiting faculty. She is having 11 years of research experience of guiding postgraduate students in their project work. In administrative assignments, she is the member of organizing committee of science open house, supervision duty, admission duty, press duty for conducting entrance examination, industrial visit arrangement, working as counting officer during the union association election. So I just, so Dr. Kimia Tinnani is going to deliver a talk on the perishable stochastic inventory model under inflation and trade credit. So I invite you, madam, you can just start your talk.
Good evening, all of you. First of all, I am very much thankful to Professor Tirupati Rao sir, who has given me this opportunity for presenting my work. I am very happy to be a part of this prestigious international conference. I'm just sharing my PPT. Is it visible, sir? Madam?
Yes, yes. Please continue.
Yes. Okay, now the title of my talk is Perishable Stochastic Inventory Models under Inflation and Trade Credit. Okay, the contents of this talk are supply uncertainty problem, trade credit, inflation, optimal policy, numerical examples, sensitivity, and with conclusion. Okay, now inventory is a stock of item which is very much useful for future use. The main reason for maintaining inventory level is to shorten the gap between demand and supply. Any inventory system consists of input process and output process. Input process refers to the supply either by means of production or purchase, while output process refers to the demand due to which inventory occurs. So in most of the inventory problem, it is assumed that the product to be ordered is always available. That is, when an order is placed, it is received immediately or after some random lead time. However, if product is purchased from outside of the supplier, the supply of the product may not be available due to some unpredictable circumstances. So in that situation, inventory manager would need to know how to produce or purchase when supply is fully available. Silver be the first author who had discussed the need of models that deal with supply uncertainty. Parler and Birkin consider the supply uncertainty problem for class of EOQ models. Now, in classical EOQ model, it is assumed that the payments for the goods should be received immediately after receiving a product. However, in today's business transactions, suppliers allow some grace period to customer to settle the account. Okay, so during this period, no interest will be charged by the supplier, but if payment is delayed beyond that period, then interest will be charged by the supplier. So this is an advantage to the customer that they do not have to pay immediately after receiving the product. So customer can start accumulating revenue on the sale of the product. At present, it is impossible to ignore the effect of inflation. It is necessary to consider the effect of inflation on inventory system. I have considered here 3 models which I already developed, and they are published in very reputed journals, that is journals related with ISPS, Indian Statistical, Probability Statistics, ZISA, IAPQ. Okay. So one of the model is single supplier, that is stochastic inventory model under inflation and permissible delay in payment, which is developed based on certain assumptions. Since our demand is deterministic, that is D is greater than or equal to 1, and status of system is initially on. Here on means what? Supplier is available. On period means supplier is available. So here we define 2 random variables, X and Y, which are corresponding to the length of on and off period, where X and Y are random variable corresponding to the exponentially distributed with parameter lambda and mu, which are independently distributed. Here we define Q is our order up to level and R is reorder level. That is Q and R are our decision variables. Q is order up to level and R is reorder level, which are our decision variable. Theta is a rate of deterioration. And here we define T0. T0 is a credit period which is known constant, and T00 is our cycle period, which is decision variable. We define inflation rate as F. R is present value of nominal inflation rate. Now here we define our indicator variable as delta, where delta takes value 0 and 1. So when it is 0, that means what? If account is settled completely at T0, where T0 is credit time. So interest charge is usually higher than interest earned. The actual cost incurred will be developed by this expression. Now here supplier allows a fixed period T0 to settle the account. So during this fixed period, no interest will be charged by the supplier, but if payment is delayed beyond that period, then interest will be charged by the supplier. Okay, so during this fixed period, customer can accumulate revenue on the sale of the product. Account is settled completely either at the end of the credit period or at the end of the cycle period. So here usually interest charge is higher than interest earned. Now the policy for the decision model we have developed here as QR policy. So when inventory drops to R and period is on, we can order for Q units, which increase our inventory level Q plus R. So when inventory drops to R and period is off period means supplier is not available, then decision maker has to wait until the supplier become available. So here cycle is defined when order is replenished, when supplier is available. Average cost objective function is defined as expected cost per cycle to the expected length of the cycle. For finding this expression, we have used renewal reward theorem, and optimal solution we have obtained using Newton-Raphson method in R programming method. Now here we are considering examples. So first model is related to single supplier. So here I have considered 2 cases. First case is inflation rate is less than interest charge. So here if you see in this example, our inflation rate is 0.05. This is our inflation rate and interest charge is 0.15. So here we are considering inflation rate is less than interest charge and delta is equal to 1. Okay, so delta is equal to 1 means what? As we have defined indicator variable, delta has value 0 and 1. So 0 means account is settled at a credit time given by the supplier, and 1 means account is not settled. So here if we see our average cost is 197, and if you see in another case what we are doing, we are keeping other parameter as it is. Simply we consider now delta is equal to 0. So here our indicator variable 0 means what? Account is settled Okay, whatever the period is given by the supplier, so account is settled at a credit time given by the supplier. So here we will see that our average cost is 194.89. So from both the numerical example, we conclude that the cost is minimum when account is settled at a credit time given by the supplier. So this implies what? We encourage the small businessmen to do the business by giving them loan, but simultaneously we want to discourage them for not clearing the account at the end of the credit period. Now, another case we have considered inflation rate is greater than interest charge. So here we have considered R is equal to 0.25 and interest charge is 0.15. So again, we have considered two different situations, that is delta is equal to 1 when account is not cleared and account is cleared. So here we will see that when account is not settled at a credit time given by the supplier, so here it is advisable not to settle the account at the end of the credit period, but settle the account at the end of cycle period, because cost is minimum when you not settling the account. So the reason for this, once inflation rate is higher than the interest charge, we actually see our debt wiped out by the inflation. Now, again, we have extended our single supplier model to the two supplier model. So in practically, we will see that here we are assuming that inventory manager may place his order with any one of the two suppliers who are randomly available. We assume that the decision maker deals with two suppliers who may be on or off. So here actually there are three states 0, 1, 2 that represents availability of at least one of the two suppliers, and state 3 represents both the suppliers are not available. So state 0 means both are available, 1 means only supplier 1 is available, 2 means supplier 2 is available, and 3 means both are not available. So here it is assumed that one may place order to either one of the two suppliers when both the suppliers are available. Okay, so for this we have assumed different assumptions that our demand is deterministic, right? We define xi and yi be the random variable corresponding to the length of on and off period, which are exponentially distributed with parameter lambda I and mu I. Okay, xi and yi are independently distributed. Here our qi and r, that are our decision variable. Qi is order up to level, r is our reorder level. Here we have defined our credit period T0I, which is allowed by the ith supplier, and T00 is our cycle period. So here we define our indicator variable for ith supplier is equal to 0 and 1 if account is settled completely at T0I, and 1 otherwise. Okay, so these are the notations for inflation rate and interest earned. So again, here we are assuming that the supplier allows a fixed period T0I to settle the account. During this fixed period, no interest is charged by the ith supplier. But beyond this period, interest is charged by the ith supplier under the terms and condition. Okay, the account is settled completely either at the end of the credit period or at the end of cycle period. Now here the policy we have chosen as Q0, Q1, Q2 are, okay, these are order level and reorder point. So order is placed for QI units when inventory drops to R. Okay, and supplier, when both the suppliers are available, Q0 is total order either from one or both the supplier. If process is found in state 3, that is both the suppliers are not available, nothing can be ordered. So in that case, shortages start accumulating. So here we define cycle as when both the suppliers are available. So again, here we have calculated average cost objective function as a ratio of expected cost per cycle to the expected length of the cycle. And we have used renewal reward theorem to develop average cost objective function. Again, we have find optimal solution using Newton-Raphson method in R programming. We have same situation now. Here there are 4 different situations in case of 2 supplier. Here we are considering our indicator variable as alpha 1 is equal to 1 and alpha 2 is equal to 1. First situation is inflation rate is less than interest charge. So again, here we are seeing that business in first situation, when businessmen do not settle the account at the respective credit period, our average cost is 6.245. If we consider another situation, that is alpha 1 is equal to 0 and alpha 2 is equal to 0, that means account is settled. Okay, businessmen settle the account at respective credit time by both the suppliers. So cost is minimum if you see here. Third situation is first supplier, whatever credit time is given by first supplier, businessman is settling that account, but he is not settling credit given by the second supplier. Similarly, fourth situation, when alpha 1 is 0 and alpha 2 is 1, that is when an account is settled by businessman at the credit time given by first supplier, but he do not settle the account at the credit time given by the second supplier. Okay, so among all the four average cost, we will see that cost is minimum when account is settled at a credit time given by both the suppliers. Now again, procedure we have repeated whatever we have done in single supplier. Here we have considered another situation when inflation rate is greater than interest charge. So again, there are four different situations, but here we are considering our inflation rate is higher than the interest charge. So in that situation, when our inflation rate is greater than interest charge, so we will see that cost is minimum when both the businessman is not settling account at the credit time given by both the suppliers. So again, here we can say that businessmen are advised not to settle the account at the end of the credit period, but he has to give an advice to settle the account at the end of cycle period. So if you consider when second supplier is off, okay, so the solution of the above problem reduces to the solution which we have found in single supplier, that is case 1. If we compare both the cases, so in that case, we will see that when we consider two supplier case, our cost is minimum as compared to, our cost is reduced as compared to single supplier case. So the moral of the story is that it is always advisable to go for two supplier or multiple supplier for reducing average cost. We have conducted sensitivity analysis also. So here I am giving some example related with, first we are considering, like if we consider inflation rate is less than interest rate charge, there are four different situations when businessman is not settling the account at the credit time given by both the suppliers. So here we see that as our inflation rate is increased, our average cost is increased. Another situation, that is when account is settled by both the supplier. Here account is not settled at the credit time by the first supplier, but settled at the second supplier. So among these four different situations, we will see that cost is minimum when account is not settled by the credit period given by both the supplier. Second situation, inflation rate is greater than interest charge. So again, here we have consider different four situations. Okay, and we will see that cost is minimum when account is not settled. So overall conclusion is what? By comparing two cases, that is when inflation rate is less than interest charge, we conclude that cost is minimum when account is settled at the credit time given by IH supplier. So in this situation, also businessmen are advised to settle the account at the credit time given by the respective supplier. However, when inflation rate is higher than interest charge, we conclude that cost is minimum when account is not settled at a credit time given by the IS supplier. So in this situation, businessmen are advised not to settle the account at the end of the credit period, but settle the account at the end of cycle period. So the reason for this is that once inflation rate is higher than the interest rate charge, we actually see debt wiped out by inflations. We have extended our model for multiple supplier. So in this case, we have generalized the model considering the case where there are suppose M suppliers. At any time, suppliers may be available or not available, which we represent as on and off state. So here there are 2 raised to m states. We have repeat the same experiment, and we have seen that when we go for multiple supplier, when number of suppliers become large, the objective function of multiple supplier problem reduces to the classical EOQ model. These are the references. Thank you, sir.
Thank you, ma'am, for such a nice presentation. Any questions?
Yeah, I have a few questions.
Yes, sir.
Some of the assumptions that you have made appears very unrealistic in the actual situation. Look at the agricultural products and look at the non-agricultural products. How inventory is managed. People do not pay, not only interest, they don't even pay the money that they are required to pay. That is the actual situation in the market. Now, if you assume these variables, I think your model is very shaky, not applicable into a real situation. I do not know whether your data collection is done by a survey of the market situation. In case of agricultural product, the rate of inflation is much higher than the market rate. Look at the onion prices now today. Now, what is happening in the inventory model in the wholesale market and the retail market? I think none of these things holds good in an actual situation. Therefore, statistics is more criticized than accepted. This I want to make a very broad understanding. We have lost in touch with the reality of life. Therefore, statistics is good for books and theory and not in actual practice. Either look at the stock market, manufacturing market, agricultural market. The UOQ, it does not work now. UOQ is more psychological than real. Please comment on this.
Madam,
Yes, sir.
Yes. Yeah. Yes, madam.
Sir, actually, this work is already done. We have extended the work of Palar and Birkin, which they have already done in that way for multiple suppliers. Here we have considered the effect of inflation and trade credit. So actually, it is already proved by Palar and Birkin in 1991. That is, whenever we consider the multiple supplier, it reduces to classical EOQ model. We have referred that paper only.
You see, what I'm trying to say is in a multiple supplier situation, if one supplier stops, they don't pay the money, they will go to the next supplier. So the man is harassed. That is the actual situation.
Yes, sir.
So have you factor in your modeling?
No, we don't have consider, but definitely I will consider whatever your suggestions, and we will consider for this research paper as a case study. By considering real life data.
Lakshman Rao sir.
Yeah, please tell me.
Shall I add something to this? Your observations.
Yes, sir. Please.
So see, as Lakshman Rao said, is making that statistical point of view, survey point of view. There are many factors that are influencing the inventory. But Professor Kinani Tina, she has presented an inventory model. This inventory model is an application of operational research. It's not comes under the statistical survey related problem. She has proposed a model when you are handling with the perishable goods. Okay, so this economic order quantity is influenced by different inventory costs. That inventory cost may include setup cost, shortage cost, holding cost, some unpredictable costs also. So any model, if you consider within the framework of certain assumptions only will work out. Professor Lakshman Rao has some presumptions. That presumptions may not be considered with the model development of her model now. In that case, what they can do is the OR model, operational research model, what she has suggested in the particular case of inventory management. Inventory management concern is one of the concern is optimal order quantity, economic order quantity, or you can say optimal order quantity, how much to be maintained in a stock. So in that process, there are so many costs that are involved: setup costs, storage cost, and shortage cost, and incidental cost, inflation cost, investment cost. Many costs are involved. Your perception is also one among the costs, but your model has considered with certain specification of assumptions, has she coded one paper. That research paper she has coded. Basing on that, she has built up a model. That might
I just want to add one more point out of my experience.
behind this research work, and this is what my observation. Model development may be used under the specified assumptions of the researcher. This is what
I just want to add one more. It is not necessary to apply OR model for inventory control. I have applied SQC model for inventory control of pharmacy in one of the large corporate hospitals, and I am able to control the inventory in a much better way at a 3 sigma level. So we have to make something which is really applicable, which a man on the road can understand. No, these are not real situations. These are theoretically good, but actually practically we have lots of difficulties in this. A practical situation. Theory. I just want to share with you that I have done this in a corporate hospital in controlling drugs, inventory of management of several medicines using SQC model, and it has worked very well. They have saved 34 lakhs in 4 months' time.
Yeah.
Just SQC model.
Over.
Thank you, sir. Thank you for your good suggestions. So, any other question? Okay, let us thank our speaker. Thank you, ma'am. Thanks a lot. Now, our next speaker is Professor S. Chandrasekhar. Let me introduce him. I hope it is visible. So,
yes.
Professor S. Chandrasekhar is senior professor.
It's display. Okay. Yeah, you can carry on, madam.
Yes, sir. Yes. Professor S. Chandrasekhar is the senior professor and director analytics in IFM Business School, Bangalore. He was chair professor from July 1998 to February 2013 and officiating director at Ford School of Management, New Delhi from 2009 to 2010. He joined Ford School in 1988 as senior professor. He also headed the software development at Ford School of Management, which are developing prototype of products in the area of business intelligence, risk management, and customer relations management. He has a total of about 34 years of experience in R&D, academic and industry in the area of quantitative techniques and IT. He has taught the courses in the area of IT, QT, advertise, marketing, market research at postgraduate level. Prior to this, he worked at Indian Institute of Management, Lucknow, for about 10 years as professor in the area of computers and information systems. He is a member secretary of IIML governing board for about 3 years. He was awarded NASSCOM Devang Mehta Award for the Best Teacher in IT in year 2010. He was awarded as India Higher Education Forum Award for contribution of technology in higher education 2012. He was awarded Times of India Education Times Award for contribution in IT area in 2013. He was facilitated as one of the best teachers by IIM Lucknow alumni during Silver Jubilee celebrations. Awarded Excellence Award for contribution in IT education by Asian Customer Engagement Forum in 2014. Outstanding contribution in education by India Education Network in September 2016. Is one of the 10 analytic faculty by Analytics India magazine for 2017 and 2018. His contribution at IFIM started executive PGDM 15 months program in business analytics in association with IBM, involved in curriculum design, course content, upgradation of analytics lab, involved in selection of students and other administrative activities relating to the program like faculty recruitment, student admission process. He also introduced business analytics as an area of specialization in full-time PGDM program also, associated with NASSCOM to launch joint program in analytics, involved right from the beginning. IFIM is a partner for Karnataka State to conduct NASSCOM related programs in analytics for Karnataka State. He has taught courses in analytics for EXEC, PGDM, and full-time PGDM students. He has written articles in various management magazines, print media in the area of business analytics and machine learning. He has attended NASSCOM Big Data Conference in July 2016 and 17, attended Intel Research Colloquium in 2017, attended and presented research work at Innovation Summit held by Career Launcher, panel speaker in IEEE International Conference held at Times Business School, New Delhi in December 2017. He has presented paper and panel speaker at International Conference of Data Science in Singapore in 2018. He was keynote speaker at International Conference on Emerging Trends in IT organized by IEEE and ACF at VIT Vellore in 2020. Attended Machine Learning at Data Science Conference conducted by Analytics India in February 2020. Conduct research in developing a model for predicting the loan rating transition using sentimental data and quantitative data using advanced predictive modeling techniques. He has patent also has been filed for this work. He holds a bachelor's degree in electrical engineering, master's degree in computer science from IIT Kanpur, and doctorate in quantitative and information systems from University of Georgia, USA. Worked in India, USA, and Canada in reputed organizations like TIFR, ISRO, NRSA, Ford, Aerospace Corporation, National Research Council before joining IIM Lucknow. Awarded UNDP Fellowship for study in advanced computer systems design. Worked in the area of neural network, forecasting using statistical techniques, mathematical modeling, data warehousing, data mining. So our next speaker, Professor S. Chandrasekhar, I invite him to deliver a talk on predicting long-term enterprise value using machine learning with the financial and news data. Sir, please continue.
Yeah, Professor Chandrasekhar, welcome, sir. Welcome you for this one.
Namaste.
And I request you to make it by 6:30, sir, so that
yes.
A lot of speakers, please. Right.
Sure. I thank her for the excellent introduction she has done. I don't know how much justice I can do for this. Let me.
Thank you, sir.
Let me try my best. So, there are a lot of mathematicians who have spoken. Okay. So, I will take that mathematics to the background. So, this is a practical work. I will somehow briefly tell this practical work. There are a lot of research work that has to go in the background. There are a lot of mathematics and statisticians here. I think some of their students should take this work further. There are a lot of challenges we faced, and we are not that much from maths background. So we need somewhere hand-holding from your side. Sir, this PPT, how do I share? Shall I share the screens or orally speak?
No. There are you able to make it? Isam?
Oh, sir, yes, sir.
Have you shared it to us, sir? Chandrasekhar, sir?
I have sent it.
You have sent to us?
Yes.
No, sir.
So, Isam?
Yes, sir. 1 minute, sir.
Sir, PPT is available with you?
No, sir. Sir, you can just click on the present now and then share it, sir.
Where? Here.
Sir, there will be a button present now. In the down bottom, like right bottom.
Present now.
Yes. Click on that.
You are now. Isam, please hold. I will explain.
Okay, sir.
Sir,
are you able to see?
No, sir. You just click the present now.
That's what I did.
The dialog box will become there, sir. Just select that one.
No, don't worry. I will just orally speak. It doesn't matter. I don't need PPTs. In fact, PPT slows the presentation. So it is much faster without PPTs.
Okay, carry on.
So this long-term enterprise value is one of the things which normally companies use when they want to acquire a company. We have another thing called market capitalization. Market capitalization changes day to day. Whenever your equity value changes, your market cap changes. So it is a short-term predict value of the company. So when somebody wants to buy a company, they are not interested in the short term. They want to look at least 1 year ahead and 2 years ahead, and then try to see whether this acquisition or merger or buying the company is worth, or we should not do it. We have a lot of short-term forecasting models, starting from our classic time series forecast, Arima, Arch, Garch, Exponential Garch. All these things are there, but most of them do only short-term prediction. They will not be able to predict 6 months ahead and 1 year ahead. So it is not possible to use those type of time series classical forecasting models for this. That is the first part. So what we did was, another thing that happens is this balance sheet comes only once in a quarter. So what we did was, we took about 20 companies, our Indian companies which are listed in the NSE exchange. Last 15 years of data was taken. So we had 15 into 4, 60 quarters of data. We initially started with about 30 financial parameters that normally predict a long-term view of the company. 30 was very huge, because what happens is then we will have to analyze the data in 30 dimension space. It becomes little complex. So what we did was, we used 2 methods to reduce the dimension of this so-called 30 variables to something like 5 or 6. So all of you know, one is our classical method, that is your factor analysis. So with using factor analysis, we reduced it to 4. But somehow we felt, yes, factor analysis does a linear combination of those variables. But somehow many of them were highly volatile and some type of a non-linearity was there. So at this stage, we decided to use that machine learning algorithm to reduce the dimension. So the classical way of doing this is what is called an autoencoder. So we fed these 20 parameters to an autoencoder. Since we don't have time today, I will not be able to explain how that autoencoder works. So using autoencoder, it does some type of a nonlinear transformation. There is something called a bottleneck layer, there is an encoding layer, there is a decoding layer, and eventually we will compress that whole 20 dimension, if you want to call it a signal, into 4 dimension space or 5 dimension space, and it does some type of a nonlinear transformation, not in one stage. In your factor analysis, it does only one stage linear transformation. That's how it does. Whereas here, it is a recurrent neural network. It goes through 2 stages, and those 20 parameters have been reduced to 4. So all our further work, we will use these 4 parameters, first financial parameters, to predict the next 6 months to 1 year enterprise value. So what we did was, we used our classical time series, our Arima and multivariate Arima, then single stage neural network and recurrent neural network. This is what we used and predicted the long-term range. What we did was, there were about 16 years of data into 4 quarters. We have 64 samples. In that 64, 62 was used to build the model, and then last 2 was what we call the holdout sample, on which we will do a prediction using the model as well as validate it. So with only using financial parameters, I can tell you the companies. We did it for Maruti, Asian Paint, Hindustan Lever, ITC, then Reddy Labs, and then one more, I think, from Birla Cements. So we took one company from each sector. It represents FMCG, it represents pharma, TCS. from IT. Then we have Tata Steel from Tata's, so that it covers the entire spectrum. So we had 64 data records. We took 62 to build the model, and we forecasted on the next two. And since we know the actual value also, we could compute mean absolute percentage error. The MAP was varied between 20 to 32% for the 6 months forecast. Then what we did was, we have a lot of news of these companies. So we extracted this news from the Bloomberg terminal for all these companies for the 64 quarters. It was a massive work. For each of these quarters, we used to end up with 200, 300 news. So for each quarter, so for 64 quarter, we used to end up with 15,000, 16,000 news into 8 companies. We landed up with 1,20,000 news. Obviously, it is impossible to analyze this type of news using manual method. So what we did was, we selected 10 to 20% of this news. Since it is a management institute, we have finance faculty also. Manually, they classified the news. Out of this 20 sample, about 1,25,000, that 1% happens to be about 1,200 news. These 1,200 news were manually classified, and we grouped them into 5 sentiments: highly positive news, positive, neutral, negative, and highly negative. Then we used the machine learning to train it. There what happens is, since it is a news, lot of pre-processing has to be done. News handling is little bit tougher than handling the numeric data, because there is a negation aspect of the news. For example, if someone says stock price is going up, it is a positive sentiment. Non-performing asset is going up, it becomes a negative sentiment. This simple no changes the polarity of the sentiment itself. So we have to be very careful, and that lot of pre-processing we did. What we did was, we break these sentences into words, do the POS tagging, then remove all these filter, all these punctuation marks, all these stop characters, etc., etc. Then we use this latent digit algorithm. That is where your mathematics comes in this. There is something called an LDA algorithm. It classifies your text into topics. Now, this LDA was developed about, I think 10 years or 15 years back. It uses the Dirichlet algorithm to classify the topic. After this, no other algorithm has come, and there are certain limitations of this LDA. So one of my requests to this huge gathering is, someone should improve this LDA algorithm. There is a big scope in that. What it does is, given a huge corpus of text, it will automatically extract the topic from the text and classify the document itself. Somehow the latest so-called 10 years old is what we call that. It is based on the Dirichlet distribution. That is why it is called latent Dirichlet algorithm. So latent Dirichlet algorithm, when we analyze large volume of data, yes, there is a lot of misclassification that is happening. I think that is one area of research where my huge statisticians and mathematicians who are much brighter than me are in this assembly. Please do it. You can patent that also. Virtually another 3 patents should come out of this exercise. That is a huge exercise I am leaving. I just said the limitation we faced. So after classifying these manually, these 1,200 news, we used the machine learning algorithm to classify the other news. That means roughly 1 lakh news were classified based on the manual classification of about 2,000 news. Initially, the errors were very high. Obviously, this is an imbalanced sample set. So obviously, if you to do it is a very error. Then what we did was that erroneous error only we started correcting. Then finally we convert this text to word to vector. There is one method of converting word to vector. It is highly inefficient method. So if my after auto speech and all, we want to extract the sentiment. Sentiment comes in adverb, adjective, verb. So this is what we have to filter from your whole text, which contains your noun, pronoun, conjunction, preposition, ... And when we convert this word to vector, it becomes a very sparse matrix. I have something like 4,000, 7,000 keywords extracted from the document, and most of the words appear only in 1 or 2 documents. So you will end up with a huge matrix like 110, some 3 columns out of that 4,000, then another 3,700 columns blank. So this becomes a highly imbalanced, or what we call the ill-conditioned matrix. We use something like that, what we call the decomposition and other things. The present technique uses to reduce this sparse matrix into other matrix. But for large matrix, no, there is a problem. I think this is another area of research. Students should take, how do we extract better information and reduce this 4,000 dimension vector to some 100 or 150. That is still a problem in our present sentiment analysis tools. So the sentiment we extract, sentiment we merge it along with the financial data of all these companies and predicted using a recurrent neural network. Two-stage recurrent neural network. We use that hyperbolic tangent activation function in the first phase. Then the rectified linear unit, that is another classic transformation function used in the second phase of the neural network. So eventually we classified, and then when we predicted the outcome, the mean absolute percentage error came down to 5%. So the Maruti next 1 year enterprise value prediction, we are able to predict about 5%. I think for Ready Lab it was 12, because this error varies from industry to industry. Because there are certain industry specific things that go into the news. There are some regulatory issues for pharma industry, finance industry regulatory, cement industry regulatory news are different. So we have to build some context sensitive news classifier for each of these industries, because the keywords are different and the contexts are different. Now we used only one type of what we call this news processing for all the sector. So the second challenge we are having is we should develop these local, what we call the context sensitive classifiers for each of the industry vertical, like pharma, heavy engineering, automobiles, then IT sector. Each one of them has specific keywords, and your classification accuracy depends on the keywords. So right now we do not have these type of language models developed for each of the vertical. I think that is another area where a lot of mathematics should handhold. Eventually what runs in the background is all mathematics and statistics only, because your financial market is one market which is highly probable. Your entire probability theory, stochastics and all can be applied to any number of things that is there, and data is public now. This is one domain where data is public. Most of the listed companies have to put the data in the public domain. So there is no dearth of data in this. And all the news and all you get from Reuters, you get from Bloomberg, and then you get from NSE. So data is not a shortage. What we are running shortage is the techniques and mathematics that apply to my country data. Another thing we found out is some of the models, recurrent neural network and machine learning models, which were used in other countries. We tried to use it for Indian data. Indian data, I don't know, has its own, I think, challenges. It did not work. So the summary of the work is, yes, with this machine learning and collecting data, analyzing large volume of news, we are able to predict next 6 months.
Excuse me, sorry for interruption for your flow, sir.
2 minutes.
Sir, this
another
is
1 minute.
Hello?
Another 1 minute.
Yeah, sir, please make it.
That's all. So we are able to classify between 5 to 10% accuracy. So with more mathematicians coming into domain and statisticians coming into domain, I think we should reduce this error. I think with this, I will close my talk, and I thank once again for providing me an opportunity to speak in this C.R. Rao's well-known statistician conference. Purposely, I left out the mathematics part out of this because you are all on the other side. So please take care of that. Good evening to all of you.
Thank you, sir. It was a nice thing, but it was more verbal than numerical. Your analysis was more on grammar, adjectives, and pronouns and nouns than numbers 0 to 9. This is on the lighter side. But you have taken a 15-year data. Demonetization was in between. Demonetization was in between. It has crashed all your things. The financial market has lot of impact on the demonetization. And if this is a factor, I think all our estimates are not valid and robust.
No.
In order to make the robust situation, we must take demonetization as an important event in the whole financial market. Your 15-year data is intervened by this demonetization, is what I want to say.
Shall I respond to that?
Yes, sir.
Yeah, I will definitely respond. So what happens, what he said is correct. During those demonetization days, we set up a special indicator variable that was put. And the second thing is, during demonetization, since we took the news component into effect, lot of negative news were there. So that way your demonetization was built into the sentiment part, which was built into the model. That is why the accuracy went up. You remember I told, without this news component, our model error was between 10 to 30 across all the samples we took. The moment the news was incorporated, after all your demonetization, there is a lot of news that has come. So when the sentiment was extracted, most of them came out during that time and little bit of following the time also as highly negative sentiment. So they will all, the indicator variables were set to -3, -4, -5 like that. So that has been taken into account. We have taken into account. Yes.
Thank you.
Yes.
You are correct, sir. Sir, your talk is very, very extempore, and you have touched upon very depth of the data mining, text mining, sentimental analysis, factorization, dimension reduction, artificial neural networks. Within a short span, you have covered a lot of this one. That means your depth, whatever you can, diversify knowledge and depth of the knowledge in making that. So really a wonderful experience to me today to listen you, sir, on speaking on predicting long-term enterprise values by incorporating the sentiment analysis and other fields. Your contributions towards the financial research through machine learning, and what we now we are witnessing that intelligence, business intelligence, or data-driven decision makings. These are all the latest requirements and demands of the people where data scientists are working for that. I agree with you. Your way of making use of advanced mathematical tools for exploring the hidden intelligence within the data by mining the data and exploring the data intelligence. These are all the various requirements where you can properly point out that math is the mother of all these subjects. And you are correctly touched the point, sir. Thank you very much, sir, for your exploring extempore lecture, sir. Extempore lecture.
And any help you need from my side, I am always there. All your youngsters can contact me.
Yeah.
Lot of research problems I can give. We have 30 problems waiting for them.
Right, sir. We will be in touch with you. We will be in touch with you, sir. We will be in touch with you, and really it's a real fortunate thing for us to have your interaction. Definitely we can make use of this interaction, sir. Thank you, sir.
And we will get the funding also from all the, we will get funding from the companies for these students.
Exactly, sir. Exactly. We will be in touch.
We will get enough funding.
Yeah. We will be in touch with you, sir. Definitely. Madam.
Thank you. Thank you all very much.
Is also,
Thank you, sir.
Data science, she will be interacting with you, sir. Thank you, sir.
Oh, yes,
thank you, sir, for such a wonderful lecture. Let us thank our Professor Chandrasekhar, sir. Sir, Lakshman Rao, sir, anything you want to say? Yes, sir, please. Sir, unmute your mic. Sir, please unmute your mic. Lakshman Rao, sir.
He has to unmute.
No, he is not speaking anything.
I want to tell Professor Chandrasekhar that we are available. We are statisticians, bare statisticians. We would like to have a marriage with the finance people.
Sure.
Oh, yes, we are available to you anytime. I am a Kannadiga from Chennai. I am able to provide you anything that your institute wants voluntarily without any expectation, without any financial expectations.
Thank you very much. And definitely it should happen. Because nowadays all research are interdiscipline. That is the trend. So both your data science, statistician, another person, only that we will be able to take it forward. And this patent I have already filed for this one.
Yeah, this is the purpose of this conference. We are bridging together. Interdisciplines are getting bridged.
Thank you, sir.
Can I
Yes,
talk
ma'am.
to Professor Subramaniam for a minute?
Yes,
Professor
ma'am.
Subramaniam, this is Kanchan Jain from Punjab University, Chandigarh. Hello.
Yes, ma'am. Please continue.
Professor Subramaniam, actually.
Sir, Professor Chandrasekhar, sir. Sir.
Sir, I am Kanchan Jain from Punjab University, Chandigarh. Hello. I think he's not able.
Ma'am, you are.
Yes. Speak, madam. Speak. You can speak now.
Professor
So
Chandrasekhar.
please speak loud, ma'am.
Professor Chandrasekhar.
Yes.
Sir, I will like to get in touch with you.
Sure.
Regarding some research problem.
Definitely. there are n number of research problems. Don't worry.
Sir, I will surely get in touch.
Thank you for your offer, sir. Thank you.
I will take your email from Professor Rao.
Yeah, definitely.
Thank you.
Thanks a lot. So now our next speaker is Dr. M. Ramakrishnan. Let me introduce him. Dr. M. Ramakrishnan is from Department of Mathematics, RKM Vivekanand College, Chennai. Here is his mail. Now his area of specialization is survival analysis. He has completed his research under the guidance of Dr. R. Ravanan, Joint Directorate of Collegiate Education, Chennai. He has attended 90 workshops, more than 90 workshops all over India in SPSS and R software, particularly delivered lectures in many FTP R workshop in VIT, University of Madras, Manomaniyam University, Periyar University, Colleges Research Institute, Anna Institute of Management, DIET, NIFT, NITTR, etc. He has published 12 research papers in both national and international journals. He has presented more than 25 research papers in national and international conferences. He has guided 7 MPhil students, currently guiding 3 research scholars and 1 MPhil student under his supervision. He is holding the position of executive member in Tamil Nadu Statistical Association and life member in ISPS. So today his talk is on, now invite Dr. M. Ramakrishnan to talk on, to deliver a talk on multivariate statistical analysis using the R packages. Sir, please continue.
Thank you, madam. Good evening to all. So I am really very happy to share my knowledge in this forum because I am working as a mathematics professor in the Department of Mathematics. I joined as a research scholar under the guidance of Professor Ravanan. Now my topic is multivariate analysis using R. Both terms are new to me because in the pandemic period, I searched the papers and I developed the knowledge regarding the multivariate analysis and another thing also R. This is exclusively different from my academic and also research work because my research fully depends upon the survival analysis. Everything is done because of my supervisor, Professor R. Ravanan. He shared all information, all experience. He transformed all the things to me. That's why I am sitting before you as a speaker of multivariate analysis using R. So in this forum, I wish to thank Professor Rajendra Reddy. He has invited me to deliver a lecture in Sri Venkateswara University in the March 8th. This is also one of the program he conducted as a series of lectures of CLR Rao lectures. So I'm really very happy. I am also one of the part of that one. So another thing, Professor Tirupati Rao has given me many opportunities to share and develop my knowledge. So, and also I am seeing his attitude, tireless effort brings out my people like me to study more and involve with him year after also. So I really thanks to Professor Rao in this forum. So my title of the speak is multivariate analysis using R. You know, everyone know in the data must contain variables. If the variable, hello?
Have you shared them, our presentation?
Okay, I'm sharing.
Oh, make it. Right.
Is it clear? Is it visible to you? Hello?
No. Right, not now.
It's not visible, you know. Now it's okay?
Still not yet. It's coming. Came.
Okay. Thank you. Thanks for. So every data contains many variables. So multivariate analysis is a set of statistical technique used for analysis of data that contains more than one variable. We know the famous statistical technique is a multiple linear regression model. So if the variable contains many variables, we can go for some techniques involved in multivariate analysis. So I wish to explain all the multivariate techniques within the 25 minutes with the help of the R. Because the most researchers are doing their work with the help of SPSS. Now the R is very free and open source. Every day we are getting the more packages from R user. So that R packages, if anybody use it, easily they can gain more knowledge in the field also, and also they can help to others also. So here I have given some variables: income, expense, number of family members. It is one type of data, contains 3 variables. Another data contains cholesterol, blood pressure, BMI, and eating habit. If eating habit may affect the cholesterol or blood pressure or BMI. If you take it eating habit as my response variable or dependent variable, so cholesterol, blood pressure, and BMI may be our predictors. Similarly, I have given another socioeconomic data example. So when handling data, we must care about the types of data. Nominal, ordinal, interval, and ratio. Nominal and ordinal are non-metric values. Interval and ratio are the metric values. So the first 2 things is a categorical value. The next 2 things can be called as a scale values. In multivariate techniques, we have 2 methods are there. One is dependence method. Another one is a independence method. In the dependent method, we have many variables are there. Then we can go for structural equation modeling. I will tell one by one later with the help of the R program also. If I assume our several dependent variables are in single relationship, then we have to take what type of the variables in dependent variables. That's several variables. If the several variables are metric, then let us go for our independent variable. If your independent variable also metric or non-metric, then you can go for canonical correlation analysis. So in the whole study depends upon the canonical correlation analysis. I will explain how it is in the program, because the canonical correlation analysis, correlation is the relationship between the 2 set of variables. So one set may contain metric variable or non-metric variable, another set may contain metric variable or non-metric variable. We have to connect the 2 things with the correlations only. So we have a nice mathematical explanation is there. After you, if you one set of the variable can be denoted as x1 is called as a linear combination of the one set of variable. Another set of variable y1 is called as a linear combination of the another set of variable. Now you can find the value of x1, correlation between x1 and y1 with the help of the correlations among independent variables, correlation among dependent variables, and correlation among both independent and dependent variable. The whole multivariate techniques depends upon the eigenvalues. Here also we can find the regression coefficient with the use of the eigenvalues. My aim is to focus everything with the help of the R. That's why I skipped something. Next one is called as a, if your dependent variable is metric and another thing is called a non-metric. We know one-way ANOVA, two-way ANOVA. One-way ANOVA is one type is metric, another thing is dependent variable is a non-metric. So here also, here we are having the one variable is dependent variable metric and two non-metric variable. Then you can go for two-way ANOVA. Then if you are having the one compounding variable, then you can go for ANCOVA. If it's a more than two confounding variable, then you can say it as a MANCOVA. So what is the meaning of MANOVA? If you have several dependent variables or in metric, then you can say it as a MANOVA. We can see everything. So another thing is called as a canonical, the same thing I told it about the two set of variables. Here, if you have only one dependent variable, then you know very familiar thing is called as a multiple regression. One dependent variable is a metric. It must satisfy the conditions, normality, linearity, and everything is there. So another thing is called as a conjoint analysis. Conjoint analysis is an excellent thing used in the business people, how they are measure the levels in a structure of the phone itself. If they want to mobile phone, they have some memory capacities there, some prices are there. How they are measure memory capacity and prices in the business things, we can see it everything with the help of the R in conjoint analysis. So next thing is called as a non-metric. That is one dependent variable with non-metric. So if the dependent variable, that dependent variable is a non-metric, it has only two classification, then you can go for a logistic regression. That is a logistic odd is there. Then another, if it has a more than two classification, then you can go for multiple discriminant analysis. So next thing is called as a independence method. It has a only independent variable. Therefore, dependent variables, that variable must be depends on another variables. Here we have a only independent variable, then we can go for factor analysis. Factor analysis and also component analysis, exploratory factor analysis, and also confirmatory factor analysis. If you are having the cases, that is respondents, then we can go for cluster analysis. So many methods are there in cluster analysis. If you see the objects, what's the meaning of objects? Then you have four different types of TV or TV brands are there. How the people are visualize the that brands, how they are needed the close to two brands. That can be done with the help of the multi-dimensional scaling technique with the help of the nice graphical representation. Similarly, another one is called as a correspondence analysis. The correspondence analysis is the way it contains a non-metric. Non-metric means in the cross tabs we have two non-metric variables there that we can fix it. The only chi-square test allows us to bring out there is any association between the two variable or not. But how they are associated, what are the two levels are associated each other, that cannot be done by the chi-square test, but test of independence test. But correspondence analysis gives how the two levels in each category related to each other with the help of the nice row profile and column profile. The mathematical background is there. But within the 25 minutes, I have to complete it with all the things. That's why I am just explaining the concept, that's all. So these are the excellent mathematical representation. I explained this one. First thing is canonical correlation. From the canonical correlation only, we can decrease one by one. So these are the 10 methods are there. To explain everything, I have taken one data from this book. That is called a job data. This is data contains 4 nominal variable, non-metric variables, categorical variable, the 20 ordinal variable. Each variable as a factor. We have 4 variables contained in the one dimension. I have put it into new variable, that is EP variable. Another 4 variables, I put it into another dimension, that variable as AC. I created everything with the help of the R. Similarly, OC, when you are adding OC1, OC2, OC3 and OC4, you are having the new variable. That variable are as metric variable. Similarly, job satisfaction, JS, and also I created SI. All the things, all the 5 dimension you are adding, that is called as a total variable. I have created everything. Another categorical variable I have created the level variables. with the help of the quartiles, I divided the total variable into 3 categories. So with the help of this data, I'm going to explain everything with the help of R. We have collected the data 400 from the 400 respondents. So now I move to the R program. So this is the data I bring it to, and whatever I told when run this command, I got these things, a level. Now let us see the excellent multiple regression. We have only linear model. LM, the function is enough. LM. We will get stored into one object. Then summary, you will find out the unstandardized coefficients and also which parameters are highly significant or not. Here JS is not significant. The R, capital R, is the meaning of the correlation between the predictor and the observed variable. So this is the multiple R square value. The multiple R square value, I got it the same value, 0.33. Now, regression coefficients can be easily find out with the help of the 4 different chances. One is, I already told you, this is with the help of the correlation matrices of dependent variable and independent variable. This is one part. When using the unstandardized coefficients, this is the things I took. This is another model. I'm getting everything with the help of the package, quant psych package. We will get all the 4 standardized variable. Next, you standardize your data frame, then you put it the same LM model, you will get it everything. So these are the 4 things are available in my study I completed. So next things I will go for logistic regression. Logistic regression is my dependent variable contains the two categories. He admitted or not admitted. In the same data, I wish to make it as my presentation whole. That's why I divided the EP variable into 2 categories according to median. Then and I used that GLM function. GLM function. Now I run this command. Here I am having the logistic coefficient parameters. Here this is the meaning of the exponential. That is a log odd parameters. Now, if the variable having a negative value, then this is a decreases odd. If the variable has a positive value, this is increases odd. Now, how 40% of the increases the odd. What is the odd here? This is my dependent variable is JBC, low level and high level. So I2 low increases the 40%. That things okay. Similarly, I have divided into another variable. When you are adding the another here, we have what the significant variable, only SI is the significant variable. That's why I introduced some continuous variables more. I got it here, some variables SI and OC, SI and also OC is also significant variable, even though age is not a significant variable. Next, I moved to discriminant analysis. So this discriminant analysis can be used with the help of the mass package. So excellent thing in R is a mass package, I told you. Okay. So here the function is called as a linear LDA, linear discriminant analysis. So my job has 2 categories. Here the discriminant analysis can be done for dependent variable having 2 or more than 2 categories also. First I took 2 categories, proportional and non-proportional. Here when I explain this is the objectives, I go some fast. Now this is the how the values are predicted, probability value. Now this is how you got it, the original value. This is the predicted value. Okay, this is the posterior probability. From the posterior probability, if the p value, the probability value is less than 0.5, then you can put it into 0, 0. It is greater than 0.5, then put it into 1. So the things are, I did it and compared it. This is the nice graphical representation. Now this is the confusion matrix. How my values are predicted. Here in this case, your 57% of the values are correctly predicted in discriminant analysis. In the by using the discriminant analysis, my data contains 57 analysis. When you are introducing the increasing the independent variable more, you will get the prediction also more. That things also I have given the example. Here this is the another things. Now you do the increases the independent variables. Okay, so here it increases 59. So this is the another data is the data is the taken from the SPSS data from the so
Sorry for interruption.
Please, yeah.
So those who have discomfort in visualizing the full screen, they are suggested to select the option pin to screen, so that it will show up the total screen. You will be having the comfort in visualizing. Right.
Oh, it's okay now.
Carry on, sir.
Okay, now I selected the data. This is the function read.sps because I wish to introduce another concept in this forum. That's why I introduced that one. Okay, this is the data is taken. This is the job as a categorical data. That is a non-metric data. I wish to say how the things are classified in this data. So these are the things are there. So box M is the function for multinormal testing. Now you see here, this is the correlation between the variables. So my aim is to see the diagram because this so it's not necessary. Okay, you see this things, how much 59% are there in this case, or in this case some values are there. So because I have to skip one by one, time is not permitted. There is some problem is there also. So now this is you can easily check your data. You put your data because we have three independent variables. You put it and find it where your data lies in this which case. It comes in the first class, the second category or third category. That can be done with the help of this linear. If it is clearly done, it will be automatically work. Otherwise, you see here, these are the things are happening. Yeah, this is. So I come to next one. This is a excellent thing is canonical correlation. I explained to you. This is 2 packages are there, 4 packages. Canonical correlation. Here I have divided EP into 2 categories. I converted into numerical values. This is one set of values, 2 metric values. Another set of values has 2 metric value, 1 non-metric values. Because here, okay, EPC 28, 29, 30, 31, 32, 33. So now it will work. Now this is a data frame. Now summary of the variables. Here, this is the relation between these two. This is the nice things. Yeah, leave it. So this is the CC function gives everything. You see here, CC function, to obtain the CC function, yeah. Yeah. CC1, CC2. Yeah, I will explain here. So the CC1 and CC function will gives the correlation between the 2 variables, and also it gives the correlation between the 2 variables x1, y1. You take it as it is a linear combination of the first set of variable. It is a linear combination of the second set of variable. This is the correlation. We have canonical variates are there. Similarly, now this one we have. This is I told. This is the regression. If you put this is capital X1, this is the regression coefficient for this category. This is the regression coefficient for second category. This is X2. This is Y2. This is Y1. This is Y2. Correlation between these two things only this one. Correlation between these two things is only this one. Because here we have only two correlation coefficients. Because minimum number of variables only it will took it. So that second thing is not working. That's why it's coming like this. You see it how you can. I've written this one by one. If I have, it will take time, and also I'm going hurry. Then only if I have some errors are having. But these are the program as written and run correctly. We can find the canonical standardized coefficients also with the help of these functions. Yeah, this is the standardized coefficients. But here it's not working. Yeah, this is the value. Now next I will go for MANOVA, because my aim is I have to explain everything with taking that one set. That's why I took it. Now the excellent thing is this is a five metric variables. This is the mean of the metric variable with compared to the job category. Now MANOVA. What's the meaning of MANOVA? I told you this is. You see here in each category, this is EB has no significant difference among gender, among experience. Only this variable has a significant variable. Now I did it for gender category also, because here we have only one significant variable. Now here we have this is J is also significant and AC is also significant. Now let us go for. The excellent thing is called conjoint analysis. Conjoint analysis, how people are prefer. That is the things we have.
Your interruption. Make it conclude.
Yeah. So with the help of the linear regression, you can complete it. Just you see what are the things are happening. These are the parameters. If it is minus 0.5, another one is called as a 0.5. I took the one data. This has a 4 varieties with a different level, 3, 3, 3, and 2. So 54 levels. But we have okay. Yeah. Okay. So you see here, this is the CA importance. How they are measured the values. I give this one with the help of this. You see it, this you take one SPSS data easily, the setup data, delivery and tools. We have all levels. This is the setup time in minutes, delivery period in days, we get a number of tools can accommodate. Easily you can get the value with the help of linear regression. But in the using the package, so if everything run correctly, we have excellent graph. This is only thing is enough. See, this will at least it will work. Yeah. Okay. So it will works on the excellently. It will gives the how each levels are predicted. I have to check it. Everything is works properly. Now next one is called as a correspondence analysis. I told it. This is the chi-square test table. Age is a one categorical variable, level is another categorical variable. When testing this one, so this is the p-value, reject the independence. There is an association between the two variables. Now my CA function gives everything. So this is the inertia is the meaning of called as an eigenvalue. If the eigenvalue is 1, there is a no association is there. Here eigenvalue is nearer to 0, 86.85% are there. Now similarly, here we have inertia. Inertia is the meaning of how they contribute to the path. We can see it visually. That will help you more. You see here. You see here. So there are so many graphs are there because I don't have time. From the time itself, graph itself, we can understand which variables are they measure. You see here, they measure S3 value. These are the things here. So this is the graph. This is the graph. Everything is here. Two categories are there. One is age category. Another one is low level, moderate level, and level. So in the chi-square test, we can predict only the independence between the two variables. But here you can easily, this is the one axis. This is one axis. This is the another axis. In the one axis, these are in the one side. These are in the another side. So in the another axis, these two are one side, these are the other side. These type of things you can easily predict with the help of the graphs. Everything is here. Now, if I'm going for factor analysis, so this is all the three tests first we have to done. So this is the value, that is the reliability and KMO and Bartlett test. Then I can go for factor analysis. So this is the how in this 20 variables 1, 2, 3, 4, 5. You suggest 5 factors are, you can suggest 5 factors in the both parallel analysis and also the PC method. The difference between the principal component analysis and the exploratory factor analysis, the component analysis does not relate with other dimensions, but we can allow correlation between the factors in the EFA. Here, this is the meaning of, if you take the 5 factors, you can get 70% of information. We can lose 29% of information others. So these things, excellent diagrams and things will happen. I will complete that. Okay. So this is the 5 factors. You are getting the values. Graphical. Nowadays, factor extra and ggplot is the excellent packages are there. Many authors are given. Nice textbooks are there. This is the two factor and the EFA. Both things are there here. Here, Varimax is applied. I told you, no. Varimax means orthogonal rotation is applied here. So here there is a correlation between these two. This is EFA. So there is no correlation between components. It is called as a component. Next, I move for. This is the excellent thing in the AMAS only. We are doing the everything structural equation modeling, and R. It is a very easy code. You have to write it, and you find the reliability in the AMAS. There is no chance for finding the reliability. You have to go for SPSS. Then you have to put it in everything in Excel. Then you have to do it. But the only function reliability it gives the that alpha values and also average variance, etc. This is for discriminant analysis. How my values are discriminant or my variables are discriminant or not. This is the fit measure. All the things you can put it in Lavon plot. This is the Lavon plot, nice Lavon plot. In AMAS, you have to do everything, but here easily we can done it with the help of the things. So I told you the discriminant analysis, we have to find with the intercorrelation. Everything is done with the help of the R. So these are the two things I given. Structural equation model, we have path analysis and also measurement model and also then structural equation model. This is the, I have related these two things. This is called structural equation model. So everything has come. This one, you see it, 5 factors are connected. The one has regression coefficient. This is called regression coefficient. If the 5 factors are connected with regression coefficient, then that is called as a structural model. The parametric estimates are there. This is another diagram. Cluster analysis. There are so many methods completed. So I taken 6 type of methods is there, but I explained this. Okay, I will finish it, sir.
Yeah, there are some more speakers and we are running behind.
Okay, it's enough. Okay.
Yes. I have a question.
Yes.
I have a small question.
Yes.
When the intercept is negative, how do you interpret it? Number one. Now, when you are taking multiple variables, what should be the sample size? You know, for every variable that you are including, there are various opinions. At least the sample size should be minimum 15. And what is the sample size that you have taken for the multiple variables that you have considered? P-value that you have, that I saw here indicates that variables have multicollinearity in the whole system. Therefore, the robustness of your estimate is only 65%, which is 1 sigma level. So we are looking at 3 sigma at least minimum for any estimates. What is your comment for this?
Yeah. So in the research papers and every textbook gives minimum 5 samples for one variable. 5 or 10, 5 up to 10. Okay. So here we have collected 20 variables, but for the 20 variable collected 400 individuals. Okay. So in my data, 400 individuals, that's okay. Then another thing is, you are asking about the percentages, you know. Percentages of things. In the reliability, we have some fixed codes is there, 0.7 level greater than 0.7. That can be used for making our data is correct or not. Because why I am making something is wrong means, because my aim is I have to tell everything with taking the one data, job data. So when doing that one, easily the participants may achieve getting the knowledge from the data only. That type of maybe some checking normality may not be problem is maybe there. For checking the normality, you can use the big jump test also. After, if you taken the data, if you put it the perfect things, you can go it slowly and make it as a perfect. Yeah, so many things are there.
Participants are requested to clarify their doubts on a one-to-one basis later, because we are running behind the schedule. Please, please wind up.
I have one question. Question.
Yeah.
Shall I ask?
Yes, ma'am. Yes.
Apart from this, your discriminant analysis and other things, we have to move a little further. We have more sophisticated classification techniques like support vector machines. So why did you not use SVM? Then we have decision trees. So I think we should go more beyond this and then use some of those things also into the analysis. They provide a better analysis compared to your model. So I suggest that you try support vector machine and decision trees also for your classification. They are supposed to be better than these methods, and it can handle your extreme values, missing values. They can take care very nicely.
Yes, it is correct. But
thank you, sir.
All the techniques, all the 10 statistical techniques within this forum. That's why. Okay.
Sir, forget R. There are so many zero programming tools available. Take that 9 or head 2. Without writing a single line of code, you will do it in 5 minutes.
Yeah. You are correct, sir.
You are correct.
But Ramakrishnan's effort is that to give some information how to make use of open source software R. Okay, so it's being a program language, it is having more flexibilities, and he is trying to exhaust all the multivariate analysis techniques. Mostly infinite. Okay, you are trying to exhaust the infinite sense, it's highly impossible because each tool has its own course.
Yes.
Okay, you can consider as one course of content is there to explain one tool. So anyway, you are trying to make maximum out of it. So really wonderful phenomena that multivariate analysis has a larger scope, as Professor Chandrasekhar Subramaniam said. Nowadays, every day, data science is modifying, and it is more friendly to data users now. So we are having that scope, sir. Thank you, Professor Ramakrishna ji. Madam.
Thank you.
Madam Suresh Kunde, please.
Thank you, sir. Let us thank Dr. Ramakrishnan. Our next speaker is Professor Kaushalendra Kumar Singh from BHU. Let me introduce him.
I want to make a request. Can you swap me for an earlier session, because I have to go for doctor at that time where you are fixed. If it is possible, can I swap with somebody else? So that one earlier session would be better for me. If it can accommodate, I will appreciate. Otherwise, there is no problem.
Okay, we'll see.
If you can accommodate me by swapping the session with somebody else, you please consider.
Let this session start.
So let me introduce our next speaker, Professor Kaushalendra Kumar Singh from BHU.
Welcome, sir. Singh sir. Welcome. Thank you for your sparing time. So really great. We are two people from your university, BHU. One is Professor Mishra.
Mishra.
Mathematics department.
Oh.
Yes, he has given his session in the first part. Madam?
So, yes, sir. So, Professor Kaushalendra Kumar Singh is from Banaras Hindu University, Varanasi. His title of PhD thesis is Some Analytical Models for Couple Fertility and Their Applications. Sir is having the research experience of 39 years, teaching experience about 39 years since 1981, experience of supervising about 35 years. 16 students have already completed their PhD degree while 6 are working. He has guided more than 200 students of MA, MSc final year who wrote their dissertation on different topics relating to population studies. He has guided more than 300 students in BA, BSc final examination who wrote their dissertation on different topics related to population studies. His specialization areas are population studies, technical demography. He has research publications, 4 edited books, 149 published articles, and accepted for publication are 3, excluded more than 5 dozen published abstracts, number of seminars, international 80, conferences attended and national 100, presented paper total 220, countries visited USA, UK, Canada, Indonesia, Thailand, and he has given so many seminars in these international and national conferences. And Professor Kaushalendra has completed research projects from these funding agencies: WHO, NIH, Rockefeller Foundation, UGC, BHU, ICFR. And now I invite Professor to deliver the talk on the estimation of fertility measures, visualizing the future courses through stochastic models. Sir, please continue.
Thank you, madam.
Thank you, sir.
Yeah. Whether you can see that?
Yes, sir. Now it is coming.
Okay. Good. So this is the work of one of my student. Her name was Anjali Pandey. She is working right now in AIMS. So I'm going to start. This was the introduction and then methodology and discussion and conclusion. I'm going to start now. You may be knowing that there are 3 factors: mortality, fertility, and migration in population studies, which is usually estimated or studied, in which the fertility, I am focusing on fertility because you know that mortality you can handle it very easily, making different infrastructure. But if you are going to approach to fertility, the effect is going to, you can see the effect after many years, means that after 20 years you see the effect of that. So it is very important factor. So that's why we are analyzing fertility by different indirect methods. So Usually the fertility rate are age-specific fertility rate, total fertility rate, mean age at childbearing, as well as net reproduction rate. These are by that we are going to give you the estimate. And we are going to use different models. I am going to use the easiest model so you can understand it easily, but we have done a lot of more things on that. I will explain what you can do and what we have done further to that. So this is the model given by Singh and Bhattacharya in 1970 and Singh 1978. So in this model, various assumptions are there. So we are going to give you some models. By models, you can estimate the net reproduction rate by a limited indirect source of data. So if we are going to, if we have number of births in between the time 0 to t, and we know the number of conceptions. Actually, we know the number of births we put 9 months back, and then we go for conceptions. Let xt denote the number of conception to a female during a time interval 0 to t of length t since marriage. So in between 0 to t, you have many conceptions. One conception or one birth, two birth, three births. Similarly, you have many births or many conceptions. So let the successive conception to a woman occur at times Z1, Z2, and there are n conceptions, Zn plus 1. And Yn, the interval between two conceptions, Yn is defined at Zn plus 1 minus Zn is the time interval between nth and n plus 1th conception. One conception is part, there is a two part there. One is the rest period and one is the time of resumption of fecundable state. When a female gives birth, there is a postpartum amenorrhea period, and after that there is pregnancy. We say that it is a rest period, and after that they go for resumption of next state. So here lambda I is taken as a conception rate for I plus 1th conception. Theta is the probability of complete conception, that is a conception results in a live birth, and H1 and H2 are the rest period associated with incomplete and complete conception respectively. H1 is when you have an incomplete conception, and H2 when you have an complete conception. And alpha n is the probability that women under consideration will not acquire sterility up to a occurrence of nth conception. So here we have assumed, here is the density function, we have the expression. So here we have assumed that lambda I is constant over all the conceptions, but we can change is lambda can change from first conception to second conception to third conception. So the second expression is for that only. So in this we have some different assumption that the female has led a married life throughout the period observation, means that her marriage was intact between the period 0 to t. The probability of occurrence of first conception in time interval t to t plus delta t is delta 0 delta t and 0 delta t, where delta 0 is the conception rate at the beginning, and let theta be the probability of complete conception, that is a conception results in a live birth, such as 1 minus theta is the probability of incomplete conception. Every conception is followed by a period of temporary sterility called rest period, which includes duration of pregnancy and associated postpartum amenorrhea period, what we have explained earlier. These are the assumptions, and then we have the probability of exactly n conception during the time 0 to t, which is called as PNT. So by that we can estimate here, we can estimate also lambda by different maximum likelihood estimate as well as the moment estimate. But here I am giving example by taking lambda 0 is equal to 65.5 years, means that 4 months where the incomplete conception is there, 4 months of gestation period, and 2 months of postpartum period. And H2 where 9 months of the conception is complete, then 9 months of gestation and 6 months of postpartum period. And theta is taken to be 0.85, means the probability of conception converting into a live birth is 0.85. The alpha 1 values will be determined by fertility regulating and stopping behavior of the couple. There may exist several such stopping rules which define the fertility regulating behavior of couples, but we define only 6 hypothetical. Here, since the time is short, I don't want to go through that. So 6 hypothetical cases we have. So plan A. You can take as many as, you can take the from the NFHS 4, the present scenario, you can take whatever your state is going on, but I am giving you 6 hypothetical plans. First plan is that 15% of the fecund couple becomes sterile following the first birth, means that I am assuming that before first birth, nobody is going to be sterile. So 15% of the fecund couple becomes sterile following first birth. 50% of the remaining fecund couple becomes sterile following second birth, and then 65, what is the rest is there, 65% of the remaining fecund couple becomes sterile at each conception following third conception, and 92% of remaining fecund couples become sterile at each conception following sixth birth. Means that after first birth, 15% are going to sterile, 50% after second birth and third birth, and from sixth birth 65%, it is from third birth, fourth birth and fifth birth, and from 6%, 92% of remaining females become sterile at each conception. So here lambda is taken to be constant, which is 0.65, and this data is from the NFHS 3. Whatever values are lambda is there, we have taken that. But you can estimate also lambda. If you have a distribution of number of births between time period 0 to t, from the same model you can estimate also the value of lambda. Alpha 0 is equal to 1 means that none of the females are sterile before first birth. 15% of the fecund couple becomes sterile, means that 0.85 is the alpha 1 minus that, and then 50% alpha 2, and then alpha 3, alpha 4, alpha 5, 65%. So means that probability comes out to be 0.35, and similarly alpha I is 92% remaining fecund female becomes sterile. So here there is no sex preference, right? She will continue birth as she wants with no sex preference. And then plan B, all fecund couples use contraceptive of 70% effectiveness following first conception. So lambda 1 is equal to 0.30 into lambda 0, because they are using 70% effectiveness of the contraceptive. Alpha 0 is equal to 1 and alpha 1 is equal to 1. 30% of the remaining fecund couple become sterile following second conception, and remaining 70% couple use contraceptive of 75% effectiveness. So alpha 2 becomes 0.70 into lambda 0. Alpha 2 becomes 0.70, 70% effectiveness, and lambda 2 becomes 0.25, lambda 0, right? So of the rest couple become fecund couple, 50% becomes sterile, and rest 50% use contraceptive of 85% effectiveness following third birth. So similarly, you can define alpha 3 and lambda 3 and so on. So next plan is C and D. C and D is just extension of the plan A. And now you can see there is a stopping rule. That is the plan E. Stop childbearing as soon as one male child is born, or total number of conception is 3. Means that you are going to stop your reproductive process as and when you get one male child. Either the male child is first or second or third. After third, you don't want any more conception, whichever comes early. This implies that lambda I is lambda 0, what is equal to 0.65, alpha 0 is equal to 1, alpha 1 is equal to 438. I will tell you later how the values comes out to be 438, and alpha 2 is 1 minus 438, that is 0.562. And then the plan F is that you want one male and one female. One male and one female, and you don't want more than 3. So whenever it comes, it comes. So now, anticipating the widely accepted sex ratio at birth is 106 males per 100 female. This is accepted in India. The conditional probability of a male birth is P is 0.515. The conditional probability and female is Q is 1 minus P, 0.485. And we have already assumed that the probability that a conception is incomplete is 1 minus theta is 0.15. Let us define the events. L, a conception remains incomplete, means it converted into fetal. M, a conception is complete and it result in a male birth. And then a conception is complete, and F, a complete conception is complete and result in a female birth. Therefore, PL. PL means that a conception remains incomplete. That is 1 minus theta, and that is 0.15. PM. PM is equal to a conception is complete and the result in a male birth. Male birth means that we have the probability of birth, male birth, 0.515. We multiplied that by 0.85, and then we find the value 0.438. Similarly, PF, the value is, you know, that 0.485. We multiply it 0.85, and the value comes out to be 0.412. So all probability 1 minus theta, PC and QC, the total probability is going to be 1. So these are the plans, and to specify the plan E and F, the women abide by plan E. These women will stop conceiving further as soon as one male childbirth take place, and with the maximum number 2. Here, when you see in the plan F, how you define alpha 1 and alpha 2. Alpha 2 is the value when a person is going to stop, when he has first male and second female, and then first female and second. So when you are going to multiply by PC into PM into PF plus PF into PM, and then you get 1 minus that is the probability 0.638. So how you define? So you can make your own assumptions. You can make your own assumptions and plans. We have taken the plan 1, which is NFHS 3, how the NFHS 3 is working, but you can make your own plans, or whatever in your area is going on. Since we don't want to complex, because the viewers are not, you see, of our field, so we don't want to make more complexity. In the models, we have already considered the adolescent sterility also. We have already considered the primary sterility in the model, as well as we have taken the parity dependent models. We have already done that, but due to simplicity, I want to let you know how the model is going to work, how you can predict the values from these models. So you have 6 plants A, B, C, D, E, and F. Here we have taken, already told you that we have taken lambda is equal to 0.65. But if you have the data of number of births between the time 0 to t, you can easily estimate the value of lambda, as well as the other parameters which I have explained you. So now the calculations are there. In time is little fast is going anyway. So we have calculated the value average number of conceptions in interval 0 to t using PNT from the NFHS2 data, and then we multiply it by average number of conception theta, and that is our table 2, which is going to be used. So I want to let's see you what is the table 1 and 2. This is table 1 with t is equal to 1, 2, 3, the number of years, and for different plants the values are calculated, as well as this is also there by multiplying by theta, the values are there. So similarly, we can find out the age duration specific fertility rate from the table 1 as well as in table 2, and which I have already given in table 3. And by the first, for this, what we have to do by these tables, we are going to calculate the age specific fertility rate, the total fertility rate, the gross reproduction rate, as well as the mean age at childbirth. Right? So we have used the SRS data from the average life table to find out the mean childbirth rate in that particular time, the total fertility rate, and then find out the gross reproduction rate and net reproduction rate to show you, to give you, and to have an idea about the total fertility rate as well as the gross reproduction rate. So what this presentation is going to show you, there we are going to illustrate that how stochastic modeling enables us to visualize the future course of fertility using minimum empirical observation. We have taken the empirical observation lambda is equal to 0.65. Rest of things are coming from the SRS data as well as from the NFHS data. So by that, we are going to calculate age-specific fertility rate, total fertility rate, gross reproduction rate, and net reproduction rate, what we usually do in predicting the population in our country. Instead of assuming the value of conception rate lambda, conception effectiveness, and rest period H1, one can also estimate these values if distribution of the number of births in the past 15 years is available. I have already told that I have taken the values of lambda. Already we have taken a distribution of rest period also, H1 and H2. We say that when H1 there is a incomplete conception, in that period average incomplete conception comes out to be 0.5 years, and when you have incomplete conception, in that case the postpartum amenorrhea comes very fast, so we have taken 2 months. But you can take, you see, distribution for that also, and many of our students have already taken the distribution of H1 and H2 and estimated the values of H1 and H2 as well as lambda in the giving in the model. Also they have, you know that when you are going to take 0 to T, if the females means that 0 means the marriage to a time interval T, if you are going to take 15 years of data, many females are in the adolescent sterile period. So taking mu as a factor, we have estimated the mu and the effect of adolescent sterility in that particular case. Or you know that we have taken a very hard assumption here that all the females will definitely give birth. Means that before giving first child, he or she is not going to be sterile. But we know that the primary sterility comes out to be about 5% in the society. So next of my student, she is working and she has estimated the primary sterility and estimated and then predicted these plants. So I want to just show you a figure which give you the all four plants are there, plan A, B, C, D. The graph will, I think you can see the graph or you have to do something. Anyone?
Yes, sir, it is visible.
Okay. And then the main thing, plan A, B, C, D, E, and F. This is the main table. From you will see that if you are going with plan 1, means that plan 1 says that 15% of the fecund couple becomes sterile after first birth. Means that all the females are fecund. If you take here that of 5% are of the females are not fecund, in that situation you can have with the plan A, you are going to control the fertility. Plan B is different, and plan C and D where you have less restrictions, means that, and when you are going to stop the children after one male child, when you are going to stop the child having your children after one male child, in that particular position your NRR is 0.687, means that your population is going to be decreased. And if you have in your mind that if you are going only up to third birth and you are going to stop the children after getting one male birth. So if there is a stopping rule, and if you have in your mind that you are going to stop, you are not going more than 3, in that case also you have negative growth rate. Similarly, if you see, if you want one male and one female, and if you have in your mind that you are not going beyond 3, in that case also you can see that the TFR is going to be 0.243. It is almost a replacement level. That if a person is going maximum, all the person are going maximum with 3, and if they are satisfied with one male and one female child, in that case also the population is going to be not going to be increased much. This means that minimum they have 2 child, means one male and one female, then they are going to stop. If the person is going to stop at 3, minimum if they have 2, means that one male and one female, even though the population is not going. If you see the NRR, it is 1.076, and if you consider in this the primary sterility, the NRR is going to be, we have seen that NRR is going almost equal to 1. If the population thinks that they want to have one male and one female, even they want for a goal that the total birth is going to be 3, even then there you can see that NRR is going to be 1, that the population is going, the growth rate is going to be almost 1. So after some years, the population is going to be stabilized. So
sorry for interruption, sir. Please conclude.
Yes, I have already done that.
Yes, make it.
So thank you very much. I think I am on time.
Yeah.
Thank you, sir, for a wonderful lecture. If any questions?
Is it applicable to both rural and urban population? Was it a random sample or was it a stratified random sample? Do all religions taken into consideration? Some religions do not bother about the number 3. Did you come across such experiences in your studies? Please enlighten.
You see, this is plan. Na? This is hypothetical plan. Whatever plan you rural, urban, whatever you want, you can take that, right? So these are the hypothetical plans. Whatever urban, rural, NFHS data is all urban, rural, all age group is there. So I have considered also the NFHS 3 as well as NFHS 4 data, and these are all hypothetical plans, right? If you have the plan, just like you don't want that it would go stop up to 5, it will give you the TFR as well as NFR. I am making that assumption that if it is going to stop at 3, if it is not going to stop at 3, if it is going to stop at 5, you have a different NRR in that particular case. Definitely you have a growth rate. What is the growth rate? You can estimate from there.
Okay, thank you, sir. Thank you very much. Madam, conclude, madam.
Yes, sir. Thank you, sir. So let us thank the speaker, Professor Kaushal Sheikh. And now let us invite our next speaker. Next speaker is Professor Kanchan Jain. And it is an honor for me to introduce our next speaker, as Madam is my PhD guide also. So let me introduce her. Professor Kanchan K. Jain has done her education from Punjab University, MSc in Statistics, MPhil in Statistics, PhD in Statistics. Her expertise in statistics and probability, reliability, survival analysis, measurement, error models, actuarial statistics, biostatistics, income inequality. Professor has worked for nearly around 38.5 years of teaching and research at Department of Statistics, Punjab University, Chandigarh. She has done 57 research papers. 4 are communicated, 6 are to be submitted shortly. She is the Fellow of Royal Statistical Society, London. She is the elected member in International Statistical Institute, Netherlands, the National Academy of Sciences, India. Professor is a life member in Calcutta Statistical Association, International Indian Statistical Association, ISPS, IAPQR, Calcutta. She is the member of International Society for Business and Industrial Statistics, Institute of Actuaries of India, Mumbai, Association of Women in Science, USA, Organization of Women in Science for the Developing World. She has participated in so many conferences outside India, total 5. Out of that, 3 in USA, 1 in Portugal, 1 in France. Within India, more than 50. She has reviewed the different papers in very reputed journals like Mathematical Reviews of American Mathematical Society, Computational Statistics and Data Analysis, Statistical Methodology, Journal of Multivariate Analysis, Insurance, Mathematics and Economics, Statistics and Probability Letters, Communications in Statistics Theory and Methods, Communication in Statistics, Simulation and Computation, Statistical Papers, Hacetep Journal of Mathematics and Statistics. So now I would like to invite Professor Kanchan Jain to deliver the talk on log generalized inverse, generalized Weber distribution, and regression model. Ma'am, please continue.
Thank you, Dr. Sudesh.
Thank you, ma'am.
This seems to be my old biodata. I have already completed 40 years now.
Yes, ma'am.
And there are additions, but it's okay. Because I think it's my fault that I didn't update it. Okay. So, good evening, everybody. And my special thanks to Professor Rao for inviting me to deliver this talk. Actually, during this pandemic, we have been seeing each other online only. And I think it has been quite frequent. So that's a good thing. Let me present my talk. Can you see my
Yes, ma'am.
presentation?
Right. It is visible, ma'am.
Okay, thank you. So, as Dr. Sudesh read out the title, I have to talk on a distribution which is log generalized inverse generalized Weibull. It is a long name, and the corresponding regression model. Actually, this is a work with my student, Dr. Neetu Singla. And outline of my talk is what is a log generalized inverse generalized Weibull distribution, LGIGW abbreviated. Then introduction of the corresponding regression model, the parameters, MLEs, and some sensitivity and residual techniques. Then there is a real data set illustration, and we select the appropriate model, or we just show that our model is superior to some available models. Now, in literature, the available regression models are, there are many actually. I've included few which are starting from 2008. So they were introduced by different authors like Silva et al., Carrasco et al., Ortega, Hashimoto, Ku and Z, and Pascoa and all. See, this GIGW distribution was introduced by me and my student in 2014. And this GIGW distribution has the corresponding probability density function given by this f of x. And from this only, we go to log generalized inverse generalized Weibull distribution. Now, when x follows GIGW, log x will follow log GIGW distribution. And from fx, we can derive the distribution, the probability density function of capital Y. And sorry, this has this form given by G of Y. So second, this number 2 is the simplified expression for this GY. Just to write it in a simpler form, we write sigma as 1 over beta and mu as log of lambda, and rewrite GY in this form, where this alpha, gamma, and sigma, they are all greater than 0. The corresponding survival function can be written in this form, and that this is the last step, is the simplified form of the survival function, which is 1 minus this. So all this gets simplified to the last expression. If I wish to write the PDF of the standardized random variable Z, now Z we take to be Y minus mu upon sigma, and the PDF of this standardized random variable has this simplified form. There were steps for finding this, but I'm just showing the last expressions. And kth order moment of Z is given by this expression. Not a very neat expression, very nice, but if we want first 4 moments, it will not be too difficult. For alpha equal to 1, LGI-GW distribution leads to LGIW, log generalized inverse Weibull. And if I take 2 parameters to be 1, then my density function has this form. And this is the PDF of inverse extreme value distribution, or this is also called LIW, log inverse Weibull distribution. So our distribution is a generalization of LIW and LGIW distribution. When we plot the density function of LGI-GW distribution for some parametric combinations, so this distribution is slightly positively skewed. Positively skewed distributions, actuarial science or in finance also, so in insurance, they have applications in those areas. Now then we come to LGI-GW regression model under censoring. When we consider the covariates which affect lifetimes, we have age, weight, smoking status, and diabetes level. And if there are n individuals under study, let Ti be the lifetime and Ci be the censoring time for the ith individual. Because we are considering n individuals, so I will be from 1 to n. And the lifetimes and censoring times are assumed to be independent. The response variable that we will consider in this model is taken to be the minimum of log of Ti and log of Ci, because our model was taking log of a variable, log of x. So here also we consider now logs of the lifetimes and logs of the censoring times. And here in this model, assumption is that each response variable depends upon p covariates. So a regression model, this is a linear model actually for response variable yi, has this form. Zi's here are the random errors, which have the PDF given by 3. This was the PDF that I wrote as pi of z, and xi's are the covariates, betas are the unknown regression coefficients, and sigma is an unknown scalar parameter. And in matrix notation, we can write this as this. So X is a matrix and others are vectors. So survival function of yi can be estimated as we take estimates of alpha, gamma, sigma, beta. So we will get the estimate of the survival function if I put in the estimates of the these parameters and these estimates of the regression coefficients. Now we take F to be the sets of log lifetimes and capital C is the set of log censoring times. And then I can write down the total log likelihood function like in this form. Here, F I have defined a set of log lifetimes. C is my, again, log censoring times. Gamma, alpha, beta, they are all parameters. And R here is the number of observed failures. This R in the this log likelihood function is my count of observed failures. So MLE of theta can be obtained by maximizing this log likelihood function given by 5, or I showed it above. And you see, it's very difficult to find these MLEs analytically, so we have to use numerical methods. And I have not shown here the likelihood equations because those expressions are very big. Lot of mathematics is involved, so I have just avoided showing those equations. And for interval estimation and testing of hypotheses, we have a 4x4 information matrix, which is given by this. And asymptotic distribution of theta now is the vector of the parameters. So asymptotic distribution of root n into this difference between the estimate and the original one. This will be normal, multivariate normal with the p plus 3 dimensions, whose variance covariance matrix will be inverse of I. Sorry, this should, okay. I theta, where I theta is the expected information matrix and can be replaced by J of theta cap, because here I have used the notation capital J. You see these, this J has now many, it's 4x4. So I have 10 capital J's here, shown 3 elements of this matrix. So J alpha alpha is the second order derivative of L with respect to alpha. J alpha gamma is this partial derivative with respect to alpha and gamma. And this is with respect to alpha and sigma. So these expressions are also quite mathematical. So I have avoided showing all. Now, this asymptotic multivariate normal distribution can help us in constructing the confidence region for the parameters and for testing goodness of it for some submodels. Since outliers in any data set affect the results, so an important thing is to detect those outliers and influential observations using the sensitivity or residual analysis. And for doing this, there are several approaches suggested by Cook and Weisberg, Cook and Chatterjee and Hadi. So different approaches for detecting the outliers are global influence and local influence. For global influence, generalized Cook distance is found by this formula. This theta cap I is the estimate of the parameters obtained by deleting ith observation. Theta cap is the original estimate. It is theta cap I is very far away from theta cap, then ith observation can be considered as an influential observation. And another measure which can highlight the difference between these theta cap I and theta cap is the likelihood distance, which is defined as 2 times L of theta cap. L is my log likelihood, and minus L of theta cap I. So this is my original log likelihood function, and this is the log likelihood function obtained after deleting the ith observation. So at every step, we go on deleting the observations and find the difference. There are other global measures such as Wald test for explanatory variables or censoring effect. Okay, just a minute. Under a case deletion method, so these measures can also be used. Wald test can also be used, but we have not used Wald test. Local influence was also described by Cook And this is another method for sensitivity analysis. In this method, weights are assigned to the observations instead of deleting them. In global, we were deleting the observation, but now we are not deleting, we are assigning some weights and measure the effect. Model is called a perturbed model. So, if theta cap W is the vector of estimates under the perturbed model, displacement is defined in this manner, which we write as LD of W. And this is known as CD theta is known as the normal curvature. Now, normal curvature is again using J matrix. There's another matrix given by this delta, and then we have these conditions. Norm of D should be 1, and delta is a P plus 3 into N matrix. And here this is calculated for theta whole. I can also calculate individual curvatures. So elements of this matrix, they are calculated under different perturbation schemes. When we consider this matrix B, we call this matrix as B matrix, and the largest eigenvalue is taken to be CD max, where D max is the eigenvector corresponding to CD max. Index plots of D max, CDI alpha, CDI gamma, sigma, beta, they together denote the total local influence. So curvature has this form. You have CI, which is 2 times. Now I have delta I here at direction D. Actually, I'll be using them when I show you the application. And for the vector of weights, likelihood, log likelihood is written as L of theta given W. This is the log likelihood under the perturbed scheme, and this delta is calculated by using this second order derivative of the log likelihood with respect to theta j's and wi's. Now weights have been included, and these are calculated under different perturbed schemes. There are many perturbed schemes. I'll be just discussing 2 of them. So first is case weight perturbation. To perturb the contribution of each case, again vector of weights is used, where Wj equal to 1 means include, Wj equal to 0 means exclude an observation from the estimation. And this method helps us for checking the relative importance of the observations in the estimation procedure. Then we have response perturbation. Here, yi is our response variable. So this is perturbed as yi. So instead of yi, we write now yi plus wi, sy, where wi's are the weights, and sy is the standard deviation of the elements contained in y. And then we have explanatory variable perturbation. So this we apply on a particular explanatory variable xt, and we write xitw as this. Again, we are adding weights and standard deviation term to this. Then residual analysis, one is sensitivity analysis. So residual analysis can also be applied. This is for checking the assumptions of the model, validity of the data, studying the departures from error assumption, and identify the outliers. So various types are present in literature as suggested by Collett and Ortega et al. So there are 2 types of residuals. First ones are martingale residuals. which are proposed by Barlow and Prentice and Fleming and Harrington. And then Thurno et al., they introduced modified deviance residual. This is also known as martingale type residual. Now we consider this application. We consider a bone marrow transplant censored data, which we have taken from this Klein and Moschberger book for this model. Our data set consists of times to death or relapse for 15 patients with bone marrow transplants for NHL and are given an allotransplant from an HLA match sibling donor. Now, our motive is to find the impact of covariates on the logarithm of death or relapse times. So there are two covariates there. Sorry. Two covariates are X1 and X2. And first one is the pre-transplant Karnofsky score, and X2 is the waiting time to transplant. So the model is YI, because there are two covariates, so we have two regression coefficients, xi1 plus beta 2, xi2 plus sigma zi. Now this I is varying from 1 to 15 here because we have 15 patients. And these are the errors, and Z1 to Z15 are independent random variables whose PDF is again given by pi, which was shown in 3. Now we have reported the MLEs of the parameters and their standard errors for these three models, LGI-GW, LGI-W, and LI-W. And p-values are also shown. So these are the results for LGI-GW, and p-values for the regression coefficients are these. And this means regression coefficients are significant. Then second is for the model LGIW. So for these we get the estimates and the standard errors. In this model, my alpha is 1. I know that, so I'm not writing the standard error here, and p-values are again for the regression coefficients. Then LIW has only 3 parameters, and estimates are given here because in LIW, alpha and gamma are 1, both are 1. And here again, our regression coefficients are significant. So after finding the estimates, we compare these 3 models now. The one suggested by us and the 2 existing in literature. And whenever we have to compare models, we use these criteria: AIC, archaic information criterion, then Bayes information criterion, archaic information criterion. This, the model which has the lowest AIC, BIC, or AICC will be the best. So in this table, we can see the lowest values are happening for LGI-GW. So which means LGI-GW model is better than these 2 models. And if I wish to compare through likelihood ratio test, if I want to compare LGI-W with LGI-GW, so in LGI-W, my alpha is 1. So my H0 is alpha is 1, and versus alpha is not 1. And the likelihood ratio statistics comes out to be this with my p-value as 0. And we reject the null hypothesis. That is LGI-W fits the data set, accepting that LGI-GW will fit the data set. Now in sensitivity analysis, we have obtained measures of generalized Cook distance and likelihood distance, and their values are shown in this table. So actually I'm considering this table is showing only 10 values. So if you look at these.
Madam, please conclude. The time
okay, sir. Okay. So then we plot the index plots also. And if you look at the index plots, at 5, the generalized Cook distance is maximum. And here actually it is being shown at 2. So they are the most influential observations. Then for case weight perturbation, again, plots show that 2 and 5 are the influential observations. For response variable perturbation, again, to be an influential observation. For residual analysis, also again, we have the highest residual for 5. So here again, we can conclude that 5 can be taken to be a common influential observation. And when we see the impact of detected outliers, I'll skip this theory. I'll just show the 5th observation is now the influential observation. So we find the estimates relative change. If I delete 5th observation from my data set, then this is the relative change. So I deleted 5th and I have shown the estimates and the relative changes. So conclusions are that LGIGW is the best fit to this model, to this data set. And we have also carried out the diagnosis analysis using sensitivity and residual. So these are my references. And thank you.
Thank you, ma'am, for such a wonderful talk. Any questions? Any questions? Okay, so let us thank Professor Kanchan Jan. Now, our next speaker is Professor G. Srinivas Rao. Let me introduce him. Professor G. Srinivas Rao is from Department of Mathematics and Statistics, University of Dodoma, Tanzania. He has received his BSc in 1985. He has completed MSc, MPhil, PhD from Acharya Nagarjuna University. His research interests include statistical inference, quality control, and reliability estimation. He has published more than 125 articles in different peer-reviewed journals. Now I would like to invite Professor G. Srinivas Rao for delivering the lecture on exponentiated inverse Rayleigh distribution to develop the generalized multiple dependent state sampling plans. Sir, please continue.
Thank you very much, madam.
Thank you.
For a nice introduction to me.
Thank you, sir.
Okay.
So please continue.
Let me share. Can you help me to share?
Yeah. Present now. Present now. Select the option called present now. Right side lower. Right side lower.
Right, so okay.
Yeah. First, you have to open your presentation.
Yeah, it's open.
A tab it to be selected. Present now.
And then window. A window.
Present.
And then a window.
Yeah, it's come. It's coming.
Still not come.
Window, you can go there and select your one. There should be desktop and your.
Yeah, it's coming now.
Okay. Very good evening to one and all.
You have to select the presentation.
Sir?
Presentation you have to select.
Your presentation.
First you have to open the presentation.
Yeah, I have already opened.
Yeah.
Now you just open a PPT, sir.
Select that.
Yeah, just click there. No, down. Just click the PPT. Present. Down. You just open a PPT, sir.
Yeah.
No. You just open our PPT, sir. It's in it.
Go there on window and then select that.
Top menu, bottom menu, sir. You already opened, right? That mathematics.
Yeah. On your window, you can see the desktop as well as your presentation. Go to your presentation.
Sir, you already shared, sir. No issues. You just open your PPT, sir. You just open your file. Which file you want to share? You just select it. You just open the file, sir.
Is it coming?
No.
He has to minimize this screen.
No,
Minimize the meeting screen.
You just minimize this Google Meet screen.
Okay.
And then click on whatever you have opened.
What about now, madam? Is it?
No, it's showing empty screen.
Black screen is coming.
Sir, otherwise you just stop sharing, sir.
Sir, you select the tab mathematics.
Sir, 1 minute. Sir, 1 minute, sir. 1 minute, sir. 1 minute, sir. Sir, just stop sharing, sir. Just click stop sharing.
Oh.
Right.
Yeah, just wait. You just wait. Now you just go to the present now. Sir.
Sir.
Now you just go to click the present now, sir.
Present now, I clicked.
Yeah, there is an entire screen is there. You just select the entire screen.
Okay.
You just wait, sir. No, it is still not there.
Then minimize Google Meet screen.
Yes, sir. No, wait. Now you just minimize your Google Meet screen browser. Minimize top. Yes, that one. Yeah. Just proceed, sir.
It's okay.
You just proceed, sir. Yes, sir. You just skip a slideshow if you want.
Okay.
Yeah, that yes, sir. You just click bottom. Yeah. That one. Yeah. You just continue, sir.
Okay. How good.
Okay, sir.
Continue, sir.
Very good evening to one and all, and thanks to the organizers for joining us at a 4 days virtual conference on Professor C.R. Rao School of Thought on Statistical Sciences at Pondicherry University on the eve of Professor C.R. Rao's birth centenary year. I feel it's a great honor to me to participate in this conference, being a invited speaker. At this juncture, my abundant thanks to the Professor Tirupati Rao Garu for his encouragement and support extended to me. Today's my topic is, sir, am I audible?
Yes.
Okay. Today's my topic is exponentiated Rayleigh distribution to develop a generalized multi-dependent state sampling plans. My objectives of the study is designing of generalized multi-dependent state sampling plans for generalized Rayleigh distribution, the necessary measures including the operating characteristics functions are derived, the plan parameters of the proposed test plans are determined through the nonlinear optimization solution. The proposed sampling plan is studied for a minimal sample size subject to the specified requirements of the consumers and producers risk. The efficiency of the proposed plan in terms of sample size are discussed for the existing sampling plans using the same level of all parameters. The advantage of the proposed plans are discussed through simulation and real data from the industry. Introduction of the topic. The high quality is the main target of all companies in the world nowadays. There is a competition among the industries in producing the high quality products. To manufacture the high quality of the product, the producers are very careful in purchasing the raw material and testing or inspection of the products at each stage of the manufacturing of the product, or we can say that the process, manufacturing process. Therefore, the inspection of the raw material to the finished product is an important activity to maintain the high quality of the product. For inspecting the product, it is not possible to check each item at every stage of the production process. Therefore, inspection in the industry done through a well-defined acceptance sampling plans. A sampling plans plays a role like a guide to select a suitable random samples and acceptance number at a specified parametric values. As for the lot sentencing purpose, a random sample is selected from a lot of the product. There is a chance that a good lot is rejected. Usually we call it as producer's risk. And the bad lot may be accepted. Usually we call it as consumer's risk. The sampling schemes are designed with minimizing both the risk during the inspection of the lot. More commonly, a single sampling plans are used to design the sampling schemes, which is simple to inspect a lot of the product. However, the use of single sampling needs a large sample size for the inspection of the product. The inspection cost is directly influenced by the sample size, that we know that. Larger the sample size means the more inspection cost for the lot sentencing. The various sampling schemes such as double sampling, repetitive sampling, resubmitted sampling, sequential sampling, and multi-dependent state sampling plans are more economical than the single sampling plans. A tremendous works were done by numerous others in multi-dependent state sampling plans. It's my pleasure to name some of the outstanding authors in this area of research, namely Muhammad Aslam, Jan, Professor R.L. Kantam, S. Balamurali, Z. Govindaraju, etc. They are my direct or indirect teachers in these specific fields of sampling plans and the control charts. Fortunately, I got an opportunity to work with them for various papers and are published in well-reputed journals. I should thank them for their encouragement in this research area. In the multi-dependent state sampling plans, to decide about the state of the process, in addition to the current subgroup information, we consider the previous subgroup information. This scheme is more efficient than to the single sampling plans. Wortham and Baker 1976 initiated the multi-dependent sampling plan scheme. Some more contributions can be seen in Soundarajan and Vijayaraghavan 1989, 1990, and Karlamani and Govindarajulu 1992, Govindarajulu Subramani in 1993, and also Aslam did a lot of work from 2013 to 2017, number of papers. Especially Balamurali and Gan in 2007 designed the MDSS plan for the normal distribution. Yan et al. Worked for these sampling plans using the coefficient of variation. Balamurali et al. 2017 proposed this sampling plan for Weibull distribution. Balamurali et al. In 2017 used the generalized inverse exponential distribution to modeling the multi-dependent state sampling plans. Who worked for the MDDS plan for the one-sided process capability index. Balamurali et al. Also studied for the multi-dependent sampling plans to reduce the inspection cost. More recently, with the collaboration of different authors, I have done more work on the generalized multi-dependent state sampling plans. They are Raja and Aslam 2019, Rao et al. 2019, Aslam et al. 2019, Rao et al. 2019, Aslam et al. 2019 formulated the generalized multi-dependent state sampling plans for various schemes. Of course, there are some other latest works done by the Balamuralins and others. The chief advantage of multi-dependent state sampling plan, generalized multi-dependent state sampling plan over the MDS scheme is as follows. To make the conclusion about the lot, whether to accept or reject based on the GDS scheme as if at least K out of M preceding accepted lots are considered to make a final decision about the lot of the production process. Whereas MDS scheme consider previous M accepted lots to take a decision. Our objective is to propose generalized multi-dependent state sampling plans for the exponentiated Rayleigh distribution. The exponentiated Rayleigh distribution was introduced by Sarnath and Padaget. Actually, the Burr distribution, Burr in 1942 introduced the 12 different types of distributions to modeling the data. From all these 12 distribution functions, a more interesting distributions in the field of quality and reliability study are Burr 10th and Burr 12th distributions. In recent times, Sarlas and Pedget 2001 well thought of the two-parameter Burr 10th distribution by introducing a shape parameter, and rightly they named as a generalized Rayleigh distribution, or some people they call it as exponentiated Rayleigh distribution. Let T be the life random variable of the product follows a exponentiated Rayleigh distribution with the shape parameter alpha and the scale parameter beta. The CDF is given in equation 1. The median can be obtained as mu is equal to minus 1 by beta log of that expression, and it can be written as n over beta power 1 by 2, where eta is equal to this expression. The failure probability of the product when experimental time T0 is denoted by P, and it can be expressed as equation 2. It is convenient to determine the termination time T0 as a multiplier of a specified median life mu0. That is, T0 is equal to A times of mu0. The scale parameter beta can be written in terms of median mu. Hence, the failure probability in the equation 2 can be expressed as follows. The design methodology, the operating procedure of the generalized multi-dependent state sampling plan for a time-truncated life test is as follows. It has 5 steps. Step 1, select a random sample of n items from a lot, then put them on a test for a specified time T0. Observe the number of failures before the experimental time T0 and denote it as D. If the number of failures D is smaller than or equal to CA, then accept the lot. Reject the lot if the number of failures is larger than CR. And the step 5 is if CA is in between, if D is in between CA and CR, then accept the lot if at least K out of M preceding lots were all accepted with a number of failures before the experimental time T0 is less than or equal to CA. Otherwise, reject the entire lot. This design consisting of 5 parameters, namely sample size N and unconditional acceptance number CA, conditional acceptance number CR, K and M. These K and M are to decide the preceding lots. Our proposed generalized multi-dependent state sampling plan can be reduced to the multi-dependent state sampling plan if M is equal to K. And it reduces to the single sampling plan when M and K tends to infinity, CA is equal to CR is equal to C. So when you are studying the sampling plans, we have to study the performance. The performance study can be done by using the operating characteristic function. Here we can obtain the operating characteristic function of our model is PA of P is equal to equation 4, where small pa is equal to probability of D less than or equal to CA, and the plan parameters of the proposed plan can be determined by optimizing the following nonlinear problem. The nonlinear problem is minimize the N subject to the conditions using the producer's risk and the consumer's risk simultaneously. That is the 6th equation and 7th equation, and also additional condition is CR is greater than CA, where P1 and P2 values are given below. In order to find the design parameters of the proposed plan, the quality is represented in terms of ratio of true median life and the specified median life. In this approach, the quality level is measured through a ratio of its median life to the true median life, mu by mu over mu naught. To ensure and improve the quality of the product, the producers may use the median ratios. The probability gamma of rejecting a good lot is called as the producer's risk, and the probability rho of accepting a bad lot is known as the consumer's risk. At the instance of both producers and consumers, the inference is drawn from the proposed plan to develop a many may fulfill their specific risks, both producers and consumers. Under these two conditions, one is based on the P1 and based on the P2. Based on the P1 is we are taking the mu over the mu naught is 2, 4, 6, 8, 10, and whereas at the consumers may reject the lot at mu over mu naught is equal to 1. To determine those plan parameters, we use the following algorithm. A grid search method is used to obtain the nonlinear optimization solutions. This methodology requires setting up a grids in the decision space. The nonlinear objective function values are evaluated at the grid points. The points which corresponds to the better objective function values consider as a optimum solution of the nonlinear function. Better solution here means that minimum sample size N. The below algorithm can be applied. Step 1. Specify the values of gamma, rho, A is the multiplier, and the unknown shape parameter of the distribution. Step 2. Fix the values N is equal to 2, CA is equal to 0, and CR is equal to CA plus 1. And step 3, for a given values of gamma, rho, and multiplier A, the unknown shape parameter of the distribution with a specified median ratios mu over mu naught obtain the failure probabilities by using the equation 2 and denoted as P1 and P2. Step 4, obtain the acceptance probabilities of the lot at P1 and P2 using the equation 6 and 7 respectively and are denoted as PA of P1 and PA of P2 respectively. And the fifth step is determine the parameters for both the conditions in equation 6 and 7 are satisfied such that to obtain the minimum value of the n. And the last step is if there exists a value of n satisfying the equation 5, step 5, then the desired optimum parameters are n. Pick those optimum parametric values as n, Ca, and Cr, and for a fixed values of the m and k. Otherwise, repeat the steps 4 to 5 to get the optimum parametric values. The interpretation of the tables. Using the same algorithm, we got this table 1 and table 2. The interpretation of the tables. Using the above algorithm, the results are computed for m is equal to 5 and the values of the k are considered as 5, 4, and 3. You know that here k is equal to 5 and m is equal to 5 means our plan becomes the multi-dependent state sampling plan. That's why we consider k value as 5, 4, and 3. Table 2 and 3 are given for the exponentiated Rayleigh distribution with a shape parameter of equal to 0.5 and 1.5 at a constant value 0.5. From these tables, we can draw a conclusion that if you observe carefully, so these ratios increases 2, 4, 6, 8, the sample sizes are decreasing in all the combinations. Similarly, this ratio is increases and the Ca, Cr values are also decreasing. And also when for a fixed value of m is equal to 5, and when you are running k value from 3 to 5, that means if k is increases, your this sample size n is increases. So here 20, here 23, and here is 36. Similarly, and also another observation is the consumer's risk, that is from 0.5 to 0.01. That means consumer's risk is decreases, then the sample size is increases for a specific combination. See here ratio 2, sample size is 20, and the ratio 2, 34, and at the ratio 2, that is 47, and the producer, that is consumer's risk at 0.01, and the ratio is 2, then its size is 81. The similar fashion is observed here, and also other parametric combinations. So there's an observation from the tables. And so from this, we can say that when you are saying that the m and k are equal, that is m is equal to 5 and k is equal to 5, we are saying that this is a MDS plan. Whereas m is equal to 5 and k is equal to 4, we are saying that our proposed model, proposed sampling plan, and here is also m is equal to 5 and k is equal to 3. This we call it as our proposed model. By observing the table values, we can say that our proposed model is more efficient than to the existing sampling plan.
Please conclude, sir.
Okay, sir.
Please
And
conclude, sir.
okay, sir. 1 minute. 1 minute, sir.
Okay. No problem. Carry on.
Okay. A real data application. To illustrate our methodology, we have taken a real data from the Cardiaro et al. 2017. These are the 30 observations related to the precipitation, These data sets are these, and the data to apply this model, first we have fitted this model, and we have applied the QQ plot technique, and also we are estimated the parameters of the distribution by using the maximum likelihood estimation, and we got the alpha value is equal to 0.9018, and we applied the Kolmogorov-Simrose test, and we got the p-value is 0.9943. It shows that for this real data, our model, our distribution is well fitted, and it shows that the graphical presentation of the fitting of the model. And to demonstrate the model, the proposed sampling plan, assume the specified median time to the precipitation in 2 inches. That means mu naught is equal to 2, and the experiment termination value is 1 inch. That is T naught is equal to 1 inch, and mu naught is equal to 2. That implies that your A multiplier answer is 0.5. Also assume that the producer's risk gamma is equal to 5%, and consumer's risk rho is equal to 25%. If you see from the table 3, these corresponding values are 16, and CA value is 1 and CR value is 5. So for this, we can explain the methodology is like this. That means the implication of this methodology is when you take a sample of data, for example, here we have fixed the T naught is equal to 1. Before 1 inch, there are 3 values in the current plan, that is 0.05, 0.19, and 0.52. That means your D is equal to 3, and which lies between the 1 and 5. Therefore, we can accept the current lot. Whereas, if you want to take a final decision, you have to see the preceding 5 lots. Out of the preceding 5 lots, if 3 lots are accepted, then we could draw a conclusion that the lot of the product is accepted. That is the main advantage of this method. Instead of testing the 5 lots, we are testing only 3 lots. In multi-dependent state sampling plan, we have to test the 5 lots, whereas here we are testing the 3 lots. And this is the OC curve. It shows that the better performance than to the MDS plan and single sampling plan. And these are some references. And thank you very much, sir.
Thank you, sir, for a nice presentation. Any questions? Any questions? Okay, so let us. In case no question.
Can I get a clarification?
Please, sir. Continue.
Good evening, Professor. This is nice work actually. Estimating, determining 5 parameters in a sampling plan. It's a wonderful work. You have used nonlinear optimization. That's also a beautiful work. I want to have a simple clarification. The production process should follow the basic assumption upon which we develop sampling plan.
Yes.
So you have given real life data as observations from a situation.
Yes, sir.
Was it possible to test whether our assumptions are satisfied by the data, just like we test normality, like that our distribution is specified here, whether the observations satisfy that basic assumptions we have? Have you observed anything, or you have to?
Actually, these sampling plans were developed for the normal distribution.
Yes.
Later on, the different authors were extended to the non-normal distribution, because when you see any quality characteristics or any industrial data, they never follows to the normal distribution. And also lifetime experimentation, they start from 0 onwards. So that's why the people who are introduced the non-normal distributions, especially Balamurali sir they studied in the normal distribution. Then they extended that study to the variable distribution and inverse exponential distribution, and they studied the lot of work on the multi-dependent state sampling plans.
Exactly.
And in all these studies, they suggested that we have to develop a methodology for our sampling procedure, and the same procedure, if we take a real situation for a real data which follows to that particular distribution, then we can apply these sampling plans. If they are not follows to that distribution, then we cannot apply.
Exactly. That's what the last point I wanted to clarify. The particular distribution we have suggested, whether that observations following this pattern, how to test that? Did you made any efforts? That's my question.
Yeah, even now we are suffering the same situation. My PhD student, he collected the data from the beverages, and that data we expected some distribution, and that data does not follow to that distribution. Now we are struggling to find which distribution follows to that data, and we are struggling. So like that.
I do accept your statement. It's a big problem, and in our environment, it's very tough to get real life data. You are right.
Yes, sir.
I accept.
Yes, sir.
Thank you.
Thank you, sir. Now let us move to our next speaker, Professor Manish Kumar Sharma. Let me introduce him.
So, Srinivasa, please stop sharing, sir.
Wanted the session to be a little earlier. If you are not interested to give me the time, I would like to give it up. Okay. I told you that I want it to be preponed. But if you are very stubborn that I cannot be changed, please close this one. I am going away. Okay. Is that okay with you?
Rahul.
For a request. I told you that I would like it to be preponed.
Sir, Manish.
No. If you don't want, doesn't matter. I don't care for making a paper presentation. You may think that my paper is not valid. If that is so, let me close that. I requested that I have to go out at 9 o'clock, and I wanted it to be preponed. So what is your problem?
Sir, voice is not audible properly.
No. I see you must have a consideration for the customer. Okay, all right. I don't want a present. Okay,
please.
That is okay with you? I requested that one can be preponed.
Please, I am requesting Manish Sharma. Sir, can you make it after him? Manish Sharma.
Yeah, why not, sir? Why not?
Thank you, sir. Thank you, sir.
Okay.
So our next speaker is Professor Lakshman Rao. Let me introduce him.
Now, take only one sentence for introducing me. Please don't waste your time.
Okay, sir.
I don't.
Our next. Now, I would like to invite Dr. H.K. Lakshman Rao to deliver the talk on the statistical methods for all uses, rampant misuses, and abuses of statistical methods in the current context.
Okay.
Thank you, sir.
Okay.
Please continue.
Thank you. I appreciate giving me this time now. I am near the tail end. I think the interests are also dipping down deeply. But let me just take my PowerPoint. I need some help in taking the PowerPoint out.
Sir, please click your present now, sir. Present now.
Okay. Is
entire screen.
my PowerPoint visible?
No. You just click the present now.
Now I am presenting now.
Now you just select entire screen.
I don't understand.
Entire screen.
Okay, I can make it entire screen. Please wait.
Yeah. Wait. You just click the entire screen. Please
wait. Is it okay? Is it okay?
Wait, sir. Wait, please wait, sir. Please wait.
Okay. Now I am not able to see you. I hope you are able to see me. I thank the organizers for giving me an opportunity for talking on the general topic, statistics for all. I will just quickly go through slide by slide so that I can finish the presentation quickly. Now, maybe I may be an outlier presenter.
We are unable to see you. We see your presentation.
Not able to see me?
See your presentation.
Not able to see?
Unable to see your presentation.
Sir, I can do the presentation from here.
Are you able to see my presentation?
I'll do the presentation from here, sir. 1 second, sir.
I wanted, you see, I have made some changes in my slides. I wanted to make the presentation from here. Is there any problem for that?
No, sir. Then you have to click on the present now, and after that another.
No, 1 minute. Let me do that.
When you click on the present now, there will be an option called and your entire screen. Click on that, sir.
Okay.
Entire screen.
Yeah.
Then minimize this meet.
No. Please
minimize or share?
No. Please click the entire screen, sir.
Should I minimize?
Minimize the Google Meet screen, sir.
See, I'm not able to get it. Now,
Ganapati, 1 minute. I'll speak to him. Sir,
no. I have my PowerPoints here.
Yeah, sir. You just click present now, then go to your entire screen. Once you click that, just click it on that, sir.
He has to minimize this window.
No, just wait, sir. Once he clicks, his screen should be available with. Yeah, now it is available, sir.
Yes, shall I make it full?
Yes, sir.
Yes, sir.
Yes, sir.
Just please have a little patience. I will make it.
Yes, sir. That one. Yeah, you just proceed, sir.
Yes, sir.
I want to go back to the Is it okay now?
Yes,
Yes, sir. Yes,
okay.
Sir. Now click the top.
Okay. Okay. Now I'm speaking out of my 40-year concern about how statistics is being used by people who do not have much background and appreciation to statistical methods and statistical techniques. Very unfortunately, statistics is being largely used by people who do not have much of grounding. Therefore, it has become a little problem for people to understand the whole situation. I would like to stress there is an urgent need to understand the environment, risks analytically and precisely. Therefore, statistics is very much needed now. Now, when we talk about understanding the totality, we go through a sample, that is how to understand things in a subtle way and go to the grass. Today, administrators, managers, and other people who are in the healthcare industry are not aware of what numbers that they are using. They are using according to their own whims and fancies and previous experiences and emotional contents. This is creating a lot of problem into the situation. Now, statistics helps us from looking at the micro thing and understanding the macro. I think this everybody must understand that we are looking at a sample, but sample is not the end. We are interested in the totality and the population. Sample helps us to understand the totality and population. Many of the reports that are coming up now, particularly in the media, they are making interpretation on the sample itself, not making a real projection to the totality. Therefore, this is creating a lot of confusion in the whole situation. Now, all of us should understand that we are deriving facts from figures. Figures are numbers, facts are thoughts and ideas. So based on thoughts and ideas, we take decisions, and numbers are necessary vehicle for driving these facts and figures. So sample is what is known to us. What is not known to us is the population and the universe. So from the known, we are traveling to the unknown. When we are traveling to the unknown, there is a possibility of error. We may not be very precise, but the understanding of the population with a small error is just enough for us to take decisions. And this idea must be conveyed to every decision maker, that whether it's a blood sample or a sample of a soil testing or sample of a transaction in an organization, all these are indications of what the totality could be. Now it is also necessary to find out how 2 or 3 variables are getting related and what are the interrelationship between the 2 variables. For example, the price and the demand. To what extent the demand of a product can be influenced by the price. If the marketer really understands this, he will be very cautious in fixing the price. So inter-variable relationships are inherent in statistics. Therefore, an understanding of statistical methods will help in decision making, whether we do our planning or implementing or carrying out monitoring and evaluating in the end. Always statistics is very important for us. Now it is we are here to utilize the available resources effectively and efficiently, and this is not possible unless we understand the situations numerically and be a little away from our emotional feelings. Now, therefore, I would like to stress that statistics is not confined to certain areas and certain people, certain professionals. It is applicable to everybody and everywhere. And today we are seeing lots of statistical fallacies in medical systems. I would like to share with you that I underwent an eye operation and got some eye drops. Now, the eye drop, 30 drop bottle cost 670 rupees. I asked the doctor, what is this, why it is so heavy? He says, this is a very important, this is very delicate, this is the only medicine that we have. I bought the medicine and then I opened, what are the clinical testing? Now, he says that we have carried out this test on 13 samples. It is a global product, and it proved 9 out of 13 found this satisfactory. Therefore, this was considered as effective. Then I took serious objection and sent to the manufacturer, and the distributor was in Bangalore, the manufacturer was in US, and they said this is not the way to test a drug for a global application, and it has to follow certain statistical norms before you market this product. Finally they said, yes, we agree, we have not applied statistical methods. However, our medical council has approved that product, therefore we are in the market. So when I sent this to the medical council, there was complete silence. This is what is happening in the hands of the non-statistical people. All these things are happening now. Now, the project management professionals do not know much of statistics. So we see lots and lots of failures in project management today because they do not apply, they do not understand the probability of certain things happening. Now, the Six Sigma practitioners today, Professor Murali may be there, Muralidharan, he is a specialist on Six Sigma training. Now, most of the people who get certificates are incapable of putting that into action in their work environment because their knowledge of statistics is very little. Their knowledge is just enough to get a certificate. Therefore, whole system is not working because lack of statistical appreciation, lack of statistical insights into the situation. even among research scholars, they take samples and carry out research, make hypothesis, test the hypothesis the way in which they find it convenient, but not following any statistical rules and regulations. This is not necessarily for people with statistics orientation. The research scholars in economics, psychology, sociology, their understanding of statistics is very little, and therefore their final interpretation and methodology is not up to the mark. These are some areas where we have to strengthen. Even stock market analysis, today also we had 1 or 2 presentations on stock market analysis. They do not see the probability of certain things happening. They have no idea of how a variation, how a mean value can affect the situations. Now, auditors and chartered accountants who are also working on numbers have no consideration to probabilities and the risk factors, and they need to understand a little bit of statistics. Even the corporations and the civic bodies are enabled to use the data that they have got efficiently. Let me just take 1 minute to say, I was taken as a statistical consultant to Bangalore Corporation, and I was asked to find out how the solid waste management can be managed better. So I studied the movement of trucks from Bangalore city to several areas and did nothing but simple normal distribution and the bell curve, and tried to bring down 236 trucks that were carrying solid waste to dumping grounds, and brought it to 110, and said that this is possible without losing any efficiency. We can bring down the number of trucks. Unfortunately, all the truck owners were the councillors of the corporation, and it did not get through because there is a lot of politics in the statistics. This is what I want to convey and tell. So today, statistics is in the hands of people, and in an environment where data is pouring in, statistical methods are not being efficiently and effectively used. So there is, I feel, this is my personal view, there is immense scope and opportunity for applying statistical methods, simple statistical methods, to utilize the resources in an optimum way. Now, this will help in improving the quality, reducing the cost, reducing wastages, and improving the safety in many areas. Now, the one more example I would like to say, I was working for a corporate hospital as a management consultant. One of the areas there was to control the inventory in the pharmacy. It's a 36-year-old corporate hospitals. They were losing lots of money in the pharmacy because they had to dump the outdated drugs because the person who was managing the whole thing was just a school dropout with a 30-year-old experience, and based on his own intuition, he was making the purchase order. There were a lot of stocks idling in the whole pharmacy. Simple using of normal distribution and the bell curve, we were able to control the order placement and inventory, and within 6 months, 7.5 lakhs were saved with this situation. We do not need sophisticated statistical methods to do things at the ground level. So, not necessarily we should go through the operations research tools and techniques. Even simple statistical tools, statistical methods can help us to find out where we are and what we should do. Similarly, in the healthcare system, in agriculture, in the infrastructure development, the people who are manning all these things have very little concern, very little appreciation for statistical methods. and applications. Therefore, things are not going in the way that we want. Now, what we call healthcare in the hospital is no more a health care. It is only a sick care. People are trying to treat the sick people. They are not creating any health system. If we can reverse the statistics and apply statistics for healthcare system, things can be largely improved. I have done some work on how yoga can help curing many diseases, taking some examples of people trying some yoga asanas and found extremely significant improvement in the whole thing. Without any medicine, people have been cured, people have been healed. So there are several such possibilities for us to understand what we are doing and why we are doing. Now, therefore, it is now necessary for us to do a little brainstorming on why and how statistics can be used, how hypotheses can be formed, how hypotheses can be tested. Now, I have done this work on Ayurveda, allopathic treatments, agricultural productivity by changing the distance between two cropping lines instead of total chemical fertilizers. Organic plus chemical fertilizers can give better yields and can give better control. I had the opportunity of working with ITC to find out how neem, organic based neem, is better than malathion, which is chemical based. So we did a work on about 1800 data points drawn from Andhra and Madhya Pradesh and tried to use a randomized block system and found that malathion is a better controller compared to neem, marginally better, but ultimately 14% of the chemicals were in the food grains, the Ashirwad wheat, but neem had no residual at all, but marginally its capacity to kill pests was slightly lower. So through statistical methods, the neem-based pesticides was approved as better than malathion. I had to make a presentation for the Agricultural Ministry on behalf of ITC, and they appreciated the way in which statistical methods are used, and now it has become a branded product in ITC. Now, they said that we do not believe an agricultural person saying this. We wanted a statistical analysis. This is what the Ministry of Agriculture and Warehousing wanted, and this is the way in which statistics has helped to establish a brand. Now I told you about
Please,
I just close in 1 minute. This yogasana and physiotherapy, these are areas where certain hypotheses can be formulated and tested for its veracity and situation. I do not want to go beyond that. We are now applying simple normal distribution and bell curve even for buying groceries to the house, depending on how much of utilization that are happening throughout the month. So I do not want to go beyond this. I just want to say that what are the actions needed? Focus is needed on data-based research and experience and hunch, gut feeling, personalized opinions must go to the background. It is necessary for us to train and bring statistical methods into focus. It is now important to teach statistics for non-statisticians rather than carrying coal to the same situation. So therefore, it is important that we conduct some international or national seminars on statistics for non-statisticians so that development can take place better and in a faster way. Now, Now, this is what I want to reiterate. Essentials of statistics to non-statisticians is necessary. Decision-making support systems and people who are working on numbers must be trained on statistics. So now it is possible for online learning, online teaching. This must be better used. And I am here to provide any support that anybody wants. I am available on bringing fundamentals and essentials of statistics to anybody that is want. This is a voluntary thing that I want to promise and tell you. And I wish to thank the conference leaders and particularly Tirupati Rao, who has given me an opportunity for me to share my random thoughts on this paper, which has no equations, which has no sophisticated formulas. This is a simple understanding that we can do much better if we can understand what is statistics, what is variability, what is a variation, how we can control the variation, what type of hypothesis we should make, what type of testing we should have, and how we can go about in utilizing statistical technology into our real life. So I thank Pondicherry University for this. When I was going through C.R. Rao's life history, and one of his ambitions was that statistics should enter to all fields, not necessarily those in the manufacturing and service sector. It must enter to every field. I think with this message, I would like to say that if we can try non-statisticians with the field with some data-based understanding, we will be doing honor to C.N. Rao at this point of time. Thank you, sir. I do not want to take much of your time.
Thank you, sir, for the nice presentation. Any question? If there is no question, let us move to our last speaker, Professor Manish Kumar Sharma. Let me introduce him.
Sir, please stop sharing here.
Dr. Lakshman Rao, sir, please stop sharing your presentation.
What did you say?
Sir, please stop sharing your presentation. Stop sharing.
Stop presenting, sir. Just click to stop presenting. Stop sharing or stop presenting, sir.
One minute.
Okay. So let me introduce our next speaker.
Welcome, sir. Professor Sharma ji, Professor Malik sir.
Good evening, sir.
Welcome.
Thank you, sir.
Sorry for the inconvenience, Sharma ji.
No, sir.
There are sometimes we have to face this type of people.
No, sir.
What is the output we got? We don't know.
It's okay, sir, but I think so. It is always
Mr. Rao, we continue, no problem.
Okay.
We have to.
So
our
our
next speaker is Professor Manish Kumar Sharma from Division of Statistics and CS from Sher-e Kashmir University of Agricultural Sciences and Technology of Kashmir, Jammu. He is a gold medal recipient in MSc Statistics by University of Jammu. Besides teaching, completed 3 projects as nodal officer or PI, and 1 project is going on. He has authored more than 65 research papers in various peer-reviewed international and national journals. He has authored 2 books, 4 manuals, 15 chapters. He has delivered approximately 150 invited lectures and talks in reputed institutions in India and abroad. He has presented research paper in more than 20 international and national conferences. He has 2 PhD and 2 MSc students have been awarded under his supervision. He is an executive member, reviewer, and member of various national and international statistical societies, organized conference, workshop, and short trainings. He has recently visited University of Dodoma, Tanzania, and delivered the invited talk and chaired 1 session during 3rd Statistical Conference organized by the Department of Statistics on World Statistics day. Now I would like to invite Professor Manish Sharma to deliver the talk on optimum exponential ratio type estimators for estimating the population mean. Sir, please continue.
Yeah, thank you very much, ma'am. Sudesh.
Thank you, sir. Sir, please share your presentation.
Yeah, yeah.
Yes.
I think so. No, is it visible?
Yeah,
Yes,
yeah.
sir.
It's coming.
It is coming.
I think so. It is right now. It is visible to all of you. So good evening to one
Sir,
and all.
your
Yes,
PPT
sir.
is not visible.
Sir, not visible.
Yeah.
Please minimize the Google Meet screen, sir. Please minimize the Google Meet screen.
Oh, fine. Okay, 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 okay.
Yeah.
No, it is okay.
No, 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 no. You just open the Google Meet screen and just stop sharing.
Make the process again, sir.
Sir, please do present now. Please click the
Just a
present
minute.
now.
Just a minute.
Yeah. Present now and select the entire screen, sir.
Is it visible?
Yeah, now we just select your PPT. Just minimize this Google Meet screen. Now you open your PPT, sir, in your desktop.
It is open.
It's open.
Just a minute. No problem. I will click again.
Yes, sir.
Is it visible?
No, no, no.
No, no. You want to you just stop sharing. Now you just click present now.
A window.
No, 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 not select a window, sir. You just select the entire screen.
Okay, okay, okay.
You don't select a window.
Okay, okay, okay.
Please select the entire screen.
Yeah.
He has to minimize. Okay, he's.
Yeah, now you just minimize your screen. Yeah, now just to open your PPT.
It's
Yeah,
okay.
it's coming.
Now it's coming.
Okay, okay. Sorry for this disturbance. Good evening to one and all, and thank you very much. First of all, I've through this conference I've interacted my friend Rao sir also, and Malik sir. I have seen him. So first of all, sir, this is the work we myself and my student we are working on this optimum exponential ratio type estimator for estimating the population mean. So I am very thankful to the organizers gave me opportunity to present this work on this virtual international conference on Professor CRO School of Thought 2020. So we all statisticians are celebrating and we always celebrate our doyen of statistics always blessing us, and he has very well said statistics is the key technology of the current times. So after the R.A. Fisher, so this modern statisticians have rightly said, and I'm feeling this also. So my outline of the work, we both my student and we are looking on some new ratio type and product type estimators. We are looking on that so that we should be able to minimize the mean square error. So this is the outline of the work. Ratio and product and exponential type of estimators I will discuss, and then some modified exponential ratio type estimator with using auxiliary information and numerical illustrations. And then we will discuss, I will discuss modified exponential ratio type estimator without using auxiliary information and numerical illustrations. And then dual exponential ratio type estimator and a numerical illustration of the same. So we all you very well know about this, the major aspect of sampling. One is the sampling procedure, and second one is the estimation procedure. Since we are working with the study variable to estimate the population mean, which is the main emphasis of all the statisticians and all the work we need to estimate the behavior of the population with the sample. So estimation procedure, y-bar we are using for estimating the capital y-bar. I would like to say y-bar. So this modification or revolution started after Sarra in 1963. He proposed y-bar is equal to k y-bar. He introduced k in there and modified estimators started. And we are all looking on that how to minimize the mean square error as the variability will be minimum, so we will be able to provide the precise estimator and we should be able to estimate the population with more precision. Estimation procedures, again, I would like to say we have classified with the auxiliary variable and without using auxiliary variable have played a vital role in this. So first I'm coming on estimator with auxiliary variable. Everybody know. So Cochrane 1940, he first to show the contribution of auxiliary information when study variable and the auxiliary variable are positively correlated with each other. So he proposed an estimator. So this ratio estimator, and it was more efficient, the sample mean estimator, under the condition that this ratio should be greater than 1/2, and if it is equal to, both are equal to 8. So under such range, I would like to say this estimator is better than the conventional estimator. And when both the estimator, when the study variable and the auxiliary variables, they are naturally correlated with each other. So under such condition, the Murthy in 1964 modified revisited the Robson estimator and proposed this estimator, and the condition is that this estimator should be greater with the range -1/2, and the range is this. So several researchers, Sodia and Devedi, Singh and Taylor, Kosh-Visian, and Sharma and Bhatnagar, Sharma et al. 2000, all proposed different type of estimator for giving more precise estimate of the population mean. So concept of exponential estimator also started in 1991. Bahel and Tuteta proposed exponential and ratio and product type estimators, and with the conditions that the ratio estimator should rise between this range, and whereas the product estimator should rise between this range. So they are more efficient than the simple sample mean estimator, mean unit estimator, as well as the ratio and product estimator existing. So Singh et al. 2009 again proposed a modified exponential ratio type using the information, and he proposed this estimator where A and B are a real number. So many works after that, Kadiller 2016, Zaman 2019, etc., are still working. Many are working on to give the modified estimator, so that the population should be estimated, population mean should be estimated with the more precision. So why we need exponential estimator? The question arises because these estimators are more precise than the ratio and product type estimator, which is already existing, and have more that we do not need a linear relationship between the auxiliary variable and study variable, whereas we need in case of the ratio and product estimator. So keeping such point on view, we are looking and still be working on some exponential ratio type estimator. So these two estimator we are proposing, and here P and Q we have taken as a constant, such that the MSC should be minimized. We have drawn the value, optimum value of P and Q using some mathematical concepts here. So simple random sampling without replacement scheme has been used here, and these the scales we have used it, and the moments have been evaluated, and these are the terminologies have been used for driving the bias and mean square error. So when these methodology have been applied for on the estimator, see we have got this mean square error for the proposed estimator, exponential ratio type estimator, that this is the mean square error up to order first, and optimum value of Q and Q are determined by using the differentiating of these mean square error with respect to Q and P, and considering it, and then we got an optimum value of this Q and found to be this. And when this value have been replaced in the Q and P into the mean square error, so we are able to propose the mean square error of the proposed estimator as this. And these this estimator have been compared with the mean unit estimator, Muran estimator, Bahel-Toteja estimator, and by Singh at 2009 estimator. So all under such condition, it was for, we are observing that the condition which we are finally getting is greater than 0. That means we can say that our estimator is proposed having more efficiency, have more precision. And for numerical illustrations, we have used the Shabir and the data of Shabir and Murthy, sir. So we have used the data for this, and the three populations have been taken, and these are the parameter of there, and these the estimator which we have used, and we have proposed the mean square and bias have been calculated. So the mean square error of the proposed estimator were coming same, whereas the bias were coming different. The bias are different. So, and when they are compared with the conventional estimator, so the proposed estimator having more precision, we are getting in all the three population different. So this estimator which we are proposing have more precision and having less mean square error. So similarly, we worked on some auxiliary variable. Why we think about different type of estimator. Sometimes this I would like to say before that I'm going to it. One point was also in our mind, which I will discuss later on. So this is the concept of Subramani 2016. He proposed the median based ratio estimator. So maybe an idea of that, since nowadays we are getting a voluminous data, and that data is suffering from many influential and outlier observations. But such type of estimator, if we will use, so they may be able to, we will able to give such more good estimator to handle such type of problems. Data have suffering from this problem. So the mean square and bias were this accordingly. And Watson 1937 proposed the linear regression estimator for estimating the population mean, because it is also used for comparison purposes. So here we have used two different estimator on the basis of median, and we have a study variable, and the median of the study variable have been taken not as the auxiliary variable. These median are using for the auxiliary, for the study variable only. So these two estimator have been proposed. Again, P and Q are looking so that this value should of mean square error should be minimized. So same methodology which I have discussed, discussed earlier. So same have been used, and similar concept for mean square error for the proposed estimator median base. Mean square error for both the estimator have been calculated, and Q and Q value again has to be found this, and the mean square error again by replacing P and Q value here. So we have got this mean square error finally. So this again estimator have been compared with the mean unit estimator Watson and Bahel and Toteja, and with the Cochrane and with the Subramani, all estimators. So under such we are getting the condition the proposed estimator will be better than the existing estimator under the condition if this condition should be satisfied. And according to this parameter, we have again taken a numerical illustration, different type of population for per mil Mokha source. We have used these populations, and these were the parameter of the populations, and whatever the estimator which we have proposed and existing estimator or ratio type and median based estimator, so they have been compared. Again, we are getting the same mean square error, but bias are different, and the efficiency of the proposed estimator coming better than the conventional estimator and the estimator which are already existing. Similarly, on the basis of that, we are looking on a different type of estimator. We can say dual estimator, which should work as a ratio and product estimator. So, as we know, for positively correlated, we need ratio estimator, and for negatively, we need product estimator. So, different authors have worked on that for dual estimator. Singh 2009, Taylor and Sharma, Sharma and Taylor et al., Sharma et al. 2018 proposed different type of dual estimators, which can be applied for both positively and negatively correlated variable on the basis of by keeping such point in view. So two dual exponential ratio type estimator here we have proposed. Here we are looking for P and Q such that the bias should be minimum, or the estimator should be unbiased, and we are looking for alpha and beta, what the value of the alpha and beta should be there, so that the these should be have a mean square error, minimum mean square error. Again, the methodology which we are using for the earlier proposed estimator, same has been used, and we got the biasness and mean square error up to order first for the proposed estimator as this. The estimator I would like to say TDE1 and TT2, which we have proposed, they will be unbiased if this condition for P should be hold and this condition for Q should be hold. And when the value of the P and Q have been replaced into the mean square error, and after solving that, the optimum value of alpha has been obtained. It should be lies between this range, and the optimum value lies in this range. Then the mean square error, and after that we are getting finally the mean square error of this form. And the proposed dual type estimator have been again compared with the existing estimator. So we are getting almost the conditions which are true mathematically, and as well all are coming greater than 0. So we can say the proposed estimator having more efficiency than the existing estimator. So for this, we have used the source of Sukhatme, Murthy, Oneka, and Gujarati's books, and different population have been used for comparison purposes. Two population where they are positively correlated, and for the population 3 and 4, we have a correlation negative. So this is used for product type estimator just to see the performance of the proposed. Just these are for the I would like to say ratio type of estimator. So different population have been taken, and this is by taking C just to see the efficiency of the proposed estimator in compared to the ratio estimator existing exponential. So we are getting our this mean square error less than the existing estimator, and the percent relative efficiency is also coming more as compared to the existing estimator. Similarly, when the proposed estimator compared with the product type of estimator, existing exponential product type estimator and product estimator, so again it has been observed the proposed estimator having more efficiency and more percent relative efficiency rather than comparing this. And moreover, the proposed estimator are coming unbiased also. So by keeping such point of view, we are still working on this estimate or looking on other estimator also. So this is the references which we have used for this. So this is from my side. This slides are okay. And very special thanks to the organizer for giving me opportunity, and special to Professor Rao sir. They always support to the support to our division and us for wherever we request to him. Thank you very much, sir.
Thank you, sir, for a very nice presentation. Any question?
So nice presentation, sir, regarding the ratio estimators. Ratio estimators have a significant place in any analysis. When particularly the concept of efficiency, we used to consider ratios as input on the lower side, output will be the numerator, and input will be the denominator. We can say that is a measure of efficiency. Okay. So most of the times efficiency is measured, expressed as a ratio estimators. So thanks to Professor M.N. Murthy for his pioneering works in 1960s, it has opened a broad area where the efficiency measures can be understood with the help of ratios, not like simple abstract numbers. So it's a very good area, sir, and your contributions regarding identification of the ratio type of estimators you have proposed, and finally you have verified that validity with different measures. It's very interesting, and your presentation is very lucid and good. I can say simply super. Thank you.
And thank you very much. I think so now after a very long time, virtually we are interacting with the Malik sir also. Special good evening to you, sir, also. And Rao Gadi, Srinivasa Rao sir, I'm seeing you after a long time.
Yeah, good evening, Dr. Manish, and really you presented nicely the work, and you suggested some good estimators with zero bias.
Yes, yes, sir. I am with my student. We are working, and still we are looking on some more good estimators, so that we should be able to give some unbiased as well as with minimum variance estimator. We should be able to present it.
So in the coming years, can we say that the proposed estimators will be sufficient?
Still no, sir. This work is, I think so, it will always be open, because right now we are facing with the different type of data. See, sir, what is the situation of the data? We have it before 10 years. Now, right now, whatever we do the survey, so these are the the lot of variation in the data is there. So I think so the still work is open, and it will be remain open, because variation is day by day increasing. No, it is not, we can say, decreasing. So there may be one of the reasons we should have to look on always on new estimators under different conditions.
Okay. So nice. Thank you.
Yes, Nazneen ma'am, please unmute your mic. Professor Nazneen Sharif. Nazneen ma'am, please unmute your mic.
Okay, Professor Sharma ji.
Yes, sir.
When I visited your university, I am in the very different opinion that the agriculture statisticians, what is their contribution. But when I visited your university and the course curriculum, when I have gone through, that you are not inferior to anybody, those who are pursuing mathematical statistics in all the other universities. So I changed my opinion that agricultural statistics is also doing a very good research in classical theory also. I have observed your course curriculum and the statistical inference, theory of probability, your distribution theories and sampling theories, design of experiments, and all these things are very robust mathematics you are using. And your course curriculum also, and very interesting fact I will tell you, I think last year, one of the students wished to got admission to university for her PhD. She did has an agricultural PhD and she got the first rank.
Oh wow!
Okay, she got the first rank, but non-fulfilling of that MSc statistics, we are unable to give the admission to her due to purely technical reasons. We are unable.
Okay.
But the performance of your student is very wonderful, and really I was admired with the way that classical theory is being pursued in agricultural universities also. Now agricultural universities now broaden in different fields. That is sericulture, agriculture, aquaculture, all types of now horticulture. Different cultures you are having, that Shere Kashmir University of Science and Technology and contributing a lot to the agricultural field, and it's a really good work, sir. And
thank you very much, sir.
I'm very much thankful to you for sparing your valuable time as well as your work. I
Yes,
know
sir.
you are in a very hard times, recent past. I have a information on yours because you are my close friend. I have
Yeah, thank you very much.
information. In
Yes,
spite
sir.
of all disappointing developments in the recent past with your uncle's side and your wife's side and all these things, you participated your time, and that shows your determination and dedication towards the research field and the academics. Really, we are very much grateful to you for your presence.
Yes, sir. Thank you.
And we will have together some journey in coming days. Thank you.
Sure,
sir.
sure, sir.
One small,
Thank
simple,
you. Sir,
simple clarification.
yes, sir.
What is good for the proportion is not so good for the absolute mean value.
Sorry, sir.
What is good for proportion that you have said, efficiency, estimation based on the proportion is better. Is it not applicable to the absolute value of the mean?
Absolute value of the mean.
Suppose I want to estimate the mean of the population from the
Right, sir.
sample mean, not through the proportion. Will it be less efficient?
Sir, we are estimating the population mean, but on the absolute value, I mean to say, I'm pardon, sir, I'm not getting about the absolute value.
So we are taking a sample